Hello, and welcome to VMware vSan Management and Operations. My name is Javier Menendez, and I will be your instructor for this class. I'm one of the many full-time instructors that VMware has, and I've been with VMware for 11 years now. We're going to start this class with this chapter, which happens to be called Course Introduction. And if you take a look in this page, what they try to tell you is, number one, that you're here to enhance your skills. But besides that, if you look at the first paragraph, in the first paragraph, notice it says, VMware vSan is a policy-driven, software-defined storage solution that is integrated with Vsphere. So what exactly we're talking about? Let's dissect that statement. Number one, you need to understand that when you work with a vSan cluster, you take X number of ES6 servers, minimum 3, maximum 64. And with those servers, you build a cluster. The big difference is that you don't rely on your traditional external storage. What we're talking about here is taking X number of ES6 hosts with internal drives. And through the power of software, we're talking about turning those internal disks into virtual shared storage. Now, when you take a look, dimension policy-driven, you need to understand that vSan is controlled with virtual machine storage policies. We have a default policy. That policy is called FTT1, failures to tolerate equals 1. That means that if you create a VM and that VM uses that policy, that VM will be a two-way mirror. You don't have to use that policy. You can create others. You can make a VM, use different RAID levels, for example, RAID 5, RAID 6, RAID 10, even RAID 0. We can create additional policies, some of them which are specific to stretch clusters. In this class, we will deal with all those policies. Not only that, when it says integrated with Vsphere, we're talking about that vSan does not rely on external appliances. This is built into the kernel. Having said that, it requires a separate license. And if you take a look at this page has the goals of this class. So the idea here is simple. We're going to spend a lot of time talking about this product. As we go through the chapters, one of them will deal with the ES6 server itself. In a nutshell, we're going to be talking about best practices, do's and don'ts, things to look for, things to avoid. We're going to be talking about patching and potentially upgrading your vSan cluster. That's why you see the reference to Vsphere Lifecycle Manager. Besides that, you can see we have a whole chapter that deals with vSan resiliency. So we're going to be talking about that. What to expect when you have a failure or potentially multiple failures. We have a whole chapter dealing with virtual machine storage policies. And for example, what happens if you try to modify a policy that happens to be in use? Or perhaps what happens if you try to delete a policy if the policy is in use? By the way, hint, that will fail. Not only that, we are going to be talking about best practices when it comes to putting a server in maintenance mode. We're going to talk about all the choices that you have with vSan. For example, we're going to explain the difference between full data migration, no data migration, and the default option. In a nutshell, the default option makes you move the bare minimum in order to make sure that every VM can continue to be operational. So that is called ensure accessibility. We have a whole chapter where we learn how to monitor the vSan cluster. Another one that deals with troubleshooting a vSan cluster. We have a whole chapter that deals with two-node clusters and stretch clusters. And besides those chapters, we have chapters that deal with new features. vSan 7.0 Update 1 has a lot of new features. If you look at the bottom of this page, we have a chapter that deals with vSan native file services. That is not really new in 7.0 Update 1. It was introduced in 7.0, but it was enhanced in 7.0 Update 1. We also have another chapter that deals with the concept of vSan Direct. That is new in 7.0 Update 1. And as I go through the class, I will be doing a series of demos So please make sure you pay attention to the demos. Now, when we look at this particular page, this one has a list of all the chapters. So we start with the course introduction, and we finish the class dealing with native vSan file services. You're going to finish this class with a lab. And in that lab, you're going to set up a series of appliances that will control file services. And through those appliances and containers, you will be creating NFS or Samba shares. And you're going to be sharing those shares with non-ESXi hosts. Now, when you look at this page, we have this page in every single one of our classes. So as you go through the labs, you're going to notice that at different times we use different fonts. For example, we use monospace bold when telling you to execute a command inside of a VM. For that matter, we use boldface to let you know when you have to click on a particular tab on the Vsphere client. And if you look at this page, in this page, all we try to tell you is that with every release of vSan, VMware makes available a lot of different guides and PDFs. You can always download these guides by either going to docs.vmware.com or, for that matter, storagehub.vmware.com. The ones for Vsphere in particular can always be found in docs.vmware.com. But the ones for vSan happen to always be located in storagehub.vmware.com. Now, when you look at this page, besides talking about PDFs or guides that you should download, in this page we also recommend the communities. Every time I teach a class in person or online, I always tell my students that they should join the communities. This way you can log in and you can interact with your peers. You can learn from your peers. You can ask questions and so on. Now, when you look at this page, we also mentioned the support page. Notice https vmware.com support. We also mentioned hands-on labs. And this is something that you want to remember because you can test drive our software for free whenever it works for you. One of the most common questions is, when do I lose access to the equipment, to the kit, to the lab? And officially, you lose access in a normal class when the class is over. Having said that, like I said, you could always go to Hands-On Lab and test drive our software for free. And we also mentioned the education page. So when you go to this particular page, here we mentioned vmware.com education. Now, if you go to that page, very quickly you will realize that VMware has different types of classes. We have classes on vSphere, on vSan, NSX, VRA, VROPS, and so on. And as an instructor, sometimes I teach in person, sometimes I teach from home. And also, if you go to that particular page, you will see that we have classes on demand. Now, when it comes to certification, a lot of people come to class because they want to become a certified vSphere administrator. Now, when you look at this page, we have different types of certifications. Most people typically mention the VCP exam. So when we're talking about VCP, we're talking about VMware Certified Professional. Above that, we have something called a VCAP exam. And as you can see on this page, VCAP is an acronym that stands for VMware Certified Advanced Professional. As an instructor in my case, I have a couple of VCPs and I also have one VCAP. We have different types of VCAPs. The one that I happen to have is the VCAP Deploy. There's another one called the Design. If you get those two, you become a VCIX, that is an implementation expert. And at the very top, we have VCDX. A VCDX, as you can see here, this is an acronym that stands for VMware Certified Design Expert. This is typically something that architects want to achieve, consultants perhaps. But most instructors typically just go for VCPs and VCAPs as well. One of my friends has a VCDX, but But again, most people typically stop either with a VCP or potentially, again, in some cases, with a VCAP exam. Now, when it comes to vSan, we don't have a VCP for vSan. But if you have a valid VCP, you can always go and take the vSan Specialist exam. If you take that exam, if you pass, immediately you become a vSan Specialist. The latest version of that particular test, as you can see here, is vSan Specialist 2020. Now, what follows is a quick video, and this video will show you how to use your lab. It will explain to you how to use the VLP environment. Thank you, and I will see you after that video.
Welcome everyone. This is Joe Cooper from VMware Education, and I'm here to walk you through the VMware Learning Zone lab environment for your courses. Hopefully doing this and watching this little walkthrough will make it a whole lot easier and answer a lot of your questions before they even come up about the VMware Learning Zone. Once you've enrolled in a course, you'll see the list of all of the different types of content that we have for your particular course. In this case, I'm looking at the Vsphere Install, Configure, and Manage version 6.7 course, where there's some on-demand content, there's the lab, there's the assessment, and the evaluation. We're here to focus on the lab. So once you've logged into the VMware Learning Zone, and I'm going to assume that the fact that you have found this video tells me that you have logged in, okay? It's at vmwarelearningzone.vmware.com, okay? Hit the play button, and what'll pop up is the lab environment here. Now, it does take some time to get the labs fired up. At this point, the system is actually deploying an entire virtualized environment for you. So you should expect, depending on the course that you have enrolled in, for this to take a significant period of time in some cases. Okay, like it says over here on the right-hand side where your entire lab manual is, this could take as long as 10 minutes. Okay, so make sure that you're patient with this, and when we come back, we'll walk you through the process of actually completing these labs and actually also getting some help when you need it. Well, that didn't take very long at all. Now, let's have a look at what we've got here. Notice that I'm in a browser here, and there's a bunch of stuff going on. I've got a bunch of applications, and I've got a desktop system right here in the middle pane, and it gives me some notes, okay? You'll note that what we are looking at here is a host name called student-a-01, and for most of our courses, this is where you'll start by doing the labs, okay? You'll notice a few things on here. On the left-hand side, we have a console, and this gives us access to all of the systems that make up your lab environment. In this case, I have a domain controller and access server. This also will typically act as your default gateway. For the Vsphere Install, Configure, Manage version 6.7 course, I've got 2 ESXi hosts, I've got a vCenter server, and I've got the desktop that I'm working on right here, Student A01. And I can actually switch between the consoles on any of these systems. Notice when I click on this particular console, as it loads, it will actually be an ESXi host, and you can see that right now, this host is actually currently firing up. So again, be patient with this. Even though you've gained access to the system here, okay, student A01 is fired up and you're logged into this, the rest of the systems may be still currently starting. Okay, so this console gives you an idea as to whether they have finished starting and you're ready to begin doing labs. Let's head back over to student A01 and we'll collapse the console tab and we'll look at a few other things. I actually like to view this in a full screen mode. So let's go ahead and we can maximize this. And if you're really clever about it, you can also hide the ribbons and things like that in your own browser if you like, or you can always scroll up and down. Note here though, that if I'm scrolling up and down, that I don't necessarily have full access to the menu bars and things like this on the bottom of the screen. Okay, so be aware of this. You may actually want to move into, for example, you can exit full screen mode here. Let's do that. Exit maximized mode. Okay. You can place this in the center of the page if you like. Okay. There's lots of different things that you can do with this. Also, note that you can, on the right-hand side with your manual, notice, first of all, there's 123 steps or 123 pages in this particular manual. Okay. You can increase the font size. Okay. Don't forget that you will have a scroller here. Okay. You can create a floating window for this that you can drag around if you like. You can change the pages using the arrows and things like that. Very nice. Lots of different ways to manipulate this window. Note that if you want to actually collapse this back to the side, just hit the X here and you can expand the manual again. Now, as you begin doing work in the labs, you will notice that as you go through these, you'll start a lab and that there will be a guide me video for each of these labs. So if you get stuck in any of these labs for any reason, don't try to, for example, open a console and reconfigure the entire environment. Okay. One of the things that you can definitely do is go through the guide me labs for each of these labs here. Okay. So you'll note you've got a number of these labs. All of them have a full guide me video, and it'll walk you through the process of each of the more complex components of
identified
the labs
by VMware ESXi, top left.
Now, if you're still stuck, there's always live help available for you during regular business hours. Okay. Don't forget, scroll up to the top of the screen and go ahead and find the help tab. There are a number of support options that are here. Okay. There are tips. You can download the user guide here for the VMware Learning Zone lab environment itself. Okay. Let's take a look at some of these support options. You can test your speed. If you're having trouble here at all with the environment, if it seems slow to you, you can head over to the speed test, where it actually allows you to start a test looking at all of the different components that make up the performance in your environment. Notice the speed of the learning zone, cloud speed, cloud latency, and VLP latency. So these are all different components that make up the performance in your environment. You can also email education support at edulabssupport@vmware.com. Okay? And you can have a look at some of the troubleshooting FAQs. Now, when you are done with the course, okay, you have the ability to end the particular lab setup. Now, you've got 30 days for most of our courses to complete the course and all of the labs, like it says here. Okay, you can exit the labs and return later, or you can hit the end button. Now, if you hit the end button, you are done with these labs. Hitting the end button says, I'm done with the labs. I'm done with the class. I've completed all my labs, right? Once you hit that end button, you cannot come back to these labs, even if you're within that 30-day period for which you have access to the class. Okay. Also note here that it says that in this case, I have not met the criteria for completing the class. You actually have to hit at least 50% of the entire lab environment in order to do this. So please keep that in mind. Here's an interesting trick. As you're going through the labs, the lab manual will give you things like credentials, or may have a series of commands that it asks you to type in, or set up a series of scripts. Okay? If you highlight text in the lab manual, you're able to drag that text into the console, where it'll actually fill that straight in for you. So you don't need to even worry about copying and pasting. A drag and drop does a great job, and then allows you to do things like log in to the Vsphere environment. Oh, and one last thing. Don't forget, during normal business hours, you can chat with support. It's Inderg. Well, that does it for me. I hope you are really enjoying the online classes and you're having a good time with these labs. Of course, you can always reach out to us if you need any further support. I thank you for your time and attention, and have a great time. Take care. Bye-bye.
Okay guys, welcome back. Hopefully you enjoyed the previous video. Hopefully that helps you understand how to use the lab and the whole setup. Let's finish this video. And after this, we're going to start with the next chapter. The next chapter is called vSan Node Management. And it's a pretty cool chapter. It deals with different topics, such as hardware compatibility, the concept of updating and or upgrading your vSan cluster, the idea of using Lifecycle Manager to upgrade, for example, firmware and driver version. So enjoy, and I'll see you in a few minutes. Thanks again. Hello, and welcome to vSan Node Management. In this chapter, we're going to spend a few minutes talking about your ESXi server. We mentioned earlier that in order to build a vSan cluster, you need to have X number of ESXi servers. We mentioned earlier that we're talking about minimum 3 ESXi hosts and maximum 64. But it's not just the number of ESXi servers that you're going to use. It's what kind of ESXi server you're going to use. So in this chapter, we're going to talk about certain do's and don'ts and certain best practices. So let's take a look at this next page. When you look at this page, in this particular page, they try to tell you that since vSan can run extremely IO-intensive workloads, it is once again critical that your hardware is supported. One of the things that I constantly emphasize in class is that you want to make sure that every piece of hardware is supported. You want to take a look at the hardware compatibility list. But if you look at the rest of the statement, here it says performance characteristics and hardware stability cannot be guaranteed if you do not thoroughly test devices, firmware, and driver combinations. So it's not just about the hardware. As you can see here, we're also talking about drivers and we're also talking about firmware. Now, if we go to the next page, here we have the goals for this chapter. Now, when you take a look, we're going to start by spending a couple of minutes talking about the criticality of selecting the appropriate hardware. Once again, making sure that every piece of hardware is supported. If you take a look, we're also going to talk about potential changes that you may want to actually do at the BIOS to ensure that you get optimum performance. Then, We're going to talk about the importance of driver and firmware compatibility. And then lastly, we'll talk about how nowadays you could use Lifecycle Manager to update firmware if needed. Now, when we look at this page, in this page, we can see that we start this topic. And again, here, we're talking about verifying hardware compatibility. In this page at the very bottom, you can see that we show you a URL. And if you never visited the URL, I highly recommend that before you build your cluster, or potentially even if you already have a cluster in place, you visit that site. In that site, for example, you can see what kind of servers we support. And we're talking about servers from different vendors, not just from one vendor. Some of our customers use, for example, Dell servers. Others will use Supermicro, HP, and so on. Now, when you take a look, one of the most important things is that you take a look at every single component. Now, in the old days in particular, people would try to build vSan clusters without necessarily looking at the hardware compatibility list. And the biggest problem in the old days is that when you did that, perhaps everything would work fine until you had a problem. And then if you had a problem, then that's when you would notice that, for example, you picked the wrong controller, because then your controller perhaps could become your bottleneck. Now, when we look at the next page, as we talk about controllers, I always emphasize to my students that if you can, number one, you want to have servers with multiple controllers. Now, let's think about this. Let's say that we have a 3-node cluster and we use 3 servers, and each server has one controller, one HBA. Now, the idea is if you build a vSan data store with 3 hosts, assuming that all the hosts have the same number of disks and the disks have the same capacity, if you lose one controller, right off the bat, you lost 1/3 of your capacity. Now, if you had 2 controllers per host, if you were to lose one controller, assuming that you have the same number of drives behind each controller, then instead of losing 33% of your capacity, you would be losing half of that. So more controllers ideally is better than one controller. But besides that, as we talk about controllers, 2 things you want to consider. Number 1, what is the queue depth of your controller? And number 2, did you configure your controller properly? In this page, you can see that when it comes to controllers, depending on which controller you select, you have 2 choices when it comes to configuring the controller. You want to make sure that our software sees every individual disk. So, depending on the controller that you select, either A, you need to set up the controller in pass-through mode, or B, in RAID 0 mode. But what you want to remember is that with our software, we are performing software RAID. So you do not, and let me emphasize this, you do not want to set up hardware RAID and then combine it with software RAID. That would be overkill. Also, that would limit the flexibility that our software has when it comes to choosing where to store the data. So the idea is no matter which controller you have, you want to make sure that once again, we see every single one of the drives. Now, if I go to the next page, here, we're talking about storage controller performance. So we've mentioned that you want to pick the right controller. We've mentioned that you want a controller with a high queue depth. The question is, how can I tell what is the queue depth of my controller? And this is something that you can see with the command line, with one of 2 commands. Now, if you haven't built your cluster yet, you can see the controller queue depth with ESXtop. I'm going to do a demo at the end of this chapter, and I'm going to show you that. But with ESXtop, you can go to a host, you can type ESXtop, and then you could type D as in disk. Now that will show you all your HBAs. But one of the things you need to remember is that ESXtop does not show every single column. In some cases, you have to add columns. To add a column, you want to press F. And if you press F, Then you see additional columns that you could potentially add. Among those columns is the one that you would need in order to be able to see the controller queue depth. And you want to make sure that you have a controller that has a really high queue depth. I would say 1,000 or higher. If you take a look at what we support and don't, I would assume that in the year 2020, I haven't looked at that recently, I would assume that the minimum we support is 512. But I can tell you I've had students that have shown me the output of another command that I'm about to mention. And that command shows, for example, a queue depth of close to 10,000 in some cases. Now, the second command only works if you already built a vSan cluster. The second command is an ESXCLI vSan command. If you never use these commands, all you have to do is connect to one of your hosts, type ESXCLI vSan debug, and in there, you have a namespace called controller. If I type ESXCLI vSan debug controller list, this will show me every single one of the controllers that I have. Not only that, that command will tell me which one I'm using for vSan, and it will also show me the controller queue depth. So please remember those two commands. Now, when you take a look, here we make certain suggestions when it comes to how to set up the controller. So make sure that you read every single one of these statements. We've mentioned already that multiple controllers is usually better than one. Once again, you want to think worst case scenario. You want to remember what would happen if I lose a disk or if I lose a controller. So if you have multiple controllers per host, once again, should you lose one of them, the impact on your vSan data store is going to be less compared to if you have only one controller. Notice, here it tells you at the very bottom of the page, the business wants better performance, which typically requires multiple controllers. So if you think about it, when it comes to best practices, think multiple controllers instead of one, and also multiple disk groups instead of just one disk group per host. Now, when we look at this page, we've mentioned that there's certain things that you could actually modify both at the BIOS and with the Vsphere client in order to make sure that you get high performance. Now, when you take a look at the very top of this page, you can see in this page, it says the frequency of the physical CPU can be controlled either by the BIOS or by the ESXi host. So which one do you think we recommend? We recommend that this is controlled by your hypervisor. Notice, we tell you that in the middle of the page. In the middle of a page, we say for high performance, consider the following configurations. Number one, select the OS control CPU power management mode. You can see an illustration on the right side of this page. Number two, we recommend that you enable Turbo Boost. And if you take a look at this statement here, notice it says, this allows the processor to run faster than the marked frequency in order to increase performance for both single and multi-threaded applications. And lastly, we recommend that you expose BIOS C states to the hypervisor. Now, there's a range of C states, and your machine may not have all of them. As you can see in this page, here you can see that the range is between C0 and C6. And just in case if you're not familiar with this, notice here we mentioned that if needed, you could, of course, make changes at the BIOS and again also with the Vsphere client. And again, notice the higher the C number is, the deeper into sleep mode the CPU goes. So here we're talking about making changes, not necessarily to save power, instead to get the best performance that you can. And when you look at this page, as we continue talking about CPU power management, here you can see a change that you could potentially make on the Vsphere client. And if you take a look here, we're talking about editing power policy settings. The default is balance. And that is not what we recommend for vSan. Once again, because you're running extremely I/O intensive workloads, we recommend that you change that to high performance. All right, so that will probably conclude the first part of this chapter, because I want to make sure that you take a break, you stretch your legs. So when we come back, we're going to continue talking about this topic. Thank you. Okay, we're back. And before the break, we were talking about making sure that you have the correct hardware, you have the correct firmware. In this page, as you can see, we've mentioned that you could use Skyline Health to verify hardware compatibility. So when you look at the illustration on the right side of the page, here you can see that we have an entire section when it comes to do you have the right hardware or not. And ideally, this is what you want to see. If you never use Skyline Health, what you may get instead of this is potentially warnings. Now in class, don't be surprised when you get warnings because we use embedded ESXi hosts. But in real life, you want to see everything in green. Notice there's a section for the controller. And you can see here you have a green check mark when it comes to the controller being VMware certified. Notice you have another section for the controller driver, and you have another one for the controller firmware. So once again, if you already have a cluster in place, go take a look and make sure that everything is supported. One of the things that you could do is every so often update your vSan hardware compatibility list database. And as you can see, this is something that you could do using the Vsphere client. If your vCenter is connected to the outside world, you can get the latest version online. Otherwise, you could use the option, update from file. Now, in this page, we talk about how, if you want, you could update drivers firmware. Now here we don't show you the easiest way to do it. Here we're talking about how to do it with the command line. Now let's take a look at this command. If you look at this command is the ESXCLI software vib install command. So in this case, we're trying to install a package, a vib, that happens to come in a zip format. Now, if you have a small environment, there's nothing wrong with doing this using the command line. But as your environment gets bigger, you want to automate that. So you don't really want to use the command line unless you have to. Now, if you never use this command, here again, what we're doing is we're using PuTTY to connect to one of the ESXi hosts. And if you take a look, one of the things you could do is you could type ESXCLI space software space vib space list. And that will show you all the packages that you have installed and the version of each package. There's also a get option that I'm going to show you in my demo. And again, this one not only shows you which packages you have installed, but it also shows potential dependencies. And there you can see that you also have an install option. So in this case, I would have to download the zip file, make it accessible to the ESXi server so I could install it manually. Now instead, we recommend that you use Vsphere Lifecycle Manager. And when you take a look, VMware has made significant changes to the way that we update, potentially patch or upgrade your hardware, your ESXi service, and your overall cluster. So here, first and foremost, we explain to you what is Vsphere Lifecycle Manager. You can see it says at the very top, Vsphere Lifecycle Manager is a unified software and firmware management utility that uses the desired state model for all lifecycle operations. So the idea is, number one, this piece of software is going to take a look to see if you are compliant or not. And if need be, we could always do remediation. So for example, you may want to take a look and quickly realize that, let's say for argument's sake, you're not using the latest version of the firmware that we support. At that point, remediate simply means update that particular VIB. And when you take a look, here we mentioned the concept of a base image. We mentioned potential vendor add-ons. These will be drivers from different vendors. And again, besides that, firmware and driver add-ons. Now, when you take a look at the Vsphere client, if you look at the icon on the homepage called Lifecycle Manager, very clearly you see all these options. So when it comes to the vendor plugins, you better believe that we have plugins from different vendors. And this page, they mention, for example, the ones from Dell and HP. So when we look at this page, here, we're talking about the capabilities of Lifecycle Manager. And what I'm going to do here is I'm going to refer to this as VUM version 2. This is the replacement to Update Manager. So if you're familiar with Update Manager, then you know exactly what this utility could do. Again, this is like Update Manager on steroids. If you look at the bullets, take a look at the first one. With Lifecycle Manager, I could patch up a host or I could upgrade the host. Some of you guys in the past may have used baselines. Now you can use not only baselines, but you could also use images. You can see with this utility, you can install and update third-party software. And again, you could use the same image for all your servers in a cluster. Once again, with this utility, I could update ESXi drivers and firmware. And notice you could also update VMware tools and virtual machine and hardware versions. Now, when we look at this particular page, one of the things that they mentioned here is that nowadays, as you create the cluster, you can associate the cluster to an individual image. So you do that as you create the cluster. Now, when you take a look, here it says, if you work with images, an image is created locally from a desired state criteria comprised of the hypervisor base image and vendor drivers and firmware. Now, when you look at this page, remember, you have on one hand your base image. So that would be the software that you typically install when you deploy an ESXi server. But in this case, we're talking about combining that image with firmware and drivers add-on. You can see references there to storage devices, your network cards, besides that, your I/O controllers and so on. So we're talking about grouping together the base image, drivers, and also firmware. Now, when I look at this page, what we tell you in this page is that if you want to use images, not baselines, but images, your environment needs to be running 7.0 or above. Now, to use baselines, you could be using baseline, of course, for 6.7 or even 7.0. But again, images only work in 7x. Now, let's take a look at this page. Here you can see that in this case, we're selecting a cluster. You can see the cluster is called the vSan cluster. And what they're doing here, as they select the cluster, they go to the tab called Updates. Again, take a look on the right side. At that point, they select the option Image. And what you're doing here is you are deciding to move away from baselines. And obviously, you want to start using images. So what you have to do is you have to define an image. So notice you get to select the ESXi version. You can click on Select next to Vendor Add-ons. This is optional. And again, you could add some of these additional vendor add-ons. And you can do the same exact thing when it comes to firmware and drivers. Now, when you take a look, what we're showing you here is what I was mentioning a minute ago. As you create the cluster, at the very top, you give the cluster a name. Then you select whether you want to use vSan with HA and DRS. You can choose all three. You could technically only choose vSan, but you don't want to do that. You want to combine it with HA and DRS. And then you click on the box saying manage all hosts in the cluster with a single image. As you can see here, once you do that, you get to choose the ESXi version of your choice and potentially any vendor add-ons. Now, we've mentioned the term remediate before. Remember, that means that you want to potentially patch up something or update something in particular. So here it says when you remediate a cluster, Vsphere Lifecycle Manager applies the following elements to all the hosts in your cluster. Once again, number one, your base image. Then potentially also user-specified components, firmware and driver add-ons, and so on. And if I look at this page, here they're showing you that after I finish lecturing, you get to do your first lab. So let's talk about that lab. In that lab, you get to log in into our kit. Now you get to take a look at what you have. And you're going to quickly realize that in this lab, you combine the GUI and the command line. You're going to take a look at how many clusters you have. The answer is 2. You're going to take a look at how many hosts per cluster. The answer to that is 4 per cluster. You're going to take a look at how many disk groups you have. How big is your vSan data store? And you're going to run a few commands. All right. So on that note, I'm going to do a quick demo. And then after the demo, you get to have some fun. You get to do lab number 1. All right. Thank you. And please pay attention to my demo. Thanks a lot. Welcome back, guys. And it's time to show you what your lab looks like. In this class, you're going to be using Chrome. And if you click on Chrome, you're going to notice that we have prepared some shortcuts. Here you can see that we have a shortcut to connect to the vCenter server. And if you take a look, when you log in, you need to use the typical account, which is going to be administrator at the vsphere.local. The password is VMware 1 exclamation point, uppercase V, uppercase M. Now, besides, of course, using the vSphere client, you also have right here, PuTTY, multiple tab PuTTY. And if you take a look, you have the ability to PuTTY into any of the ESXi servers, including also the vCenter server. So just for kicks, I'm going to connect to one of the hosts. You can see we have enabled SSH. So let's take a look at what we have. First of all, some people prefer the clear theme, the light theme. Other people prefer the dark theme. Myself, I prefer the dark theme. So one of the choices you have in 7.0 Update 1, and this is not new, of course, is to switch from one theme to the other. I'm going to be using the dark theme, which looks beautiful in my opinion, and it's easier on your eyes. Now, as you can see here, you have one vCenter server at the very top. The name is SAVCSA01. You have 2 4-node clusters. They're identical with one exception. As you can see here, one has 3 running VMs. The other one does not. Now, when you take a look, I'm going to select one of these particular clusters. And if you take a look, I just booted up this lab. So I want you to ignore this particular flag of mine. Now, the way that it works here is we have 2 4-node clusters. Notice carefully they're in the same data center. And if you take a look, both have the same number of disk groups and both have the same number of disks. Therefore, both have the same size when it comes to the vSan data store. If you take a look at one of these, doesn't matter which one, you're going to notice that the size of the vSan data store is 200 gigs. I'm going to run the command df-h. And here you can see, once again, that this is not a VMFS file system. This is not an NFS file system. This is of the type of vSanFS. You can see it is 200 gigs and it's pretty empty. Now, why is it 200 gigs? Let's take a look. The way we build this environment, we have 4 nodes. Each node has 1 disk group, and each disk group has 1 cache device and 1 capacity device. If you take a look, if you select the cluster, if you go to configure, notice when you go to disk management, you see exactly what I just mentioned. Here, once again, you're going to see one disk group per host. The other cluster is identical. And once again, as mentioned earlier, you have one cache device that is 5 gigs and a capacity device that is 50 gigs. Notice you have an all-flash architecture. So if you do the math, 50 gigs times 4, that is 200 gigs. Now, let's take a look at the networking layer. In this class, each of the clusters happen to have one distributed virtual switch. This distributed virtual switch is used for vMotion, for vSan, and for your VMs. Now, if I take a look at one of the hosts, what I want to show you here is how we build each ESXi server. So let's take a look at one of the servers, doesn't matter which one. And first, let's take a look at the switches. Now, these hosts have one standard switch and one distributed switch. The standard switch is using VMNIC 0. That is your typical and standard switch. You can see this is used by the hypervisor. This is your management network. Notice the management network is the 172.20.10 network. And then we have a distributed switch. This distributed switch is using 3 NICs, VMNIC 1, VMNIC 2, and VMNIC 3. VMNIC 1 is used by the port group for the VMs. VMNIC 2 is the one used by vMotion. And in class, you can see the vMotion network is the 172.20.12 network. Lastly, we have a VM kernel port for vSan. This VM kernel port for vSan is in the 10.10.10 network, and this one can only use VMNIC 3. Now, the next and final thing that I want to show you in this first demo is that if I select the cluster and I go to configure, when we choose services, let's take a look at what we have enabled and not. Number one, notice when it comes to space efficiency, we don't have the duplication and compression enabled. We don't have compression only enabled. When it comes to encryption, we don't have data at rest encryption enabled, and we don't have data in transit encryption enabled. The performance service is enabled by default. We're not using iSCSI here, therefore that service is disabled. You guys will configure a file service, so therefore this is currently disabled. And if you take a look, here we can see that we're going with the default value for your object repair timer. This is the old vSan clone repair delay parameter. Notice, besides that, we have 3 VMs. And if you right click on the VM and you try to open up the console, in this class you're going to realize that we have not installed an operating system. We don't need to do that here. So don't be surprised when you take a look. And again, these VMs don't have Windows installed or Linux installed or anything like that. Notice, this is what you're going to see if they're running. So just ignore that. What else can I show you? When it comes to the cluster, if I go to the DRS is enabled and it is fully automated. And when it comes to HA is also enabled. Please don't confuse regular HA with proactive HA. So that concludes the first demo. Thank you guys, and I'll see you when we go and start the next chapter. Thank you guys. Hello and welcome back. It's time to cover this chapter. And as you can see here, this chapter is called vSan failure handling. So over the next few minutes, what we're going to do is we are going to talk about what to expect when you have a failure. As you can see here, as I go through the list of goals, first, we are going to talk about something called the object repair timer. You may know this as vSan clone repair delay. So we're going to talk about exactly what that is, and once again, how it affects your vSan cluster. If you look at bullet number 2, we're going to talk about hardware failure scenarios. It is critical to understand the difference when you, for example, take a look at a VM and you look at one of the objects and you realize that some of the components are, for example, either absent or potentially degraded. If I look at bullet number 3, it says we will explain how to plan maintenance tasks to avoid vSan object failures. And if we look at bullet number 4, we're going to talk about the concept of resynchronizing components, when that happens and why. Lastly, no matter what policy you use, it's always critical that you back up your data. So we're going to be talking about the importance of a vSan data backup. So let's take a look at this page. In this page, which is called About Failure Handling, what they try to tell you is that when you work with the vSan cluster, the entire cluster is one big hot spare. Now, what do I mean? Earlier, we mentioned that you can have VMs which are RAID 1. So we're talking about redundant virtual machines, potentially VMs that have 2 copies of the data, 3 copies of the data, or 4 copies of the data. The idea here is quite simple. If I lose a disk, if I architected the cluster properly, the system will automatically rebuild that data somewhere else. So we need to understand what to expect when a host goes down, when a disk goes down, whether it is the cache disk or the capacity disk, what happens when a controller fails, what happens when you have a network partition. But again, as mentioned earlier, the idea here is if I lose, for example, a disk, once again, if you architected this properly, the system has the ability to use the good copy and rebuild the broken copy elsewhere. Now, let's talk about this page. As soon as I finish this lesson, I will do one demo. I will show you what to expect, for example, when you have different types of failures. So, when you work with a vSan cluster, you need to understand that a VM is a group of objects, but underneath the objects, you have the components. So for example, if I create a VM typically when you create it will have 2 objects. One will be the VM home namespace object. The second one will be the disk object. If I power on the VM, at that point the system will create a swap object. And if I take snapshots, the system will create additional objects. Now, for each of those objects, you're going to have components. And ideally, you want to see all the components active. When you see them as active, that means everything is healthy. However, one day, you may take a look at the Vsphere client and you may realize that you have an absent component. So let's talk about that for a second. Absent simply means that one of the components that makes up an object is not available. What you want to remember, one of the most important things, is that if you have an absent component, we do not start rebuilding the data immediately. By default, we wait 60 minutes. If that component is still absent, then we try to rebuild the data. Now that 60-minute interval is controlled by a parameter that was in the past called vSan clone repair delay. Now, you don't change that parameter at the host level, you change it at the cluster level. So absent is what you're going to see, for example, if you put a host in maintenance mode and you choose not to evacuate the data. Or for example, if a host crashes, or for that matter, if you have a network partition and one host cannot communicate with the other ones. The grade of this is very different. At that point, we know that that component is not coming back. That typically is what you see when you have a disk failure or a controller failure. So in that case, we don't wait 60 minutes. We start rebuilding the data, or at least we try to rebuild the data immediately. Reconfiguring is something that you may see one day because, for example, you change the policy that a VM was using. So you decided to take a VM that was running and let's say convert it from, let's say, RAID 1 to RAID 5. At that point, the system has to create new components. It has to copy the data, and then it will erase the original components. So temporarily, you're going to see reconfiguring. And then lastly, one day you may see that you have stale copies. But we need to talk about that because something has changed in 7.0 Update 1. So we need to talk about something called a delta component. But again, active and stale simply meant that you had a copy that was obviously not containing the latest copy of the data. So we're talking about a sub-mirror, for example, that did not have the latest and greatest changes. So we'll talk about that in more detail, and then we'll do a demo later on. Now, when you look at this page, here we show you that ever since 6.7, you get to dictate at the cluster level at what point we start rebuilding components automatically. I mentioned a second ago that in the old days, this was dictated by a host parameter, and that parameter was called vSan clone repair delay. And again, that was set to 60 minutes by default. And you could always change that with either the Vsphere client under advanced settings, or for that matter, you could change it with commands such as ESXCFG-advanced configuration. Now, the problem in the old days is that if you change it on one host, but you didn't change it on the other one, eventually, in the Vsphere client, you will see that you had advanced parameters out of sync. You will see that in the health service. So now you simply change it at the cluster level. That parameter starting in 7x no longer exists at the host level. It's just a cluster level parameter. And the idea is if it takes you, for example, 90 minutes to patch up a host, you want to change that value to 90 minutes because you don't want to start rebuilding data while a host is being patched up, because perhaps you're a few minutes away from finishing the patching process. So the last thing you want is to start rebuilding the data at that point. And if you take a look, should you have a host that crashes, yet you can see that the host is not coming back, you don't have to wait 60 minutes. Although you're going to have absent components, if you know that you cannot recover from that particular situation, all you have to do is click on repair objects immediately. So the idea here is you use the health service, which now is called Skyline Health. You realize that some of your objects are not healthy. So instead of waiting potentially another 59 minutes and 59 cents, you simply click on repair objects immediately. Now, when you look at this page, here they're trying to tell you that if you have different types of failures, as mentioned earlier, the system may try to rebuild the data. So at that point, you're going to see objects and components going through a resynchronization. Notice here they mention, for example, that you may see that if you lose a disk, for example, if I lose a cache disk on the upper left, or a capacity disk, or a storage controller. Now, if I have a host that is network isolated and 60 minutes go by, like I said, we're going to start rebuilding components. For that matter, if you reconnect that host to the rest of the cluster, then the stale copies need to be updated. And when you take a look, this could also happen on the right side because you change the policy that a particular VM is using. So when you take a look, I've mentioned I was going to do a demo. And in this case, remember, vSan works on a voting system. You need to have the majority of the votes for each of your objects to be able, for example, to power on the VM. So when you look at this page says impact of vSan failure testing on VMs. And if you look at the very top, it says when performing failure testing in a vSan cluster, you need to understand what to expect. So once again, in my demos, I will very quickly create a network partition. And later, I will show you a Python script that can emulate unplugging a disk or injecting a permanent failure. If I inject a permanent failure, that's an example of a degraded component. If I emulate unplugging the disk, that would be an example of absent. And when you take a look, one of the most important things is to plan maintenance mode. If you think about it, I mentioned that vSan works on a voting algorithm. So if your VM, for example, is a two-way mirror, that VM typically will have two sub-mirrors and a witness. Typically, again, each of those components will have a vote. And you can see that voting setup with the command line very easily. I'll show you how to do that. Having said that, imagine if I try to put two servers in maintenance mode at the same time. And those two servers perhaps have the two submirrors for one particular object or a submirror and the witness. In that case, 2 out of 3 components would not be available. So you can imagine that you don't want to do that. What you always want to do is you want to put a host in maintenance mode. Then you choose whether to evacuate the data or not. Now, when you bring the server back up, before you put the next one in maintenance mode, make sure that you don't have any resync operations taking place. You want to wait. You want to be patient. You want to make sure that you have rebuilt all the data before you move on and you put the next host in maintenance mode. Now, in my demo, or I should say demos, I will show you what happens when out of the blue you have absent components or degraded components. So when you take a look, here all they're trying to show you is that if, for example, I lose a disk and the disk, let's say, has one of the submirrors, if I architected my cluster properly, for example, in this case, I have 5 nodes, should I, let's say, lose the disk that contains one submirror, the idea is the system would have no problem in this case, assuming you have space. It would have no problem to rebuild a missing submirror either on the same host if you have additional disks on that host or potentially a different host. So let's take a look at this particular case. In this case, you're having a bad day because if you think about it, you now have 4 hosts and you have a lot of network partitions. In this case, if I don't have the majority of the votes available, the idea is I will not be able to restore the VM. So when you take a look in this case, you have a virtual machine. The virtual machine is registered and potentially running on host 1. In host 1, you have one of the replica components, meaning one of the submirrors. Now, if you think about it, here I'm looking at a VM. And again, they're talking about the different types of failures. Remember, here they're talking about what happens if a cache disk fails. Remember, if a cache disk fails, the entire disk group fails. So that goes back to why you want to have multiple disk groups per host. So when you look at this statement, it says when a cache device failure causes degraded components. Remember, when a disk fails, that's equals to degraded. An instant mirror copy is created, assuming, again, you architected this properly. So in this case, once again, if I were to lose one of my cache disks, that disk group would cease to operate. But if I have space elsewhere, remember, you can never have 2 submirrors on the same host, or for that matter, a submirror and a witness. The system then would have no problem rebuilding that data. So when you look at all these cases, instead of using these scenarios, I'm going to demonstrate these scenarios in my demo. So what we're going to be doing next is we are going to see what happens, for example, when a host is in maintenance mode, when a host is network isolated, or for that matter, if I unplug a disk. So here you can see what they're showing you is what? You lose a capacity disk. This disk fails on host 3, let's call it, on ESXi03 to be more precise. The system takes the good copy on ESXi-02 and it starts rebuilding the copy on ESXi01. It cannot build it on 04 because that's where you have the replica. So if you take a look, once again, these scenarios are showing you what to expect. So here we're talking about what would happen if a capacity device fails without errors. So in that case, there's a level of uncertainty. So we don't know necessarily if that particular disk is coming back or not. So that's an example of absent. Once again, if it's absent, we wait by default 60 minutes. And if you take a look, here they're talking about what happens when a controller fails. So when a controller fails, every disk behind the controller fails as well. So that's why you want to have multiple controllers instead of one controller per host if you can help it. In this case, imagine if I have one controller per host, if I lose that controller, automatically I lost 25% of the space of my cluster, assuming that every host has the same number of disks and each disk is of the same capacity. So when we look at this one, here they're talking about a host failing. And we've already mentioned, if a host crashes, we don't know if it's coming back or not, or how long will it take to come back. So in that case, that is a scenario where you once again see absent components. Now here, they're talking about network isolation. Same thing. If a host is network isolated, the components in that host will be marked as absent, not degraded, absent. And again, every time you see absent, by default, we rebuild data only after 60 minutes. Now, when you take a look, here, you're having again a bad day, and you have two network issues. Notice host 1 cannot see host 2, 3, or 4. Host 4 is also isolated. But in this case, host 2 and host 3 can see each other. In this case, despite the fact that you're having a bad day, host 2 and 3, between them, they have 2 out of 3 votes for that particular VM. So that VM, which was running on host 1, will be powered off and restarted automatically either on host 2 or 3. And if you take a look, no matter what policy you have, you want to make sure that you always back up your data. So I don't care if your VM is a 2-way mirror, 3-way mirror, or 4-way mirror. I don't care if you use RAID 5 or RAID 6, back up your data. Doesn't matter what tool you use. If you like Veeam, for example, use Veeam. If you like Net Backup, use Net Backup. Use whatever you want, but back up your data. Thank you. Welcome back. It's time for another demo. And in this demo, what I want to do is I want to create a problem. I want to show you, for example, what happens when you have issues in a vSan cluster. In particular, I want to show you the existence of absent components. Now let's take a look at what I currently have. Right now I have 3 virtual machines. The first one is RAID 5. And if you take a look, you can confirm this by looking at the summary page. By scrolling down, you can see this one is RAID 5. The other 2 are using the default policy. They're 2-way mirrors. Once again, let's take a look. There it is. And again, here's number 3. Once again, this should be a 2-way mirror. It should be using the vSan default storage policy. So let's concentrate on the first VM. If you take a look, right now, all of the components are going to be healthy. Let's take a look. I'm going to select that VM. I'm going to go to the monitor tab and I'm going to go to physical disk placement. You can see this virtual machine has 3 objects. Why 3? The first one is the VM home namespace object. That is the folder with the metadata files. The next one is the disk object. And because it's running, the third one is the swap object. RAID 5 requires 4 hosts. That's why you see 4 components. And once again, all of them are currently active. Now, what I'm going to do next is I am going to go to a machine and I am going to pick one randomly. So take a look. I'm going to pick host number 4. Remember, it doesn't matter which one I pick because all of them are being used by SAVM01. And I'm going to type ESXCLI network NIC list. Now this will show me that this host has 4 NICs. Remember, VMNIC 3 is the one being used by vSan. And you can see that this is currently up. So let's take a look at what happens. If I type ESXCLI followed by network NIC down -N VMNIC 3. This is the same thing as going to that machine and removing the network cable from that server. Now let's take a look at the GUI. In no time whatsoever, you expect to see a combination of warnings and errors. Remember, host 4 now is isolated. Host 1 can see 2 and 3, but again, the first 3 can now see 4 and vice versa. So what's going to happen is the very first host is going to be able to see, for example, 150 gigs instead of 200 gigs. Because remember, the first, second, and third can talk to each other. Each of them has a 50 gig capacity disk. 50 gigs times 3 is 150 gigs. Now, the one that is isolated, however, can only see his disk group. Therefore, he should be able to see only 50 gigs. And if you take a look, I am going to do a refresh. Now, I expect to have one absent component for each object, just like you see here. Now, the failure that I just generated potentially also affected other VMs. Let's take a look. When it comes to the second VM, if I take a look, notice none of the objects here were affected by that. Maybe I got lucky. And when it comes to number 3, let's take a look. This one once again has apparently everything active. So, how do I approach this problem? What you want to do here is you want to use always Skyline Health. This again is going to be your best friend when it comes to troubleshooting. So if you take a look, if you select the cluster, right off the bat I can see all sorts of problems. I can see that my network failure affected different objects, including the StatsDB object, which is the object for the performance service. Now I am going to go to the monitor tab and I'm going to scroll down. If I click on Skyline Health, here notice I can see immediately that I have again different types of problems. So for example, here I can see that I have an issue when it comes to the object for the performance service. Once again, if you take a look here, you can see how many objects were affected by this. And again, I could also see that I have network-related problems. So in this case, the problem is the network that affected the objects. So to fix that, what I want to do is I want to up the NIC again. To do that, I'm going to run ESXCLI network NIC up minus NVM NIC 3. And if you take a look, I'm going to type ESXCLI network NIC list. All of them should be up. And then I can go back to the GUI, back to the Vsphere client. I'm going to do a retest. And again, you're going to notice that everything goes back to normal. Notice the warnings and errors begin to disappear from everywhere. This again will take a few more seconds. I could always clean this up manually if needed. Never mind, notice it beat me to the punch. And if you take a look at the virtual machine, the one that was affected by this, notice everything should be once again active. That concludes the first demo. Thank you guys. Welcome back. It's time to start the next lesson. And as you can see here, this lesson is called vSan Storage Policy and Fault Domain Operations. Now let's take a look at the goals for this lesson. Over the next few minutes, what I want to do is first and foremost, I want to go through all of the vSan storage policies that exist. I want to show you, especially if you're used to doing this with the web client, that creating the policies is very different with the vSphere client. Even the naming convention is different. Number 2, we're going to talk about what happens when you change the attributes of a particular policy. For example, what happens when you change a rule that belongs to a particular policy? If that policy is in use, we need to understand what to expect. And then lastly, we are going to talk about fault domains. And if you're not familiar with fault domains, you need to understand that fault domains make vSan rack aware. All right, so let's take a look at this page. And this page, they're trying to show you, number 1, how to create the virtual machine storage policies. So please remember that we mentioned earlier that vSan has a default policy. And that policy is called FTT1, failures to tolerate equals 1. So when I'm talking about FTT1, or failures to tolerate equals 1, any VM using that policy is a two-way mirror. And you don't have to use that policy. Be aware you cannot delete that policy, but you can change that policy. While I'm at it, let me remind you, you cannot delete a policy if the policy is in use. So if I'm using the Vsphere client, all I have to do is go to the home screen. And when I go to the home screen, I'm going to have an icon for virtual machine storage policy. Now, when you take a look, when you create a policy, you name the policy. And then at that point, you get to this particular set of screens. You have two tabs, availability and advanced policy rules. If I take a look at availability, you have two entries. One is called site disaster tolerance. This is the option that allows me to choose between regular policies for regular clusters versus policies for stretched clusters. And then again, I have the choice failures to tolerate, aka FTT. And if I click on the expander, I get to see that I could choose RAID 0, RAID 1, RAID 5, and RAID 6. And when it comes to RAID 1, I could choose two-way mirrors, three-way mirrors, and four-way mirrors. When it comes to advanced policy rules, in there you see the choices. Number of disk drives per object. The default is 1. The maximum that you could choose is 12. IOPS limits per object. By default, we don't use IOPS limits, so the default is 0. When it comes to object space reservation, you can make your VM thin provision, that is the default, or you can tell it to reserve 25% of the space, 50% of the space, 75% of the space, or use 100% of the space. Now, it's a little bit different if you have the duplication and compression. At that point, you cannot choose options like 25% and 75%. At that point, it's either thin or thick. Now, the next choice, flash read cache reservation. This one is set to 0. But this one can only be used if you have the hybrid architecture. That cannot be used if you have the all-flash, because your cache disks, when it comes to the all-flash architecture, are only used for writes. They're used 100% for write amplification. It is different if you have a hybrid architecture. Then they're used 70% for read caching and 30% for write buffering. And then lastly, we have options called disable object checksum. That is turned off. So by default, we do checksumming. And then we have an option called forced provisioning. So by default, for example, if I don't have 4 hosts, I cannot create a RAID 5 VM because a RAID 5 VM would need 4 hosts. The reason I cannot do that is because forced provisioning dictates that by default, if you don't have enough hosts, you cannot create that type of VM. If I change the value of that parameter, that would allow me to create a VM, even though I don't have enough hosts. Temporarily, that VM would be RAID 0. If and when I add enough hosts, then magically and automatically that VM would go from RAID 0 to RAID 5 if you chose RAID 5 combined with forced provision equals yes. So I'll do a demo of that. Now, when you take a look, remember a VM is a group of objects, and nothing says every object has to use the same policy. You can have a VM very easily that has a boot disk that is a two-way mirror using the default policy. But maybe you choose perhaps to have, let's say, an application drive that is a three-way mirror. So once again, objects can use different policies. Now, when we look at this page, all we try to tell you is that when you decide to name the virtual machine storage policies, they should make sense not just to you, but to everybody. For example, the idea here is simple. If I want to create a policy called RAID 5, or again, let's say I want to create a policy that is indeed using RAID 5, I don't want to call it something like Go Dolphins. By the way, I live in Miami, so that's why I'm using that analogy, because that makes no sense whatsoever. Maybe you want to call it something like the cluster name, followed by RAID 1 or RAID 5, whatever works for you. But again, something that is consistent and it makes sense. I'm going to show you our lab And we're going to take a look at the naming conventions that we use for the different policies that we created for you. And if you take a look, in this particular lesson, we have a series of activities, if you will. So when you take a look at this page, what they're showing you is a VM. And this VM has a 100 gig disk. This VM, notice, is using the default policy. FTT1 means two-way mirror. SW1 means stripe width 1. That means we're not striping. So that's the default policy. In this case, if I look at the disk is one object. And underneath you have two replica components. That means what? Two copies of the data. Despite the fact that the VM will be thin provisioned by default, the VM in the worst case scenario will use 200 gigs of space. And when you take a look, here we see that somebody decides to create a policy. And the policy dictates that this VM is RAID 1. We're not striping. But notice FTT2. That means it's a three-way mirror. For three-way mirror VMs, you need 5 hosts. And you would have 3 replica components. So when I look at the questions, how many hosts are required? The answer is 5. 3 would have the 3 sub-mirrors. And I would need 2 more hosts. These 2 hosts would actually have the 2 witness components. In the worst case scenario, you need 3 out of 5 votes. So we're talking about 3 replicas and 2 witnesses, 5 hosts altogether. When you take a look, that's what we show you here. So notice here you have the answers to the previous scenario. And if you take a look, what we try to show you here is that if I change the policy that a particular VM is using, the system temporarily will use twice the space because the system will not resize the components. It will create new components. Take a look. In this case, we have a VM, and the VM is RAID 10. You can see it says FTT1, RAID 1, stripe width 2. So if the disk was 100 gigs, you have 2 copies, but each copy has 2 stripes. And again, each of them is 50 gigs. So you can see 50 times 4, 200 gigs. If I change the policy and I say I want to use stripe width 3, the original components will not be shrunk. The system creates a bunch of 33 gig components, copies the data, and then it deletes the original components. So make sure that you don't make those changes in the middle of a day. And this illustration is showing you exactly that. Now, when you take a look, remember, if you change the policy and the policy is used by 100 VMs, you can imagine if 100 VMs have to go through a reconfiguration, that would generate a lot of extra I/O, and that could impact the performance of your cluster. So when you make changes, do not make the changes casually and do not make them in the middle of the day. When you take a look at these bullets, number 1, they tell you make sure that you have enough space for that particular change to take place, because remember, the VM could use potentially twice the space. And again, if you're going to apply the policies, do it either 1 VM at a time or 1 object at a time, but not all the VMs at once. Now, when you take a look here, they're showing you how easily with the Vsphere client you can see whether or not your objects are compliant. So in this case, I see a VM. This VM has, in this case, 2 objects showing. One is the VM home namespace object. That's the folder with your metadata files. And the other one is the disk object. Both are using a RAID 5 policy. And notice both are compliant. So in this case, everything is healthy. All the components are healthy, active, and again, nothing is wrong. Now, when you take a look at this VM, once again, this is what you want to see. You want to see the individual components, all of them active. Remember, in this case, if you're RAID 5, you can sustain 1 loss. So in the worst case scenario, you want to see what? 3 out of 4 components per object active. If you have less than 3, then guess what? That VM will not run. But again, ideally, you want 100% of your components active. And if you take a look, next, what we do is we talk about fault domains. So we're going to take a quick break because I've been going probably for about 15 minutes. And then after the break, we'll talk about full domains. So enjoy the break and come back in a few minutes. Thank you. Welcome back. It's time for another demo. And this demo is going to be about full domains. In the lecture, I've mentioned that with vSan, you have implicit full domains, and you can also have explicit full domains. Currently, in this cluster, I have 4 nodes. That means I have currently 4 implicit full domains. If I want to create a full domain, it's very easy to do this, and you can do this with the Vsphere client. You could also do that with Power CLI. And if you take a look, what I'm going to do is I'm going to go to the cluster. I am going to go to the Configure tab, and I am going to choose right here full domains. Now, it makes no sense to create an explicit full domain with only 1 node. Typically, again, you create explicit full domains for 2 or more nodes. Now, what I'm going to do here is I am going to create 1 full domain. I'm going to click on the plus sign, and the full domain needs a name. Let's say, for argument's sake, I want to call it rack number 1. And what I'm going to do here is I'm going to choose 2 ESXi servers. Let's pretend that these 2 are in the same physical rack. Now, I'm going to click on create. And this is all it takes to create a full domain. Now, don't be surprised if you have warnings in the cluster, because remember, one of your VMs was RAID 5. And that means that automatically, no matter what, 2 of the components are going to be on the same full domain. And that should not be the case. So again, I want you to ignore that. Of course, that could also happen for any of the FTT1 VMs. Remember, these VMs were there to begin with. So maybe 2 submirrors now are in the same rack, or for that matter, a submirror and a witness. Now, if you take a look, if I need to make changes to this, I can always click on the 3 dots. And notice you can click on edit. You can always add another host at any given time. For obvious reasons, you can do the opposite. Or finally, if you want, you can always delete it. So what I'm going to do here is I'm going to click on the 3 dots, and I'm going to delete that particular full domain. Now notice, if I don't delete it yet, if I go to the Monitor tab, I am going to go back to Skyline Health. And if I do a retest, you will see again the system will start to complain. Because again, remember right now, I have 4 nodes. 2 of them are grouped together in an explicit full domain, yet I have a RAID 5 VM. So let's see what happens before I delete it. Let's give it a second. There it is. You can see the system is complaining. And obviously I want to fix that problem. So again, the best way to fix that problem in this case is simply to go to full domains and just delete it. Now at this point, of course, all I have to do is go back to the Skyline Health utility, do a retest, and everything will go back to normal. Thank you guys. That concludes this demo on full domains. Thank you. Welcome back. It's time to talk about full domains. Now, we've had full domains for a long time. If my memory doesn't fail me, full domains were created back in 6.1. I could be wrong, maybe 6.061. So let's talk about what full domains do. And prior to the break, I've mentioned that full domains make vSan rack aware. One of the most important things to understand is the difference between an implicit full domain and an explicit full domain. Each host on its own is an implicit full domain. Now think about this. Imagine you have 6 ESXi servers in your cluster, and you have 2 hosts per rack. The problem without full domains is that our software doesn't know which hosts happen to be in each rack. So there's a good chance that when you create a VM, if the VM is a 2-way mirror, potentially you could have 2 submirrors on 2 hosts in the same rack. Now imagine if you lose that rack At that point, you lose the majority of the votes. So with full domains, in that scenario with 6 hosts, you could easily create 3 explicit full domains, add 2 hosts in each full domain. So that way, if a sub-mirror goes in the first host in the first rack, the second host in that rack would never be used for the other sub-mirror and or the witness. So when you look at this page at the very top, here notice it says vSan full domains can spread component redundancy across servers in separate computing racks. So once again, this feature is making vSan rack aware. Notice it says vSan requires a minimum of 3 full domains to support FTT1. Once again, you need to have either 3 implicit full domains, meaning 3 ES6 servers on their own, or you would need to have 3 groupings of hosts. But again, we're talking about 3 explicit full domains in that case. Now, if you think about it, if I have, for example, 6 hosts, but I put 5 in one full domain, technically there, I would not be able to create a VM and make it a two-way mirror. Because in that case, if I have 5 hosts in an explicit full domain, those would count as one. And then the host outside of the full domain would count as another one. So I would only have altogether 2 full domains. So when you take a look, it doesn't make sense to create an explicit full domain with just 1 host. Because remember, each host on its own is an implicit full domain. So when you take a look, here we talk about best practices. Now, if you look at the first bullet, it says provide enough full domains to satisfy the failures to tolerate the value that is configured in the storage policies. Once again, for example, for RAID 5, I would need 4 hosts. So in that case, I need either 4 implicit full domains or a combination of implicit and explicit full domains. But again, they need to total at least 4. Notice, ideally, you want to put the same number of hosts in each full domain. So if you think about my analogy, I mentioned 6 hosts and 3 racks. And I mentioned to put 2 hosts in each full domain. And again, ideally, you want all your servers to pretty much look the same, your racks to be the same. So that's something to consider. Now let's take a look at this particular scenario. Here we're talking about implicit full domains. So remember, in this case, I have 4 hosts. If you don't build explicit full domains, these are 4 implicit full domains. So in this case, I could very easily create RAID 1 VM if the VM is a two-way mirror. For that matter, I could even use RAID 5 because again, I have 4 implicit full domains. In this case, I have a VM. The VM is a two-way mirror. One sub-mirror on the first host, the other sub-mirror on the other. That's what they mean by C1 and C2. We're talking about replica components. And then in this case, we have the witness on host 3. If I lose, let's say for argument's sake, host 1, I could take the copy of host 2 and rebuild the missing copy onto host 4. If I were to put 2 hosts in an explicit full domain, I could create a two-way mirror VM, but then if I lose a host, you got to consider what would happen in that particular scenario. So when you look at this illustration, here we have a system, or an environment, I should say, with 4 racks. And in this case, each rack has 4 hosts. So we follow in best practices. Same number of hosts in each rack. So in this case, what we're doing is we are creating 4 explicit full domains. Each explicit full domain covers 4 servers in a rack. Now, in this case, can I create a two-way mirror VM? Yes. Because despite the fact that I have 16 servers, they count as 4. Remember, here we have 4 explicit full domains. Now, would I, in this case, be able to create a RAID 5 VM? Yes, because again, I have 4 explicit full domains. But despite the fact that a 3-way mirror VM requires a minimum of 5 hosts, I would not be able to create a 3-way mirror VM here. Because again, I have 4 full domains, and I would need to have 5 full domains, either explicit or implicit. So in this case, I would not be able to create a 3-way mirror VM a 4-way mirror VM, or for that matter, a RAID 6 VM. I'm going to do a demo in a few minutes, and in that demo, I will show you exactly what I mean, and I will show you how to create full domains, modify them, and eventually delete them. When you take a look, what follows is going to be lab 2. And when it comes to lab 2, notice the lab is called Analyzing the Impact of Storage Policy Changes. So remember, I'm going to do a series of demos first, and you're going to see what happens when I try to, for example, modify a policy that is in use. I'm going to show you what happens if you try to delete a policy that is in use. Remember, you cannot delete it. I'm going to show you that you cannot, for example, delete the default policy, but you could change it. And if you take a look, this is lab 2. And following lab 2, you have another lab. This one is lab 3. You can see this one is called Identifying Objects with Reduced Availability. So I want you to look at my demo, because in my demo, I'm going to create a network partition. And as I do that, you're going to have apps and components. Also in my demo, maybe I will reboot a host. Once again, we're talking about apps and components. And later on, I will show you a Python script that allows me to emulate injecting a permanent failure, if I want, onto a disk. That would be an example of degraded components. What follows that is lab number 4. And in lab number 4, you play with full domains. So make sure you pay attention to my demo. And then after that, you get to do 3 labs in a row. Thank you. Hi guys, it's time to take care of this particular chapter. And as you can see here, this chapter is called vSan Cluster Maintenance. Now, in this page, they're trying to tell you why this topic is very important. And the goal here is quite simple. When you're doing some kind of maintenance, you want to make sure that your decisions do not impact the virtual machines that you have in your environment. So as you can see here, notice it says the maintenance of computing, network, and storage resources on production systems must be achieved without causing downtime. So if you take a look, this chapter has 3 lessons. The first one deals with what happens when you put a host in maintenance mode. The second one deals with growing the cluster and replacing faulty hardware. The third one talks about upgrading and updating virtual SAN. So if we start with lesson number 1, here you can see the first lesson is called vSan Cluster Maintenance Operations. And what I want to do here is I want to do one demo. And in this demo, what I want to do is I want to show you a brand new feature of 7.0 Update 1. So in this lesson, we are going to be talking about the different choices that you have when you put a host in maintenance mode. If you've been working with vSan for a while, you probably know that there are 3 choices: ensure accessibility, full data migration, and no data migration. We'll talk about all 3 and what is the difference of all 3. Notice, we'll talk about the right way of shutting down a host in your cluster. Also, we'll talk about how to migrate your cluster so it uses the brand new vCenter. And then finally, we'll talk about vSan logs and vSan traces. So in this page, here what they try to tell you is that when you right click on a host, if you decide to put the host in maintenance mode, on the vSphere client, a pop-up window appears and it shows you 3 choices. The default choice is ensure accessibility. And I'm going to show you in a few pages that you can change if you want the default. Besides that one, you have full data migration and no data migration. Now, if you take a look, here what they try to tell you is that nowadays when you put a host in maintenance mode, to truly understand the ramifications of your decision, if you click on pre-check, it's going to tell you exactly how many VMs will be impacted by your decision. So if we go to the next page, let's talk about what this means. Now, in this case, we're trying to explain to you the default. And the default is ensure accessibility. So what the ensure accessibility is doing is simply moving the bare minimum to ensure that every virtual machine can continue to run. Now, if you take a look, I'm about to put host 1, aka ESXi1, in maintenance mode. And as you can see here, that host has one component for VM1. And you can see VM1 is not redundant. So when you choose to ensure accessibility, we need to move that component elsewhere to make sure that that virtual machine can continue to run. But when it comes to VM2, if you look at the illustration on the left side, you can see that the VM is a two-way mirror. So that VM can live without that submirror. So in this case, we're only moving one component out of host 1, and we're choosing not to move the second submirror, let's say for the second VM, because again, that VM can live without it. Now, when I go to this page, here you can see that every choice you make has, again, a type of repercussion that you need to truly understand well. So when you look at this page, here you can see how many objects will become non-compliant. Because again, remember, we're talking about having absent components. And again, these absent components are going to be the ones, for example, in the different objects, such as the VM home namespace object, your disk object, your swap object, potentially your snapshot object, and so on. Now, when I go to this page, here again, they're trying to explain to you a brand new feature in 7.0 Update 1. And this is the existence of a brand new type of component, which is called a Delta component. Now, in order to understand what a Delta component is, we need to understand what used to happen in the past versus what happens now. So let's compare, let's say, 6.7 to 7.0 Update 1. Let's say in this case, I have a VM, and let's say that in 6.7, I decide to put ESXi01 in maintenance mode. If I went with ensure accessibility, what I was doing is I was taking a chance. Think about it. One submirror is absent. Now that VM is running. So this submirror is going through changes. Now imagine, while this was down, that this host crashes. Now, of course, this copy is unavailable. Now your instinct probably is going to be to take this host out of maintenance mode and try to store the VM with this copy. The problem is this copy is stale. It doesn't have the latest and greatest. So in that scenario, you wouldn't be able to store the VM. We don't let you store the VM with an old copy. Now, let's talk about 7.0 Update 1. We have, in this case, 4 servers. You can see the VM is a two-way mirror. So we have 2 submirrors. You put this host in maintenance mode. So this is obviously absent. What the system does now, in another host, it creates a Delta component. So as you go through changes, this copy is being updated, but the changes also go in the Delta. Now, if this host fails, and you take this host out of maintenance mode, this one, the one that was stale, uses the Delta component to update its records to allow you to store the virtual machine. So it's pretty cool. And in the GUI, you will get to see the presence of a Delta component. You will see, just like you see here, the presence of a component called RAID_D, D for Delta. Now that gets created automatically. And when you take the server out of maintenance mode, you can imagine again, at that point, we don't need that component anymore. So it gets deleted automatically. And if you take a look, remember, when you put a host in maintenance mode, if you choose ensure accessibility, we're talking about what? Absent components. So remember, you have a default value of 60 minutes. If you do not bring that host out of maintenance mode in 60 minutes, what's going to happen is we're going to try to rebuild that data somewhere else using the other copy. So if it takes you usually 90 minutes to patch up a host, you want to change that timer from 60 minutes to 90 minutes. And that used to be changed at the host level before. Now it's at the cluster level. In the old days, it was a parameter called vSan clone repair delay. That parameter no longer exists at the host level. You don't find it anymore. Again, you change it at the cluster level. Now, when you take a look, that's what they try to tell you on this page. So if you think about it, 60 minutes is the default. Some people change it. Once again, depending how long it takes you to patch up a host, you may need to change that and potentially increase that value. Now here we're talking about full data migration. Now with full data migration, what you're saying is, I don't want to take a chance. You're saying, no, I want to move all the data so at all times I have multiple copies of that particular set of data. So again, if you lose a host while one is in maintenance mode, doesn't matter. You still have 2 valid copies. So again, you're playing it safe. Now, if you think about it, however, you're talking about moving additional data before the host goes into maintenance mode, which again, if you think about it, means it's going to take longer to put a host in maintenance mode. And that's what they try to show you in this illustration. Once again, we're putting host 1 in maintenance mode. In this case, unlike the first one, we're moving not only the component for VM1 for obvious reasons, but we're also moving the component for VM2 that was in host 1. And in this case, it can only move to host 2. When you take a look, for obvious reasons, you need to architect your cluster properly. So again, that's why here you can see it says cluster size considerations. Remember, you may have read or you may have heard about the concept of slack space. So for you to make sure that you can move that data, that's why typically we tell you to reserve 25 to 30% of the available space. Again, you got to think sometimes worst case scenario. Now, as I mentioned before, whether you choose ensure accessibility or full data migration, you can very easily see what's going to happen when you do that. So once again, we're talking about pre-check. And if you take a look, no data migration is quite simple. I would use this option if I want to shut down the entire cluster. So for example, I live in Florida. We have hurricanes here. We see them coming. So let's say for argument's sake, we know a hurricane is coming on Sunday. Come Friday, I shut down all the VMs, and then I shut down all the hosts, and I choose no data migration. When at the last minute, the hurricane goes somewhere else, obviously at that point, I start to power on all my hosts, and then finally, I turn on all of my virtual machines. And if you take a look, right, once again, here you can see that they're showing you the pre-check if you were to choose no data migration. You can imagine, again, you're going to have all sorts of issues when it comes to the health of the objects. Now, I've mentioned you could modify the default when it comes to what is chosen when you go and put a host in maintenance mode. So you can see here's the name of the parameter. It is an advanced parameter at the host level. Notice here you can see the name of the parameter. You can see the default value. And on the left side, you get to see the keywords, which again are going to be used to choose either no data migration, that would be no action. And as you can see, you have another one called evacuate all data. That would be the keyword for full data migration. Now, when you move things around, or for that matter, as things change and objects grow, be aware that you may get a warning that it's time to do something called a proactive rebalance. And a proactive rebalance will take place. Again, the warning will take place if the maximum load variance is higher than 30%. Now, what do I mean? If one disk is at 50%, and let's say one disk is at 2%, the difference between 50 and 2 is more than 30%. At that point, the system will tell you that it would be a good idea to do a proactive rebalance. But you don't want to do that in the middle of the day because you're talking about moving a lot of data around. And when you take a look, nowadays, if you want, you can enable automatic rebalance. So when you enable automatic rebalance, you don't have to anymore click on proactive rebalance. The system will move things automatically. And as you can see here, it says rebalancing can wait up to 30 minutes to start. giving time to high priority tasks, such as entering maintenance mode when it comes to a host, or obviously fixing a particular object before moving data around. And you can see here we show you how to enable automatic rebalance, and we also show you the fact that you don't have to necessarily go with 30%. You can change that value. So, we talked about the concept of slack space. New 7.0 Update 1 is the ability to reserve capacity automatically. And you have two choices. You can reserve operations reserve, or again, I should say we could enable operations reserve, and we could also enable host rebuild reserve. Now, in the statements on the left side, they explain to you what these are. So notice, instead of having to manually always take into consideration slack space, in 7.0 Update 1, you can again reserve a chunk of the space for either operations or host rebuild operations. What is the difference? Notice, operations reserve, it says right here, it reserves capacity for internal vSan operations, such as object rebuilds or repairs. Host rebuild reserve is a little bit different. Notice this reserves capacity to ensure that all objects can be rebuilt if a host failure takes place. So when you take a look, here we show you how to do it. So you can actually see that if you go to the Monitor tab, and if you want, of course, there you choose capacity, then you see these new choices. When you say, I want to enable it, this again will take you to the Configuration tab. All right, so we've been going for a while. Remember, I said I was going to do a demo. So let's take a little break. And when we come back, I'll finish the lesson, and then I'll do the demo. I'll see you in a few, guys. Thank you. Welcome back, guys. So now, what we're going to do is we're going to play with maintenance mode. I'm going to choose one of your ESXi servers. I'm going to put them in maintenance mode. We're going to take a look at what happens to the actual VMs, what happens to the objects and components. And in the process, we're going to get to see for the first time, perhaps, the existence of a brand new component. And what I'm talking about is the Delta component that we mentioned a few minutes back. Now for this demo, I have chosen one VM, and that VM is SAVM03. Now what we're going to do is we're going to take a look at this virtual machine. So the first thing I want you to notice is that this virtual machine is running. So therefore this VM, as you can see here, has 3 objects. Now the reason it has 3 objects is because it has one disk, and it's running, and it doesn't have any snapshots. So one object is your VM home namespace object. That's the folder with the metadata files. One is the disk, and the last one is the swap object. Now let's take a look at one object. Now in this case, I'm going to look at the disk object. And as you can see here, this object is using the default policy. Therefore, this object is a two-way mirror. I want you to notice the location of the 2 components. Notice the 2 sub-mirrors or replica components happen to be on host 3 and also host 1. So right now, I have a large cluster. You can see I have 6 nodes in my cluster. So I could very easily put one of the hosts in maintenance mode and choose to evacuate all data, to do a full data migration. But let's say I choose not to. Let's say I go with the default. So let's take host 1. Remember, host 1 is the one being used by that virtual machine. Remember, there is a sub-mirror in that first host. So I'm going to choose to put this host in maintenance mode. Now, when I right-click on the host, I choose maintenance mode, and I enter maintenance mode. You can see here, I'm going to go with the default. So here you see the 3 choices that we were talking about. Full data migration, ensure accessibility, no data migration. We mentioned you can change the default. You can see I haven't. And if you take a look, I am going to go with the default. I don't need to go to pre-check, although I could. And I am going to click on OK. Now we know that if we have VMs running, if you have DRS, and DRS is fully automated, some of the VMs will move. That's okay. So let's take a look at what happens. I expect that host to go into maintenance mode without a problem. I expect some components to be absent. That's okay. But we want to take a look at VM3. I'm talking about SAVM03 to be more precise. And what we want to do is we want to see not only that we have an absent component, but that we have a brand new component, which is the Delta component. Now let's take a look, make sure everything is fine. Once again, I'm still waiting. There we go. I can see it finally went into maintenance mode. So now let's take a look at the different VMs. We're going to start with VM number 3. Now remember, this virtual machine was affected by my decision. You can see when it comes to, of course, the hard disk, you have absent components, but you can see the presence, look at my mouse, of this new component. And again, remember, we mentioned the name, and that is RAID_D, D for Delta. So remember, that is brand new in 7.0 update 1. So if I were to make changes, the changes would actually go into the existing submirror, and also they would go into that Delta component. So while the other one is absent, remember, I now have one submirror still up and running, but if I were to lose that submirror, I could take the other host out of maintenance mode. And between the stale copy and the Delta component, I would be able to rebuild, if you will, that absent component or update it, call it what you will, and then I would be able to power on the VM. Now, what I'm going to do next is I'm going to take the host out of maintenance mode. And remember, when I take the host out of maintenance mode, I expect that Delta component to disappear automatically. So once again, we'll take a look. We're going to do a refresh. And if we take a look, notice I have my different objects. Let's take a look. Let's make sure we don't have any Delta components. Notice this one has 2 components and a witness. That looks good. No Delta components. Notice 2 components and a witness. Once again, you can see that we don't have the Delta component anymore. So that concludes this demo. Remember, you have other choices, and in the lab, you get to play with different choices when it comes to vSan and putting a host in maintenance mode. Thank you guys, and hopefully you enjoyed that demo. Thanks again. Welcome back, and it's time for lesson number 2. And as you can see here, lesson number 2 is called vSan Node Hardware Replacement and Scaling. So what I'm going to be doing is I'm going to be going through the pages, and then I am going to do a series of demos. In one demo, I'm going to show you how to potentially remove a disk from a disk group or remove a disk group. In the other one, I am going to show you how to grow your cluster. So let's get going. If you take a look, here we have the goals of lesson number 2. And as you can see, first, we are going to talk about growing the cluster. We're talking about potentially scaling up or scaling out. Then, if you look at bullet number 2, we are going to talk about the procedure on how to remove disks from disk groups, or again, potentially how to remove disk groups completely. Now, if you take a look, the next one says we'll talk about how to remove and replace a host from the cluster. And then lastly, once again, I'm going to do a demo where I show you how to grow the cluster. So let's go through all these scenarios. Okay, let's take a look at this page. When you take a look at this particular page, here you can see that we're talking about 2 choices when it comes to growing your cluster. Choice number 1, you can scale up. What does that mean? Let's say you start with 3 hosts. What we're talking about here is not adding more hosts. We're talking about adding more disks to your existing disk groups, or potentially more disk groups to your existing hosts. Choice number 2, we're talking about scaling out. I personally prefer this one. Now, let's say you start with 3 hosts and you want to add a 4th one. So now we're talking about adding an extra host with obviously, or hopefully, extra disk groups and extra disks. Now, why do I prefer this one? Think about it. You have more choices. You have more flexibility. In the first scenario, for example, with only 3 hosts, even if I add more disks and more disk scripts, I still have the limitations of having 3 nodes. For example, I wouldn't be able to use RAID 5. In the second scenario, maybe I started with a small 3-node cluster. Maybe I didn't like it. I decided to grow it. Now, by adding a 4th host, now I can use a new RAID level. Once again, we can now use RAID 5. And if you take a look, in this page, we're talking about increasing capacity by scaling up. Once again, if we go back to the previous page, remember, this is the choice where we simply add additional capacity to your existing hosts. So when you take a look, choice number 1 in this case could be potentially you want to replace your original disks, maybe with newer ones. Or again, like I said, maybe you want to add more disks and more disk scripts to your environment. So when you look at the 2 bullets, the first one says replace capacity devices in an existing disk group with higher capacity devices. And choice number 2 again simply says just add more disks to your existing disk groups. Or again, we could easily add another choice, potentially add more disk groups. Remember, more disk groups is always better than less disk groups. Now, when we take a look at this particular choice, I'm going to show you 2 ways on how to scale out the cluster. For the longest time, we only had one method. Let's call it the manual method. But now for the last few versions, ever since 6.7 update 1, we now have the choice to also use a tool called the Quick Start utility. And you can use that Quick Start utility when you first create your cluster or afterwards as well to grow it. So I am going to do 2 demos. One of my hosts is just sitting there in my inventory. What I'm going to have to do in that case is, first of all, create the VM kernel ports for, let's say, vMotion and vSan. Then I'm going to have to drag them into the cluster and then manually create the disk scripts. In the second scenario, if I use Quick Start, the host cannot be in my inventory. When we add it straight into the cluster. It goes into maintenance mode, just like you do, let's say, on day 1 if you use that particular Quick Start utility. And if you take a look, unfortunately here in my machines, I only have 1 capacity disk per disk group, and I don't have any more disks. But it's very, very easy to add more capacity, whether it is, again, by simply creating new disk groups or, again, adding more disks to the existing disk groups. In my demo, again, I'll show you how to do that. But again, unfortunately, I don't have any more disks. So when you take a look at the next page, here, you can see we show you the different options that you have on the Vsphere client. For example, I have the option claim unused disks. Now, I could use that particular choice if I want to, let's say, create the same type of new disk group in all my hosts in the cluster. So, for example, you could use that on day 1 when you first build your cluster. Let's say you want to create the same exact disk group in all the hosts. You can do it from there. The second choice, add disks. That's the one that I use when I want to create a disk group or add more disks, let's say, to a disk group in one host only. And then you can see we have another choice called go to pre-check. So again, I'm going to be doing demos in a few minutes. Now, if you take a look, in this page, we're talking about replacing capacity tier devices. Now, let's say for argument's sake, a disk fails. Or again, I want to replace the disk with a bigger one. Couple of things that we need to remember. Number 1, if that capacity disk is the only disk in that disk group, if you try to remove that disk, that is going to take apart the entire disk group. Now, I can show you that. Now, if I have, let's say, 2 capacity disks, to keep it simple, in a disk group, I can remove a capacity disk from a disk group without a problem if I don't have the duplication and compression enabled. But if I have the duplication and compression enabled, I can't do that. At that point, I have to take apart the entire disk group. Let's take a look at the next page. I'm going to show you this in my demo. But again, here's the story. If I try to remove the cache disk from the disk group, that is going to take apart once again or delete the disk group, because you cannot have a disk group without a cache device. It doesn't matter in this case whether you have dedupe and compression enabled or not. In both cases, you can't have a disk group without a cache disk. If you try to remove the cache disk, you are taking apart the entire disk group. And if you take a look, if you decide, for example, to remove a disk group, a pop-up window will appear and it will ask you, for example, whether you want to do a full data migration or you want to choose something else. Now, let's say for argument's sake, you decided to use those disks elsewhere, in another cluster perhaps. At that point, odds are that I'm going to choose full data migration. But again, you have other choices, and again, you will see all these choices in a few minutes. Now, when you take a look at this page, here we're talking about replacing a vSan node. So let's see all the steps. Number one, evacuate all the data from that particular host. Now, you want to make sure before you proceed that the moving of the data has completed, and you want to make sure everything looks healthy. So to replace the host, notice you will put the host in maintenance mode. You will drag him out of the cluster, and then again at that point you can add a new one. One of the things that are mentioned here that you may want to remember is if you're not going to use that host anymore in a vSan cluster, there's a good chance you probably want to delete the vSan VM kernel port. But other than that, these are the broad strokes when it comes to replacing or taking a host out and adding a new one. Now, just like you can grow the cluster, you can also shrink it technically. Now, if I remove a host from a cluster, I am removing in the process all his disks. So your vSan data store in that case is shrinking. So let's see all these steps. Let's see what they're talking about here. Notice, if you're going to decommission a vSan node, once again, you have to move the data out. Now, when you take a look at step number one, you want to make sure you have enough sufficient storage capacity. Otherwise, you won't be able to move all the data to the remaining hosts. Step two, you will put the host in maintenance mode, and again, you will choose in this case, full data migration. Number three, notice it says wait for the data migration to complete. That's critical. You don't want to jump the gun. And when you look at step number four, remember, you're going to be deleting the disk scripts because you'll never use them again. Now, number five, use the Vsphere client to move the ES6 server from the cluster. Meaning what? After you put him in maintenance mode, drag him out back into your data center. And then if you want, shut down the host and do what you will with it. Now, before you do lab number five, once again, I am going to do a couple of demos. Remember, in one of them, I am going to show you how to grow the cluster. And in another one, I'm going to show you how to recreate a disk group, try to delete a disk from the disk group, or again, delete the entire disk group. So hopefully you enjoyed the demos. And remember, after the demos, you get to do a lab. I'll see you in a few minutes when we reconnect to the lab and we do the first out of two demos. Thank you guys, and I'll see you in a few. Welcome back. So as promised, now we're going to grow the cluster. And I've mentioned that you have several choices. Now I'm going to do two demos. In the first one, I am going to add a host manually. I will on purpose bypass the quick start utility. Typically I would do that if, let's say, the new host is a little bit different. Ideally you want all the servers to pretty much look the same, but they don't necessarily have to be. So in this case, I am going to add SB03 onto SA vSan 01. So how do I do it? Now, the first thing I need to do is add that host to my distributed virtual switch. Once again, I want to bypass the quick start utility. Now, if you take a look, when I select the cluster, if I go to configure, we added this utility back in 6.7 update 1. So the reason I'm going to do two demos is because the second one will use this tool, but the first one is going to be done manually. So, as mentioned, the first thing I want to do is I need to add that host I'm talking about SB-ES603, to the first distributed virtual switch. So what I'm going to do here is I am going to right click on the switch. I'm going to choose add and manage hosts. I'm going to say add host, and we're going to add, once again, SB-ES603. Now we want to add the remaining 3 cards. The way that it works in class, VMNIC 1 goes to uplink 1. That would be for VMs. VMNIC 2 goes to uplink 2. That would be for vMotion. And lastly, VMNIC 3 would go to uplink 3. We try to keep it simple. Now, what I'm going to do, I'm not going to migrate any VMs. So all I'm doing right now is I'm adding this host to the switch. Now, as soon as I do that, next what I want to do is I want to create the 2 VM kernel ports. I'm talking about the one for vMotion and the one for vSan. So how do we do that? We select the host and we go to the Configure tab. We go to VM kernel adapters and we click on Add Networking. Now the first VM kernel port is going to be, in this case, for vMotion. Make sure again that you remember in class we use DHCP, again, to speed up the demos. And make sure, of course, that if you do this, you remember to click on the box for vMotion. We use DHCP, so I expect to have an IP in the 172.20.12 network. If I see that, then I can move on. Let's take a look. There it is. Notice 172.20.12.209. And then I add one more VM kernel port. This one is going to be for virtual SAN. And again, this one is going to also use DHCP. And what I'm going to do here is I am going to proceed. And if I see an IP in the 10.10.10 range, then that means I did it right. Let's take a look. Perfect. The next step, all I have to do is drag them into the cluster. So at this point, this 5th host, all he's doing here, he is basically adding right now CPUs and memory. And the very next step, the very last step, if you will, would be the one where I create a disk group for that particular host. Then what that would do is it would grow my data store from 200 gigs onto 250 gigs. Let's make sure that this completes successfully. Okay. And like I said, the last step would be, I would go to the cluster. I would go to Configure. I would scroll down. And I would click on Disk Management. And then, of course, I would add X number of disk groups. Here in class, you would only be able to add one disk group with only one cache and one capacity device. So that concludes my first demo. Thank you guys. Go take a little break. When you come back, you get to see another way to add hosts. I'll see you in a few minutes. Thank you guys. Okay, then this is demo number 2 for lesson number 2. Welcome back, guys. So now, let's do something else. Now, in the previous demo, you saw me add manually a host to the cluster, and we grew the cluster size. Back then, of course, from 200 gigs to 250. Now, I want you to notice right now, I've added a 6th host. Now, this is for a future demo. So if you take a look right now, I could easily go to one of the hosts and notice again, right now my vSan data store is a lot bigger. Now I have 6 servers times 50 gigs, that's 300 gigs. Remember, you don't have to use the command line. For obvious reasons, I could go to the data store view. And again, what I could do here is I could actually choose SA vSan data store 01. And then I would see 300 gigs in the upper right. Now again, you can ignore this data store. If you take a look, I could try to unmount it, but again, this is for something else. Okay, so what we're going to do next is we're going to play with manually creating and taking apart things. Now, in the previous lesson, we were talking about adding disks to the disk group, adding more disk groups, removing a disk from a disk group, or removing disk groups. So that's what this demo is for. So let's take a look. Right now I have 6 servers in my cluster. All of them are pretty much identical. They all have one disk group. If I go to this management, notice you have 6 servers, one disk group per server, and every disk group, you can see, has one cache and one capacity device. So, during the lecture, we talked about claim and use disks, add disks, and so on. Now, let's see what happens in this case. If I click on claim and use disks, now I could use this. So in one shot, I could create maybe another disk group in each host. But you can see I don't have any more disks. So therefore, I cannot proceed here. Now let's say I hadn't seen that, and I just wanted to add a disk group in one host. What I would do at that point is I would select one host, and then I would create a disk group from here. But once again, I just told you, we don't have any more disks. All I would have to do here is choose which disk is going to be used for cache and which was for capacity. Now when you take a look here, you can see I can select the disk group. And if I wanted to remove a disk from a disk group, I would do it like this. I would select that disk, and again, I would choose remove disk. Now the problem here, once again, is that we only have one capacity disk in the disk group. So if you take a look, what would happen in this case if I try to choose, for example, full data migration? Now you can see again, I get a warning here, and it says, hey, this disk is about to be removed from the disk group, removing all HDD or SSDs from the disk group. Will remove the entire disk group. So I don't want to do that. And if you take a look, let's see what kind of message we get if we try to remove the cache disk from the disk group. Notice this choice is grayed out. I can't do that because, again, like I said before, I would end up with no disk group. In previous versions of vSan, you could do that, and again, it would just take apart the entire disk group. But notice now with the Vsphere client, you can't. You can't even proceed. So, if I needed to remove a disk group, one of the things that I could try to do is what? I could select, for example, a disk group, and I would click right here in the 3 dots. And again, from here, I could choose remove. So that would free up 2 drives. And again, you can see other choices, including, for example, recreate. I had to do that once. That was more for troubleshooting purposes. So when you take a look, you also have mount and unmount. And I'll explain that later on. So I just want to do a quick demo showing you all the possibilities. Now, if we want to remove a disk group, for example, we could try, just for kicks, to remove the one from one of the new servers. So remember, right now, my vSan data store is once again 300 gigs. Let's see what happens if I decide to delete the only disk group in that host. Once again, I click on the 3 dots and I choose remove. The system would ask me again what to do with the data. You have 3 choices: full data migration, ensure accessibility, and of course, lastly, no data migration. So I am going to go in this case with full data migration. Now remember, you could use this particular icon, but I'm just going to skip forward. And I'm going to say remove the disk group. If I look at the recent tasks, this should probably take about 30 seconds. Remember, the idea is technically I'm shrinking the vSan data store from 300 gigs to 250. And then that turns that host into a compute-only host. Now, I'm not saying I recommend that by any means, but again, you could technically, after the first 3, have hosts that all they bring to the table is CPU and memory. So let's take a look. It looks like it just finished. Notice the disk group is gone. And now I'm going to recreate it. I'm going to click on Create Disk Group. And I'm going to separate here the 5 gig drive. That's going to be my cache disk. And my 50 gig drive will be my capacity. I click on Create. A few seconds from now, I'm going to have a brand new disk group and 50 more gigs. So I'm going back from 250 gigs to 300 gigs. So hopefully you enjoyed that demo. Now we're going to do the last lesson of this chapter. I'll see you in lesson number 3. Thank you, guys. Welcome back. It's time for lesson number 3. And as you can see here, this lesson deals with upgrades and updates. Now let's take a look at this page. As usual, this is the learner objectives page. And here you can see that what we're going to be doing over the next few minutes is we're going to be talking about how to upgrade a vSan cluster. We're going to talk about best practices. We're going to also talk about, notice, how to evaluate supported upgrade paths and disk formats. And then finally, we're going to talk about upgrade recommendations. So let's take a look at this page. In this page, we're talking about upgrading your entire cluster. So at the very top, they tell you that the vSan upgrade process includes several stages. Think about it. On one hand, we're going to have to upgrade the vCenter server. We're also going to have to upgrade all of the ESXi hosts. If you want also, you could upgrade your distributed virtual switches. You could also upgrade the VMware tools, virtual machine hardware. But besides that, potentially you have to also upgrade the disk format version of every single one of the drives. Now, when you take a look, here it says, depending on the vSan and disk format versions that you're running, an object and disk format conversion might be required. And if that's the case, that could take a long while. Now, when you look at this page, here again, they're talking about best practices. So let's take a look at these. Number 1, you want to spend time planning the upgrade. You want to make sure you read the release notes. Learn about potential gotchas. Number 2, back up your data. Doesn't matter what RAID level you use, what FTP policy you use, back up your data. Now remember, you start by upgrading the vCenter server. And then through Lifecycle Manager, or in previous versions, Update Manager, you upgrade your ESXi hosts. Then you make sure everything looks healthy. And then after you make sure everything looks healthy, you realize, of course, at that point, whether or not you need to upgrade your disk format version. Once that completes, you want to make sure everything looks clean. So once again, you want to go to Skyline Health and make sure that everything is showing as great. Now let's take a look at this page. In this page, remember, you have to read the release notes. It's critical because you never know what, of course, to expect if you've never done it before. Number 2, you need to make sure that your hardware is still going to be supported if you upgrade to the next version. So you may want to look at the interoperability matrix. If you look at the bottom, remember, you want to make sure that in the hardware compatibility list, your servers are still supported in that version. But it's not just the servers. What about the controllers? What about your disks? What about your firmware? All those things are things to consider. And if you take a look, we've mentioned that again, you always start by upgrading Vsphere first. We start by upgrading the vCenter server. Remember, if you download the latest version of the vCenter server, if you open up the ISO image, there is a script that allows you to deploy a brand new vCenter. It allows you to upgrade the vCenter. It also lets you restore the vCenter if you ever backed it up using port 5480. And it also lets you migrate from the Windows to the Linux appliance. Once you do that, then remember, you move on to the ESXi host, and eventually, the last thing you do is you take a look and see whether or not you have to upgrade your disk format versions, whether or not you have to do a DFC, a disk format conversion. Now, when you look at this table, basically this gives you an idea of how you could go from one version to the other, what is compatible and what is not. Now, I'm not going to read this, but again, for example, if you have 6.7, there's no problem upgrading from 6.7 to 7.0 update 1. So take a look at this table, and obviously you can see that you could always do an upgrade, assuming that you have something fairly recent. Now, when we look at this page, notice again here it says the disk format upgrade is optional. I would say not really. I mean, yes, you can live without upgrading that. But again, typically you want to have the latest and greatest. I want you to notice the last statement in this page. Notice it says, after you upgrade the on-disk format, you cannot roll back. So again, there is no way if you change your mind to go back to a previous version. Just remember that. And when you take a look, once again, you want to make sure you do the upgrade while everything is healthy. So, bullet number 1, make sure you do this when all the hosts are up and running. You don't want to do this when one host is in maintenance mode or in the middle of a crisis. Let's say one host crashed. You want to make sure everybody has the same software version. You want to make sure all the disks and disk groups are healthy. And again, you want to make sure you don't have any broken or inaccessible objects. Now, when you take a look at this page, here, you can see that it's very easy with the Vsphere client to realize what version your disks happen to currently have. And again, remember, you have different version numbers for different versions of Vsphere in most cases. When you take a look, using the Vsphere client, you could use Skyline Health. And again, Skyline Health also has the ability to make recommendations. So when you take a look at this page, look at the left side, it says vSan build recommendations include patch and applicable driver updates. Notice it says to update the firmware on vSan 7.0 clusters, you must use an image with Lifecycle Manager. And if you take a look, remember, historically, we used to use baselines. A baseline is a fancy term to specify that you want to pick and install one or more than one patch. So when you take a look, here it says vSan build recommendations are provided through vSan system baselines. So if you take a look, I could, or actually, you know what? I would suggest that you actually take a look at Lifecycle Manager. Go to the home page, click on the icon for Lifecycle Manager, and then again, you're going to see the vSan baseline, which again gives you an idea of the things that could be upgraded. Now, when you take a look, this concludes this particular module. So if you think about it, this module had 3 lessons. We did a series of demos, and you had a couple of labs. Hopefully you enjoy it. I'll see you in the next chapter. Thank you, guys. Welcome back. So now it's time for this chapter. And this chapter, as you can see here, is called HCI Mesh using Remote vSan. So this chapter deals with a brand new feature. And again, that brand new feature is simply called Remote vSan. What do I mean by that? What I'm talking about is the ability of, in one cluster, mounting the remote vSan data store belonging to a second one. Now, when you take a look, here again, they're trying to explain to you why this particular topic is very important. Now, let's see what they say. As you can see here, it says, until now, compute and storage have been tied together. You know very well that, again, for the longest time, if you build a vSan data store, only the members of that cluster could use that vSan data store. Well, that's no longer the case. Again, now you can mount somebody else's vSan data store. Now, if you take a look, it says with HCI mesh or remote vSan, call it what you will, you can scale storage and compute independently. Which means, once again, if I need more space, I could now access the data store belonging to a different cluster as long as both clusters are controlled by the same vCenter and they happen to be on the same data center. Now, this chapter has 3 lessons. The first one is simply called HCI Mesh Overview and Use Cases. The second one is the one that shows you how to mount the vSan data store. And lastly, we talk about how this is or is not compatible with other features of Vsphere. So we're going to be talking about the relationship between HCI Mesh and HA, DRS, vMotion, and storage vMotion. So let's start with the first lesson. What I have done here is I have built 2 different clusters. On purpose, I build them a little bit different. There's a reason for that. And again, what I'm going to show you is how I could take the first cluster that I have. He has access to his, obviously, data store. I'm going to show you how now you can say, gee, if you belong to the first cluster, not only you get to see your vSan data store, but you also get to mount the vSan data store belonging to my second cluster. And the first cluster can mount the vSan data store belonging to the second, just like the second can also mount the one for the first. So here we see the goals of this first lesson. So instead of reading all these particular bullets, again, all I want to do is talk about what this is, what it brings to the table, do's and don'ts, best practices, and so on. So let's start with this page. Again, here, you can see the page says Introducing HCI Mesh. So once again, this is a brand new feature. And a lot of people have been asking for this. Once again, a lot of people have been asking, how is it that you can only have one vSan data store per cluster? Now, that's no longer the case. Because again, you can have yours. And you could also access somebody else's. So when you take a look, here it says with the HCI mesh architecture, you can remotely mount data stores from other vSan clusters. These would be the server clusters to one or more vSan clusters. Those would be the client ones. So in my analogy before, if I take cluster 1 and I mount the vSan data store belonging to cluster 2, cluster 1 here is the client cluster, and cluster 2 is the server cluster. Now, when you take a look, for years, people have been asking for this feature. Because think about it. When you build, let's say, X number of clusters, what happens sometimes is that you end up with one cluster that is running out of space and the other one that is not. So that's what they're showing you here. Here again, they're showing you that you have the first cluster. He is at 40% capacity. Yet the second one has reached 80%. So let's break this down. Before 7.0 update 1, if that happened, remember the servers on the second cluster could not access the vSan data store of the first, but now they can. So what I could do is I could storage vMotion some of the VMs from the second cluster into the data store of the first cluster while they're using CPU and memory on the second one. And again, balance space between the 2 vSan data stores. So you no longer waste resources like you used to in the past. And if you take a look, here we talk about the advantages of HCI Mesh, and there are plenty. I mean, think of the possibilities. A minute ago, I mentioned that you could storage vMotion the VMs to balance space. But think about other possibilities. For example, let's say you want to do maintenance when it comes to the disks of the first vSan data store, while the VMs are using CPU and memory on that cluster. Temporarily, those VMs could be using space somewhere else. So if you take a look, number 1, it improves the storage to compute ratio. Number 2, notice they mention license optimization. Number 3, heterogeneous storage classes. One of the cool things, and I love that, one of the cool things about this feature is that I could have 2, for example, clusters. Maybe one is using, let's say, NVMe devices. Let's say another one is using SSD devices. Can I mount the vSan data store belonging to the other cluster if the disks are different? The answer is yes. So again, then I could choose, for example, where to store my critical VMs, where to store my secondary VMs. And again, I could mix and match different types of disks, not just NVMe with SSDs, but also what about magnetic drives? Yes, you can. So that's pretty slick. And when you look again at this example, here you can see you have 3 clusters altogether. This is what they call a vSan cluster federation. And again, you can see that the second cluster is overused. So notice carefully in this drawing, in the second cluster, you have 4 VMs running. 2 are used in the local data store. And the other 2 are using remote vSan data stores. Now, when you take a look at this page, in this page and the next page, we talk about use cases. So, once again, you got to think of the possibilities. And if you look at the first one, we've already mentioned that. You can balance capacity across vSan clusters. Notice it says HCI mesh can be used for balancing capacity. That probably will be the most common reason to use this. Once again, you realize that you're running out of space in one, mount the remote vSan data store. It takes about a minute. And then at that point, just storage vMotion your VMs. But what about hardware maintenance? Once again, imagine that in the first cluster, you decide to enable a feature that perhaps will require a DFC. Typically, you're talking about moving data around. In this case, what you could do is simply just storage vMotion all the VMs out of there. And then again, without having to worry about taking chances in absent components, you could again perform the DFC safely. And if you take a look, bullet number 3, this is the one dealing with storage as a service. So again, you could mix and match different types of data stores. One could be all flash. One could be based on magnetic drives, aka the hybrid architecture. And then you decide where to place the different VMs, depending, of course, of the needs that they have. And if you take a look here, they continue talking about the reasons to use HCI mesh. So notice, scaling compute without adding storage. And if you take a look, it says traditional vSan scales by adding hosts. Remember, that is scaling out. And again, that may not be what you want. So notice it says you may end up with too much storage because of that. In the past, again, you'd be wasting that storage. So again, think about it. Maybe you just need more CPU and memory, but you don't necessarily need more space. Right? So again, think of all the possibilities out there. And if you take a look, it says you can use HCI mesh to scale storage and compute independently of each other. Technically, you could even build clusters without a local vSan data store. And again, they just mount the remote vSan data stores. And we've already talked about how you can save money because of license combinations. Now, the main thing here is stranded capacity. Once again, we're not wasting resources like perhaps you were doing in the past. So here it says a fixed compute to storage ratio can lead to a stranded capacity problem. So once again, in this case, you could repurpose, if you will, that space that otherwise it would go to waste. And when you take a look, we've already talked about this. So imagine if I have 3 clusters and I want to mount all the vSan data stores in all the clusters. This gives me complete flexibility. So now imagine that I have a different type of workloads. On one hand, maybe a database. Maybe on the other one, maybe, I don't know, let's say some kind of Apache server. I'm talking about something like a web server. They have different requirements. So like they tell you here in the book, Maybe you have an Oracle database. Maybe you have an SQL server. You want to put those type of VMs in the fastest storage. Having said that, when it comes to a web server, maybe you don't need NVMe devices for that. Maybe you don't even need SSDs. Maybe again, you're just happy by putting those VMs in your hybrid architecture. Or again, perhaps you put your test VMs in the hybrid architecture and your prod VMs in your faster storage. So when you take a look, here you have a scenario where you have 3 clusters. And as you can see here, everybody's running VMs. Some of them are local, some of them are remote. Take a look at the cluster on the bottom left. He has 4 VMs. 2 reside in the local vSan data store. Another 2 happen to be running on that cluster, yet the objects happen to be on the other vSan data store. The second cluster, once again, has 4 VMs. Notice the fourth one. The fourth one is running on the second cluster, yet it resides on the third vSan data store, and so on. And if you think about it, over the next few pages, what we have is terminology. So notice here they mention local cluster, server cluster. And if you take a look at the next page, the concept of the local vSan data store, the concept of the remote vSan data store, and the concept of cross-cluster vMotion. So if I'm a member of cluster 1, if I have my VM in my local vSan data store, that would be what? Local vSan data store. If I store vMotion that to the second data store, to the one belonging to the other cluster, that would be an example of a remote vSan data store. And remember, in that case, I am the client. The cluster that controls the second data store, he happens to be the server. Now, when you take a look, here over the next few pages, I show you examples of your type of architecture. So here they mention cross-cluster topology, and they also mention storage-only cluster topology. So the idea here is what? I can mount yours, you can mount somebody else's, or I can mount yours, and you can mount mine. So that's what I currently have. So let's take a look at this illustration. Now, if you take a look here, we have 4 clusters. Notice the first cluster, the one on the upper left, he has a local vSan data store, but he also mounted a remote vSan data store belonging to the cluster in the bottom. If you look carefully, the middle cluster at the top, he only has a remote vSan data store. So in that case, remember, you could technically have a cluster without a local data store, because maybe you don't want to use more disks. Maybe you don't need that because you have extra capacity elsewhere. So again, think of, once again, the possibilities. And if you take a look, here you have an example of a cross-cluster topology. Once again, here I have mine, I mount yours, and you have yours, and you mount mine. Notice, everybody's mounting pretty much everybody's. Now, right now, this is what I currently have in my setup, and I'm going to show you that in a second. So when you take a look at the requirements, here they mention network connectivity requirements and also latency requirements. Let's take a look. When it comes to network connectivity requirements, take a look at bullet number 1. Notice it says both layer 2 and layer 3 are supported for inter-cluster connectivity. If you take a look at the rest of the page, notice it says network redundancy recommendations. You know very well that we always recommend redundancy everywhere. And notice they mention top of the rack switches. If you take a look, here notice at the bottom, they talk about network performance requirements. An HCI mesh has the same requirements for remote vSan data stores as if it has for local vSan data stores. Here you have an illustration where you can see the top of the rack switches. And again, we have different pages to deal with. So here again, we're talking about licensing. So when it comes to this, I've mentioned, right, that I can mount your vSan data store, you can mount mine. But you probably know that we offer different licenses when it comes to virtual SAN. Notice at the very top, We tell you what license you need, and it says vSan Enterprise Edition is required on all the clusters participating in a mesh topology. At the bottom of the page, they also tell you that a client cluster can mount a maximum of 5 remote vSan data stores. And if you take a look, that concludes lesson number 1. Now, what I'm going to do here is I am going to show you what I currently have. And again, in my setup currently, I have 2 clusters, a 5-node cluster, a 3-node cluster, and I have mounted the remote vSan data store in both cases. So let's take a look. Thank you, and I'll see you when I do my little demo. Okay, guys, so let's take a look at what I currently have. As you can see here, I have 2 clusters. Once again, I want to emphasize that one cluster is a 5-node cluster, another cluster is a 3-node cluster. Now, let's take a look. If I select my first cluster, I am going to go to Configure. And what I'm going to do here is I'm going to go to Data Store Sharing. As you can see here, this cluster can see 2 data stores, his own and the remote one. The way you mount a vSan data store, a remote one that is by clicking here. And if you change your mind, you can select one of the data stores and choose and mount. If I go to the second cluster once again can see his, and it can also see the one belonging to the first cluster. And if you ever go to the command line and you pick one host, take a look what happens when I type df-h. Here you can see, for the first time ever, we get to see 2 vSan data stores, not 1. You can see how big they are. You can see how full they are. And once again, you could access the mount point for the 2 data stores, not just mine, but the remote one as well. So I wanted to show you that before we get to lesson number 2. Hopefully, again, you enjoyed seeing this. And again, you're going to have a lab that you're going to be performing later on. Thank you, guys. Welcome back. So now it's time for lesson number 2. And as you can see here, this lesson is called HCI Mesh Operations. This is the lesson that shows you how to mount a remote vSan data store. It shows you what you expect to see as you look at the Vsphere client. So let's start. Now remember, I have 2 clusters, and on purpose, and I'm going to show you this, my 2 clusters are a little bit different. One has 5 nodes, one has 3. I want you to remember that. Now, if you take a look, here we see the goals for lesson number 2. So let's go through them. Number 1, I'm going to show you how to mount a remote vSan data store. That's very easy. It's not really rocket science. You'll be able to do that in no time whatsoever in the Vsphere client. Number 2, we're going to explain exactly what you see from the server side and from the client side. Next, it says we will explain cluster health with VM creation test. Remember, you can run a proactive test. This time around, you could run a VM creation proactive test, and you could choose your local data store or the remote data store. And then lastly, notice it says we will describe the remote object placement on the GUI. So once again, it should be very easy to make sure that you can see that your objects now reside on a remote vSan data store. And if you take a look, remember this is a brand new feature in 7.0 Update 1. So when you take a look at this page is called Introducing HCI Mesh Operations. Remember, here they're telling you that if you want, you can mount somebody else's vSan data store. There are certain gotchas. Remember, both clusters need to be in the same data center. They need to be controlled by the same vCenter server. And you can see that's what they tell you here. Also, this is not for 2-node clusters or stretch clusters. So this is for regular vSan clusters. Now let's take a look. What exactly are we showing you here? Now imagine I log into the Vsphere client. And let's say I am on my first cluster. But there's a second cluster. So I want to mount the vSan data store belonging to that second cluster. So what do? What I do is I go and I select my cluster. I go to the Configure tab. And in this section for vSan, as you can see here, you find the option Data Store Sharing. So all you have to do is click on Mount Remote Data Store. Now, if you take a look, here you can see in parentheses that the GUI is telling you which one is your vSan data store. So in this case, you can see I'm working with a cluster called SA Cluster 01. Now, as you can see here, his data store is called vSan Data Store Cluster 1. So that is your local data store, but you want to mount somebody else's. So when you click on Mount Remote Data Store, you better believe you're going to be able to see the one belonging to the other cluster. And if you take a look, that's what we show you here. So all you have to do is simply select that particular data store. Now, when you click on Next, the system will show you whether or not this will work. And you can see again, you have a whole section for what needs to be compatible or not. Now, let's take a look at some of these without reading every single one of them. Now, the first one is a check that tells you that the remote data store indeed is a vSan data store. I've never seen that fail. Notice it says the select the server cluster is remote. Cluster configuration is supported. That's an interesting one. I'm going to show you two instances where I successfully mount the vSan data store and another instance where I cannot. For example, the first time around, if both clusters pretty much look the same, you better believe that's going to work. But in my second demo, what I'm going to do is I am going to try to mount the vSan data store belonging to another cluster. But this time, I'm going to have on the second cluster, data in transit encryption enabled. And you will notice that will make it fail. So again, we talked about that briefly when we were talking about security. Now notice, here you can see images where it says, SA vSan 01 is mounting no more than 5 remote vSan data stores. So remember, I can mount yours, you can mount mine, but again, there's a limit on how many I can mount. So when you take a look, by the time you're done, you're going to see 2 data stores, just like I show you here. You can see one of them says local. Obviously, the other one is the remote one, the one that doesn't really belong to you. Now, you can see here all sorts of information. So for example, if you look at the upper left, you can see that I am working with SA Cluster 01. So when you look at the data stores, notice the first one, in parentheses, it says local. So you know that's yours. But if you look at the second one, it doesn't say local or remote. But if you go towards the right, you can see you are the client cluster. Because again, notice your name is there, SA Cluster 01. And when you take a look, here is where the other cluster will show you. So in this case, I'm looking at Cluster 02. Cluster 02 says, I have my own local data store. I haven't mounted somebody else's data store, but I do have currently a cluster that happens to be my client. So when you look towards the right, from Cluster 2, you can see that Cluster 1 is your client. Now, when you look at this capture, here, notice what they're doing. They're selecting a data store. They're choosing hosts, and this shows you all the hosts that can access this data store, the ones for the local cluster and the ones belonging to the other one. Notice, in this case, we have the data store for the second cluster, yet you can see that we have X number of servers belonging to a cluster called SA vSan 01 and X number of servers belonging to SB vSan 01. Now, what they tell you here is that if you want, you can very easily run a proactive test. We've talked about this test before, but in this case, I want to run this proactive test. I want to create temporarily VMs, but I want to test the creation of the VMs on that remote data store. So you can choose that. And you better believe you're expecting a positive result. As you can see here, they have run the test. It says passed. And once again, you can see exactly the results. Now, if you take a look at this, here we're talking about Skyline Health. Remember, this is your best friend for troubleshooting. So if we introduce new features, you better believe that we're going to have a new section of that feature in Skyline Health. And as you can see here, notice you can see information about your local objects and also remote accessible objects. In this case, everything looks good. And this is what you want to see. So when you take a look, another thing that you could do is see whether or not you have a partition. Remember, if I have 4 servers and you have 4 servers, all 8 of us need to be able to communicate with each other to be able to access the same vSan data store. So this is a way to once again troubleshoot your environment potentially, assuming that you have some kind of network issue, which results in a network partition. And when you look at this page, what do we see here? As you can see here, we're showing you performance-related charts. Remember, this goes back to the performance service. This time around, if you notice, we have a new section. And again, that section is for remote VMs. So you can see the type of performance that you're having when you have a VM running, for example, in cluster 1, yet the objects reside on cluster 2. And when you take a look, if you look at the physical displacement, the way that you can very easily tell that your VM resides on a remote vSan data store is by looking, and obviously if you can read that it says remote accessible, once again that is telling you that that VM again is running in one cluster, yet all the objects happen to reside on a second cluster. Now remember, in a second, I'm going to do a quick demo. And when I do that demo, I'm going to show you this succeeding, but then again, I'm going to do a second demo. And I am going to show you in the second demo this failing. All right, I'll see you when we do the demo. Enjoy. Welcome back. So as promised, we're now going to play with remote vSan. And I'm going to do 2 demos. I expect the first demo to succeed. I expect the second demo to fail. I've mentioned why. But before I do that, I want you to notice my setup. Right now, you can see that I have a 5-node cluster and a 3-node cluster. There's a reason for that. Remember, one cluster has enough ESXi servers to be able to run a RAID 5 VM. The other one does not. So that's why I build them a little bit different. So I'm going to start by mounting the vSan data store belonging to the second cluster in the first. So let's take a look at SA vSan 01. This is my 5-node cluster. So what I'm going to do here is I'm going to putty into that host. Let's take a look. Right now, you can see that if I type df-h, this host can see only one vSan data store, and that is SA vSan data store 01. That's about to change, or at least it should. So what I'm going to do, as mentioned earlier, is I am going to select that cluster. I'm going to go to configure, and I'm going to go to data store sharing. Now, right now, remember, I only see my local vSan data store. So remember, the local one is SA vSan data store 01. Now I want to mount the one belonging to the second cluster. So I'm going to click on Mount Remote vSan Data Store or Mount Remote Data Store. And here you can see automatically, I only see the one belonging to the second cluster. So all I have to do is select that second data store. Click on Next. And here I'm going to see all those compatibility checks. And notice, as mentioned, I expected everything to be healthy. I expected everything to look good. Notice, I haven't exceeded the limit of 5 remote data stores. Notice both my clusters are controlled by the same vCenter. Both happen to be in the same data center. And if you take a look, notice it says, for example, vSan format version supports remote vSan. That means what? Both my clusters are running Vsphere 7.0 Update 1. Now remember, you cannot do this if you're trying to mix one running 7.0 Update 1 with something older. So at the very bottom, you can see that there's also a latency check. Notice it says latency between client and server is below 5,000 microseconds. So I'm going to click on Finish. And again, this should work Like I said, this is not too complicated. I expect in a few seconds to be able to see 2 data stores here. Now let's take a look at the recent tasks. Notice something is happening. Like I said, this will take a few more seconds. And what we want to do now is wait. Obviously, it happened now. We want to wait until the GUI refreshes. And now I can see 2 data stores, mine and the one belonging to the second cluster. So if you take a look, I have my local data store. That is the one called SA vSan Data Store 01. And I have the second one, which again, you can see is not my local one. And once again, I am the client for that second one. Now, what I want to do now is I want to take a look at some of my VMs. And I want to try storage vMotion. Remember, my second cluster has 3 hosts. What does that mean? That in that second data store, I can only put VMs that happen to be, for example, two-way mirrors. But I cannot, for example, there, put a RAID 5 VM. So let's take a look. What I'm going to do in this demo is I'm going to take a look at a couple of the VMs in the first cluster. Now let's take a look at the very first one. Now the very first one is this is the very first one. The very first one should be RAID 5. Let's see if I'm right. There it is. You can see the second one is going to be using the default policy, aka this VM is a two-way mirror. So I should be able to right-click on SAVM02. And again, I should be able to storage vMotion this VM. I'm going to choose migrate. I'm going to choose change storage only. Remember, I'm doing storage vMotion. And if you take a look, I should be able to choose the second vSan data store. Now, I'm going to click on next, and I'm going to click on finish. So again, that should be no problem. Let's take a look, make sure this succeeds, and then we'll do another demo. Almost done. Perfect. Notice it succeeded. Now, what I'm going to do is I'm going to putty into one of the hosts belonging to the second cluster. And I am going to go and obviously go to VMFS volumes. And then from there, I'm going to go to the mount point for SB vSan Data Store 01. If you take a look, you can see the folder for that VM, the one that I just stored vMotion, appears here. I can do the same thing with the GUI, but I prefer in this case to show you the command line. Now remember, if I type df-h here, I only see one data store. But if I go back to SA ESXS01, I should expect to see 2 vSan data stores. Perfect. Now, let's try to mount a second VM. Not mount, but actually I should say migrate a second VM. This time I am going to try to migrate SAVM01. Remember, this one is RAID 5. So let's see what happens. I am going to right-click on that VM. I am going to choose migrate once again. I'm going to choose change storage once again. And if you take a look, if I want to keep my existing virtual machine storage policy, notice it tells me that it is not compatible with the second vSan data store. I'm talking about SB vSan Data Store 01. If you take a look, remember, this one only has 3 hosts. This one has nothing more than 3 disk groups. So I would need really 4 full domains. I don't have it. That's why I built them differently. So I wanted to show you that. So that concludes my first demo. Now what I'm going to do in a second is I'm going to show you this failing. So if you think about it, what I want to do now before I forget is I want to move this VM back to where it belongs. So what I need to do in this case is I need to right click on that VM and I'm going to migrate this VM back. Let's put it back on SA vSan Data Store 01. You know this will take about a minute. And then I am going to unmount that remote vSan data store. Let's take a look. Perfect. So I am going to go back to that cluster. And if you take a look, what I want to do next is I want to select SB vSan Data Store 01, and I want to choose Unmount. Once again, this should take a few seconds. Let's make sure that again we wait. And then before I try to mount it again, what I'm going to do is I'm going to go to the second cluster, and I am going to enable on the second cluster data in transit encryption. So let's take a look. Let's go to SB vSan 01. Let's go to configure. Now I'm going to go to services. And what I want to do next, as mentioned earlier, is I want to enable data in transit encryption. Remember, this is a brand new feature in 7.0 update 1 as well. But if you think about it, this again is not going to be compatible. Let's wait a few seconds. Once again, this should take a few seconds. And then we're going to try to mount the vSan data store again. Remember, the second time I expect it to fail. All right, so it looks like it just completed. So let's go back to the first cluster. Let's see what happens. I choose data store sharing. I select Mount Remote Data Store. I get to choose the second one. Now remember, you can see the data store, but this is going to fail or should fail. If I click here, notice again the system complains, and it tells you specifically why this is not going to work. You can see it says there is a problem when it comes to cluster configuration being supported. And you can see it says data in transit encryption is not supported for either client cluster or server cluster. So that ends my second demo. Hopefully you enjoyed it. I'll see you in lesson number 3. Welcome back, and hopefully you enjoyed that lab. So now it's time to cover lesson number 3. And as you can see here, this lesson is called HCI Mesh Interoperability. So let's take a look at the goals for this particular lesson. Over the next few minutes, what I want to do is explain the relationship between HCI Mesh and HA. I want to do the same thing when it comes to HCI Mesh or remote vSAN and SPBM. I'm talking about virtual machine storage policies. Number 3, I've already shown you my demo that you could always storage vMotion your VMs from one cluster and of course one data store to the same cluster and a second different data store. You better believe you could also migrate a VM. I'm talking about vMotion, cross-cluster vMotion. That is compatible. And then lastly, we'll talk about the relationship between HCI Mesh and DRS. So let's take a look at this page. In this page, we're showing you different potential issues that you may encounter one day. If you look at the 3 bullets, what we're showing you here, number 1, is a network partition in the server cluster. Number 2, a network partition in the client cluster. And then lastly, loss of connectivity between the client and server clusters. I want to talk about number 3 in particular. Imagine out of the blue, your VM is running on, let's say, cluster number 1. And for whatever reason, cluster number 1 no longer sees the data store belonging to cluster number 2. What do we do about that? What do we expect? And that's what they mention on the next page. So in this page, we know that when we build a vSAN cluster, we need HA. HA is in charge of restarting the VMs. Now, historically, we don't use VMCP with vSAN because, again, typically this is for remote storage, external shared storage. Now, for the first time ever, now we're talking about having a vSan cluster with not only his data store, but also a remote one. So what they're telling you on this page is that you should, in this case, enable and configure VMCP, Virtual Machine Component Protection. Now, what they try to tell you here is that out of the blue, if you have a problem and you don't get to see the remote vSan data store anymore, at that point, what's going to happen is you're going to have an all path down situation, an APD situation. And if you look at the last two statements in this page, notice it says, when the cross-cluster communication fails, an APD situation is going to be declared automatically after 60 seconds. Now, if you look at the last paragraph, it says an APD response is going to be triggered to automatically restart the virtual machines after 3 minutes or 180 seconds. Now, when we look at this page, this goes back to my previous demo. In my previous demo, I showed you what would happen if you try to, for example, storage vMotion, a RAID 5 VM, onto the data store belonging to a 3-node cluster. And you saw, of course, that that failed. Now, why did it fail? Because remember, you have one vCenter. You have one VASA provider. And if you think about it, with HCI Mesh, the vCenter now is aware, not only, of course, of the requirements of the VM, but also the fact that this VM is trying to move, let's say, to the data store belonging to a host that does not have enough full domains. So just like I showed you that it would fail with storage vMotion, imagine if I go to my 5-node cluster, I decide to create a RAID 5 VM, but I decide to store it on the remote vSan data store. Would that work? And the answer is, of course not. Once again, as you can see here, you have one VASA provider. And again, it is still one cluster and one VASA provider. Now, when you take a look at this page, here they continue talking about SPBM and its relationship with HCI Mesh. So notice it says additional points about storage policy-based management operations with HCI Mesh clusters. And here you have 2 bullets. Notice it says only hosts in the server cluster can respond to SPBM commands. And notice number 2, vSan VASA provider ignores the client cluster hosts. Now, when you take a look at this page, remember, I've already done a demo where I showed you that yes, storage vMotion is compatible with HCI Mesh, as long as, of course, the VM uses a policy that can be satisfied by the second vSan data store. So here what they tell you is that if you want, you can storage vMotion a VM. You could also vMotion a VM. So I'm going to do another demo perhaps. And again, I'll show you maybe what happens if I try to create a VM on a remote data store. And again, we don't have enough full domains, similar to my previous demo. And again, we'll do some kind of vMotion operations. Finally, here they talk about the relationship between remote vSan and Vsphere DRS. So if you think about it, we know that DRS is the automation of vMotion. So let's say I have a 5-node cluster. Now let's say I decide to migrate a VM from the first host in that cluster to the second host in that cluster. If that VM resides on a remote vSan data store, will that work? And the answer is yes. I mean, after all, if I can manually vMotion, why wouldn't I be able to automate that? So on that note, that takes care of lesson number 3. Once again, I'm going to do one more demo, and then we're done with this chapter. Thank you, guys. I'll see you in a few. Okay, guys, it's time for another demo. And a minute ago, we finished talking about how HCI Mesh, aka Remote vSan, is compatible with storage vMotion, with vMotion. Once again, we talked about HA and we talked about DRS. So, first, let's take a look at what I have. Notice in this case, I have gone to the first cluster. And in the first cluster, I have two vSan data stores. So the first cluster has his data store, and it has access to the data store belonging to the second cluster. And I went to the second cluster and I did the same. So again, I mount your vSan data store, you mount mine. Now, in the previous demo, I showed you that you weren't able to store vMotion a VM that was RAID 5 into the second vSan data store because the second one had 3 hosts. Now, take a look at these demos. Number 1, I am going to try to create a VM from scratch. So when I create this VM, I'm doing this on the first cluster. I am going to call this VM Javier02. And what I'm going to do is I'm going to try to put it on the second data store. So again, I choose the first cluster. I choose RAID 5. Let's take a look. I have the RAID 5 policy. And you can see once again that this is not compatible with SB vSan data store 01. So just like I wasn't able to store vMotion, a RAID 5 VM into a data store comprised of only 3 hosts, same principle here. I'm not able to create a RAID 5 VM if I try to put it on the second data store for obvious reasons. Now, we're going to take this particular VM. This is SAVM02. Currently, this VM is located on the local vSan data store. Now, just like before, I'm going to migrate it. So we're going to store vMotion this VM. We're going to put it on the second vSan data store. Remember, this one is a two-way mirror VM. So this should work. Now, if you take a look, I'm going to click on Finish. We're going to look at the recent tasks. And in a few more seconds, this should be done. This should succeed. As soon as basically we do that, I am going to vMotion the VM around. So let's take a look. Okay, so now that VM resides on the remote vSan data store. Now, if you look at this VM is currently running on SA-ESXi04. So the question is, can I vMotion this VM? Not stores vMotion, I'm talking about vMotion here. So if you take a look, in this first test, I'm going to choose Change Compute Resource Only. And what I'm going to do here is I'm going to choose another host in that first cluster. Once again, if you take a look, we can see again this VM currently was, let's do cancel. Let's take a look. This VM again was on SA-ESXi04. So we're going to take this VM, we're going to choose Migrate. And once again, I'm going to choose vMotion. And I'm going to move it to SA-ESXi01. Remember, that host is a member of the same cluster. So this should work. I don't see why it wouldn't work. I'm going to click on Next. I'm going to click on Next. And I'm going to click on Finish. So all I did here was I migrated the VM from one host in the first cluster to another host in the first cluster. Perfect. One more test. Now the question is, can I migrate this VM into something like SB-ESXi01, which is a host in the other cluster? Let's find out. Right click, migrate, and if you take a look, I'm going to choose once again, Change Compute Resource Only. I'm going to choose one of the other hosts. Why wouldn't this work? You know very well that nowadays you could always do cross-cluster vMotion. Let's take a look. Oops, we have a problem with the network here. No big deal. Let's just pick. There we go. Let's pick this one. And there we go. Let's take a look, click on Finish. And again, this should succeed. So remember, the error that you saw there temporarily had nothing to do with the vSan. That was, again, about the lack of compatible networks. And voila, notice you've seen me storage vMotion the VM and vMotion the VM twice. First between two members of the same cluster, and now to a member of the second cluster. Hopefully you enjoyed that demo. I'll see you when we start the next chapter. Thank you, guys. Welcome back. It's time to deal with stretch clusters and two-node clusters. And that is what we're going to cover in this lesson. Now, if you take a look at this module, the module is called Managing Advanced vSan Cluster Operations. Now, as I mentioned a second ago, in this chapter, we're going to be dealing with two different topics. And again, these two topics were introduced back in vSan 6.1. As you can see here, first, we are going to talk about stretch clusters. Then, we're going to be talking about two-node clusters. And you're not going to have one lab or two. You're going to have 3 labs at the end of this module. What I'm going to do is I am going to lecture. We're probably going to take a break in between. I'm going to do a couple of demos. And then again, you get to do 3 labs. Here you can see it says the vSan stretch cluster is a solution that is implemented in cases where disaster avoidance or swift disaster recovery is important. So we're going to talk about the architecture of stretch clusters because it's very different than the architecture of a regular vSan cluster. You can see the goals here. Once again, let's keep it simple. First, we talk about stretch clusters. Then we talk about two-node clusters. And in my demos, what I'm going to do is, on one hand, I am going to show you how to create a stretch cluster. On the other hand, I'm going to basically take apart one of my clusters and I am going to create a two-node cluster. So you get to see everything. Now remember, with a two-node cluster, you're talking about 2 physical ESXi servers. You still have a third instance of ESXi. Typically that is a nested ESXi server, meaning an appliance that you download for VMware. And that third instance is there to store components only. I'm talking about not components when it comes to replica components, but I'm talking about witness components to be more precise. So let's take a look at this particular page. Now in this page, the first thing to understand is that if you're working with stretch clusters, you're talking about having 3 different locations. Now why 3? If you look at the illustration, you have what we call a preferred data site. Now, the idea here is in that data site, you can have up to 15 ESXi hosts. You have a secondary site. In that secondary site, you're going to have another 15 or up to 15 ESXi hosts. On the third location, you're going to have your witness host. So the first thing to understand when it comes to stretch clusters is you cannot have a 64-node cluster. When you hear or read about stretch clusters, sometimes you will hear about 31 host maximum. Now why 31? 15 physical hosts plus 15, 30. The 31st would be the one that stores your witness components. So sometimes you hear 15 plus 15 plus 1. Sometimes you hear 31. Sometimes you hear 30 plus 1. So just remember, 30 physical ESXi servers max. And ideally, you should distribute your physical ESXi servers evenly between the 2 data sites. You need to understand that these 2 data sites can actually be both active. So you can be running VMs both in your primary or preferred data site and your secondary one as well. So if you look at this page, here it says vSan stretch clusters can be used in environments where disaster and downtime avoidance happen to be key requirements. So we're talking about a feature that was introduced in 6.1. And back in 6.1, we had certain limitations. Now back in 6.1, your VMs had to be 2-way mirrors. That means you had one submirror in your preferred data site, another submirror in the secondary data site, and you had your witness components always on the witness host. So the idea back in 6.1 is it was quite simple. You had one choice. No RAID 5, no RAID 6, just two-way mirrors. So the idea was if your VM was running your preferred data site, if something were to happen to your preferred data site, let's say you lose power to your entire data site, those VMs, for obvious reasons, would crash. Because after all, they were using CPU and memory in those hosts. But because you had another sub-mirror in your secondary data site and the witness, I'm talking about the witness component on the witness host, that VM would restart because of HA in your secondary site. So you could have, again, VMs running both in your preferred site and secondary site. Now, there's a reason you have a preferred site. We're going to be explaining that in a minute. Notice it says a stretch cluster extends across two active data sites. So again, both can be active. You can have VMs running in both locations. Now, we're going to be talking about what happens when you have network issues, for example, between the two data sites in a minute. And if you take a look, remember, we introduced this in 6.1, but we've made a lot of changes to this. So I just described a second ago what you had back in vSan 6.1, which again was Vsphere 6.0 Update 1. Now, one of the things that you need to do when you set up a stretch cluster is set up DRS affinity rules. And when you set up these rules, if you want these VMs to potentially run in both sides, you need to make sure that you use words like should run or should not run. Never use must run or must not, because that defeats the purpose of a stretch cluster and restarting the VMs in another location. Now, we're going to be talking about limitations when it comes to, for example, maximum latency between, again, the two different data sites. So it's not like you can have, let's say, a preferred data site in LA and a secondary site in New York. That's not going to happen. There are certain limitations. We need to talk about those. But again, fundamentally, the idea is quite simple. Once again, we're talking about VMs with two copies of the data, one in one location, one in the other. One entire location goes down for whatever reason. Push come to shove, the VMs will restart in the other location. Now, when you take a look, you could use this for a variety of reasons. So in this page, they mention, for example, automated recovery. So I mentioned a second ago the fact that you could lose power. For example, many years ago, I was teaching in Key West, Florida. Now, in that scenario, that time around, I was told, don't bother coming tomorrow because tomorrow we're not going to have power. So in that case, we knew that was going to happen. So if you know it's going to happen, then you could use stretch clusters for planned site maintenance. So before you lose power, you migrate the VMs to the secondary location. But I went to school in LA. Now in LA, you have something called earthquakes. You don't see them coming, trust me. Bottom line, you could have different locations. Maybe one location is affected by an earthquake. Your VMs crash and they restart on the other location. So if you think about it, right, they're talking about planned site maintenance. They're talking about preventing service outages resulting from site failure or automated recovery. Now, when you take a look at this page, once again here, you can see that they're mentioning 30 physical host MACs. So altogether, 15 plus 15 plus 1. And you can see here the overall idea. Once again, a VM is going to be a two-way mirror VM, one sub-mirror in one location, the second replicate component, aka sub-mirror, in another location. Now, when it comes to networking, you need to understand that in a perfect world, everybody can communicate with everybody. So the way that it works in vSan, you always have a master host, you have, let's say, a backup host, and everybody else is an agent. Now, in a stretch cluster, your master is going to be in your preferred data site. Your backup server is going to be running on the secondary data site, in this case, data site 2. Now, these two entities, these two hosts, need to ping each other. They need to communicate with each other to make sure that the other one hasn't gone down. But these two entities also need to ping the witness host. And remember, the witness host needs to run in the third location. Because if it was run, let's say, on data site 1, If you lose data site 1, you automatically lose the majority of the votes for any VM. So having said that, when it comes to connectivity, you can see that we mentioned layer 2 networking between the two data sites. We also mentioned layer 3 networking between data sites and witness site. Now, if you take a look at this page, notice carefully at the drawing. Here they're trying to explain to you what happens when you have a network failure between your primary site and your secondary site. There is a reason one of your data sites is going to be your preferred data site. Should your primary data site not be able to communicate with the secondary site, if both of these sites cannot communicate with each other, but both can communicate with the witness host, what's going to happen here is the VMs running on your secondary site will be powered off and they will be restarted in your primary or preferred data site. So that's why we have one of them called your preferred site. Remember, in a few minutes, I'm going to be doing a demo and you're going to see those words preferred and obviously non-preferred. Now you can rename those data sites. So what I'm going to do is, on purpose, just to show you this, I'm going to rename them and I'm going to call them data site 1 and 2. And remember, the witness, which is nothing more than a virtual ESXi server that you deploy via OVF, is already up and running. So I'm going to explain to you how to install it, but we've done that for you. When you take a look, here we're talking about read locality. Now, read locality is different when you're dealing with a stretched cluster compared to a regular cluster. With regular clusters, if you have a VM that is a two-way mirror, the VM reads from one copy of the data once, the next time from the other, back and forth. In a stretched cluster, it makes no sense to read from the remote copy. Obviously, that would not help with performance. So you have 100% read locality when it comes to stretched clusters. Let's say if my VM is running on a host on datasite 1, he's always going to be doing the reads from datasite 1. Now, when you take a look, here's what we mentioned, the concept of a witness host. So the witness host technically could be a physical ESXi server, but you don't want that. Because if you do that, you're wasting a license. Your witness host cannot run VMs. Your witness host is there to be the tiebreaker in the case of a problem. Remember, the witness host is nothing more than an OVF that you get to install, meaning a virtual appliance. And the cool thing about the witness host is that it has its own license, so you don't have to sacrifice a license. Just remember, he will not run VMs. It is installed via OVF. And all you have to do is download the appliance, deploy via OVF, make changes to the management network as usual, right? That's what you do with every physical ESXi server. And then you need to create a second VM kernel port. That's going to be the VM kernel port for vSan. That way he can communicate with your physical servers. So when you take a look at the bullets, notice it says each stretched cluster must have its own witness host. If you have 2 stretched clusters, you need 2 witness hosts. That is no longer the case for 2 node clusters. That used to be the case for 2 node clusters, but that's no longer the case. Here, it's still the case. Once again, the witness can run VMs. And if you take a look, the witness is there, right, to provide cluster quorum. They mention again, this is packaged in a virtual appliance. And again, it has its own embedded license. So when you take a look, all we show you here is that if you want, you can combine stretched clustering with something like SRM, Site Recovery Manager, or a standalone replication appliance. Now here, if you notice carefully, they're showing you some latency limitations. So I've mentioned, for example, that in a stretched cluster, you cannot have, for example, a set of hosts in LA and another set of hosts in New York. Now, let's say for argument's sake, you're talking about a campus topology. If you want to replicate your VMs, let's say to another state or another country, the idea is, in this case, you can combine this feature, aka stretched clusters, with Site Recovery Manager, or again, the standalone replication appliance. If you look at this drawing, with replication, I'm talking about with SRM, with the standalone replication appliance, your minimum RPO, recovery point objective, is 5 minutes. If you look carefully here, notice they're telling you that you have a limitation of less than 5 milliseconds between data sites. Now, that is not the same number that applies when you're talking about communication or connectivity between a data site and the witness. But again, remember, your latency cannot exceed 5 milliseconds between data sites. And in a minute, I'm going to be doing my first demo. So we're going to be talking about configuring a stretch cluster. So I'm going to show you how to do it. If you decide to implement a stretch cluster, the first thing you need to do is delete your full domains, because when you build a stretch cluster, new full domains will be created. So we're going to take a quick little break. We're going to switch to our lab, and I am going to do my first demo. In my demo, to speed this up, I am going to create a 5-node stretch cluster. 2 hosts in one site, 2 hosts in a second site, and then again, we're talking about a third site, which will have one of my 2 witnesses. In this class, you have 2 witnesses. You'll see it when I do my demo. So I'll see you at the demo. Enjoy. Okay, guys, it's time to build a stretch cluster. Now, in this demo, I'm going to show you how to create a small stretch cluster. Remember, this demo is about stretch clustering. The second one is going to be about 2-node clusters. So let's take a look at what I currently have. If you notice carefully, in this demo, I want to use my second cluster. So you can see right now, I have a 4-node regular vSan cluster. Now, typically when you build a stretch cluster, you can imagine, of course, that when you build this, you wouldn't have any VMs. On purpose, I have a virtual machine. And again, I'm going to leave this VM for a particular reason. Now, before I proceed, I want you to notice that this VM currently is registered on SB03. You can see it's located on the vSan data store, and you can see it's a plain vanilla 2-way mirror VM. So if I was building this from scratch, I could always build first a regular vSan cluster. And then what I could do is I could talk to maybe somebody else in headquarters and say, I want you to download the witness appliance. I want you to deploy it via OVF. And then let me know, of course, when it's ready. So in this particular class, you can see we have 2 witnesses. You're going to use both witnesses throughout the labs. Now, the reason we have 2 also is because it's now very easy to replace a witness if it fails. So if you take a look, the first thing I want to do is I want to show you how to create a stretch cluster. So in this case, I am going to build my stretch cluster using SB vSan 01. So what I need to do here is, number 1, I need to select that particular cluster. Number 2, I need to go to configure and I need to go to full domains. You want to make sure you don't have any regular full domains. I'm talking about any regular explicit full domains. And you want to make sure that your witness host is not inside of your cluster. This is critical. If you accidentally put it inside of your cluster, this is not going to work. You're not going to be able to find it. Now, at this point, I am ready to start. So if you take a look, let's talk about the witnesses beforehand. So let's say I work with a person, let's call that person Joe. I talk to Joe, I ask him to deploy that particular appliance. So again, he needs to download it via OVF. He needs to download it, my bad, and then install it via OVF. Hopefully we all know how to do that. Now, the next thing he needs to do is change the name, the host name, and again, the IP address from a dynamic address to a static address. At that point, what I need to do is I need to add it to my inventory. But again, it cannot be a cluster member. He's not going to be inside of the cluster. The next thing I would need to do, which we have done for you, is you would need to create a second VM kernel port. Once again, this second VM kernel port is going to be the one for vSan. There is no need to create one for vMotion because, again, I'm never going to have VMs running here. However, this host needs to be able to communicate with the physical host. So you can see here we have two VM kernel ports. Notice again the IPs. Notice the IP for the vSan network, in this case, is 172.22.11.202. And then we have another one for our future lab. You can see again the IP of that one. So we've done that for you. Now we assume that you know how to create a virtual switch and a VM kernel port. So what do I need to do? To create a vSan cluster, it's not really hard. So once again, I am going to select my SB vSan01 cluster. I go to Fault Domains and I click on Configure Stretch Clustering. Now, as you can see, you have two fault domains. That's why you have to delete the ones you may have. The system will create two for you. You can see the default names are preferred and secondary. You can always rename them. So what I'm going to do here is I'm going to call them Site A and Site B. What you want to do next is you want to split the hosts evenly. So in this case, I'm going to have two hosts on one side and two hosts on the other. I'm going to click on Next. Now here is where you select the witness. Remember, if you put the witness inside of your cluster, you won't see it here. If that's the case, no big deal. Put it in the maintenance mode, drag him out of the cluster, and take him out of maintenance mode. So in this case, I'm going to choose, let's say, the first witness. Notice the system says everything looks good. At this point, you need to create a disk group on the witness. What you're seeing here is that we're using what we call the tiny configuration. When you deploy the witness, you have a choice when it comes to the size, similar to what you do with the vCenter when you deploy it. We went with the tiny configuration. The tiny configuration has a boot drive, and then it has two drives. One will act as a cache disk. That will be the 10 gig in this case. And the 35 gig will be your capacity. That's where you store the witness components. Now, you click on Next, and then you click on Finish. So this should take, roughly speaking, about a minute. You should be able to see certain tasks at the very bottom. And once again, I'm just going to wait a few seconds. Now, let me explain to you why I left that VM. There's a good chance, actually 100%, that that VM has all the components in the wrong location. Because think about it, that VM already exists. So don't be surprised if we have some warnings. Now, the reason you're going to get warnings is because that VM is not going to be compatible or compliant. If you think about it, he's not going to have the witness component in the witness host because he already existed. So I'm going to have to fix that. Now, if from now on I create a VM, if the VM is a two-way mirror, again, the idea is quite simple. One submirror will be in one location, the second submirror in the other location, and the witness component always in the witness host. So notice, I now have my two data sites. So two more things I'm going to do. Number one, we're going to create a brand new VM. I'm going to call it Javier02. Now this one is brand new. So you can imagine this one will be built properly. Now we're going to choose the second cluster. Remember, ignore any warnings you may see for now. And we're going to go with the default policy. I'm talking about, of course, we're going to make this VM a two-way mirror. We're going to put it on my vSan data store. And if you take a look, once again, I'm not going to install an OS. So we're going to make this kind of small. I always like to do that. I don't know why. Habit. So let's take a look. First, we're going to analyze Javier02. That should look clean. But then we're going to take a look at Javier01 and we're going to fix that. So let's start with the new VM. Once again, I select the VM, I go to monitor. I go to physical disk placement. Let's take a look and dissect one of the objects. There it is. Notice this is what you expect to see. You expect to see one component, meaning one replica component or submirror on side A, one on side B, and the witness component always on the witness host. But now let's take a look at here 01. Now we need to fix this one. You can see, apparently we don't have to fix it. Wow. It automatically took care of this for me. It didn't used to do that in previous versions. But again, the idea is that this VM, if needed, it would show me, especially with older versions of vSan, it would show me that there was a problem. And then at that point, all I had to do is go to Skyline Health and click on Repair Objects immediately. So this is how you build a stretch cluster. Now, one more thing, then we'll take a little break. When you take a look, should you have a problem when it comes to the witness, the idea is it's very easy nowadays to replace it. Let's take a look. I'm going to show you that in this screen, you can tell, number one, who is the witness. You can see I could click on Change Witness Host. And then again, in the worst case scenario, I would tell my friend Joe to deploy a new one. And again, I would simply select the second one. I'm not going to do that, but again, I would select the second one. And this operation would take about 3 to 5 minutes. Now, let's do a quick test. I am going to power on my VMs. Remember, you need the majority of the votes for a VM to continue to be operational. I haven't created my DRS rules. I'll do that later on. But if you take a look, I power on a VM. Now let's see where this VM is running. Now, if we take a look at the summary page, this virtual machine is currently on SB03. And if I'm not mistaken, remember SB03 is part of side B. Nope, never mind, part of side A. No big deal, doesn't matter. Now, what I'm going to do is, number one, I am going to putty into my witness. Let's see if I can do that. And we're going to emulate one failure. So this is going to be a simple failure. We're going to emulate losing the witness. When it comes to the VM, is the VM going to be affected by this? Not really. The VM will continue to run because he has still 2 out of 3 votes per object. The 2 submirrors are still okay. The witness is down, but again, you can live without the witness. So take a look. Here you can see the witness is not responding. And if I look at both my VMs, when I go to the monitor tab, I expect to have absent components. Let's take a look. There it is. But notice the VM continues to run. Both VMs in this case were affected by that, but once again, as long as they have the majority of the votes, they will continue to be running. Okay, so this concludes the first demo. I'll see you when we continue with the lecture. Hopefully you enjoyed the demo, and I'll see you in a few minutes. Thank you. Okay, guys, hopefully you enjoyed that demo. So now let's keep talking about stretch clusters. So we saw how to configure, in my case, a 5-node stretch cluster. Remember, 2 hosts on one side, 2 hosts on the other side, and a 5th host, which is my witness appliance. Here, just like I showed you in my demo, they mention that it's very easy to replace your failed witness if necessary. Now, that was not available back in the old days, back in 6.1, but that has been available for a few versions now. If you have vSan 6.7 or 7.0 or 7.0 Update 1, guess what? That feature is there. So remember, all you would have to do is simply deploy a new one, add it to your inventory, add the second VM kernel port, then click on Change Witness Host. Wait about 3-5 minutes, and then make sure that you rebuild those witness components. So make sure you go to Skyline Health, and then you simply specify that you want to repair the objects immediately. Now, when you take a look, what we try to show you here is that when you put the witness appliance in maintenance mode, there's nothing to evacuate. So when you compare what you see, when you try to put a host in maintenance mode versus this witness appliance, the big difference is that with a regular host, you have the three typical choices: full data migration, ensure accessibility, and no data migration. That is not the case when it comes to the witness. Remember, you can live without those witness components. As long as you have the majority of the votes, you're still doing okay. And if you take a look, if needed, one of the things you could do is you could always go to Skyline Health and take a look at what's going on with your stretch cluster. Like I said a minute ago, if you replace your witness appliance, what you'll have to do is go to Skyline Health. For obvious reasons, you're not going to see all the tests in green. And then at that point, you'll have to repair the objects immediately. Now, when you take a look, you can see that there's a whole section of tests for stretch clustering. You can see, for example, the system could complain that it couldn't find the witness. Notice again, for example, you may have more than your 3 full domains. Remember, you have site A, site B. The witness is the 3rd full domain. So if you're building a stretch cluster and you accidentally forget to add one of your hosts to one of those full domains, then you'll end up with 4 full domains. The system will complain and it will tell you, hey, you got too many full domains. Now, when you take a look, you also see additional errors that the system may realize that you're going through. So for example, notice you may have unicast related problems. Notice again, maybe you don't have any disks claimed on the witness host and so on. Now, I built a 5-node cluster. That's not what you're going to do when you get to the lab. You're going to build a bigger one. And there's a reason. When we first introduced stretch clusters, all your VMs had to be two-way mirrors. One submirror in one location, one submirror in the other. Now, imagine if you have a regular stretch cluster like the one I built, and then you lose the disk that contains the local copy of the data. Temporarily, that VM will use the remote copy. And you're going to have to wait until you finish rebuilding that missing submirror. Performance is not going to be the same if you're relying on the remote copy. Now, not in 6.1, but much later, we introduced variations to stretch clustering. For example, now you have new policies, such as the one that allows me to have a VM that is a two-way mirror, where we're talking about one copy of the data on one side, one copy on the other. But then in turn, each of these copies is going to be redundant. So that would be like the equivalent of a 4-way mirror. Now we're talking about 2 submirrors in one data site, 2 submirrors on the other, and 3 witnesses altogether. One witness for the 2 submirrors in site A, another witness for the 2 submirrors in site B, and then the 3rd witness, which is the witness between data sites. So how do I build that type of VM? Notice you have to combine different rules to create a brand new policy. What you would have to do is you would choose under site disaster tolerance, the option dual site mirroring. And then when it comes to failures to tolerate, you will use one failure rate 1. Now that would require 7 servers altogether. 7. I'm talking about, 7. 3 in one data site, because you need submirror, witness. 3 on the other, submirror, and witness. And a 7th, which is going to be your witness host. That's what you're going to be doing in the lab. There is another choice. The next choice entails that you have a VM that is a 2-way mirror, but in turn, each submirror is really RAID 5. Now that requires 9 hosts, because remember, RAID 5 requires 4. So we're talking about 4 plus 4 plus 1. How do I build that policy? Once again, I combine dual site mirroring, parentheses stretch cluster, with RAID 5. When you take a look, this, again, is the one that requires 7 servers. As you can see here, you have 2 replica components in each site. You need a witness for basically each set of mirrors. And then again, you have that 3rd witness And again, the third witness is going to be always on your witness site. Now you can imagine in this case, if I lose one of the copies of my data in my local site, I still have another one there. And I get to rebuild that missing copy using the local copy, not necessarily the remote one. And if you take a look, this one talks about combining that with RAID 5. So this illustration doesn't look right. Again, in this case, you would need 4 hosts in each location. Now, when you take a look, here they mention that again, in a perfect world, the 3 sites are communicating with each other. Notice here's what they mention: the master node, the backup node. Again, these 2 entities are communicating with each other, and they're also communicating with the witness. They're pinging each other all the time. Now, how can I tell? Not that it matters, but how can I tell who the master or the backup is? Basically, you go to the command line and you could type ESXCLI vSan. And when you type ESXCLI vSan, you will have different namespaces. So if you type ESXCLI vSan cluster get, that will show you whether you are the master, the backup, or obviously an agent. Remember, always one master, always one backup. Everybody else is going to be an agent. If the backup fails, one of the agents gets promoted. If the master fails, the backup then becomes a master. And if you take a look, what we have next is a series of questions. So take a look at this. Let's assume that we have two-way mirror VMs, just plain vanilla two-way mirror VMs. If I have a virtual machine, let's say running on data site 1, and I have another machine running on data site 2, what happens if you lose data site 2? In this case, you have 2 VMs running on data site 2. Those are VMs 03 and 04. Those would crash. They would restart, obviously on data site 1. Who restarts them? HA. And when you take a look, that's the answer to the question that you just saw. Now let's take a look at this one. In this case, you're talking about having a VM. Once again, we're going to stick to two-way mirror VMs. In this case, I'll lose one host. So let's stick to one VM. Let's say we have VM1. If VM1 is running on host 1, and let's say host 2 crashes, that VM will continue to run. Now, there is no concept of data locality when it comes to VMs. That means what? The VM could be using CPU and memory on host 1, but maybe his sub-mirror was on host 2. In any event, if the VM is running on host 2, it crashes. It will restart, and your DRS rules will tell it to restart and data site 1. Now, on the other hand, if it was running on, let's say, host 1, yes, maybe it was affected temporarily because host 2 went down, because maybe that's where you had the replica component. But if you didn't have the replica component at all in host 2, then obviously you couldn't care less. He'll still be okay. And again, you can play with this. You're going to have a lab where you test these type of scenarios. I'll do another demo and I'll show you that. Here again, you have the answers. So once again, if the VM was running on that host, the one that crashed, HA will restart it. Now let's take a look at this one. In this case, this is what I showed you before. You lose the witness. Once again, we know the answer to that. The VMs will continue to run. If you cannot bring back the witness, all you have to do is deploy a new one and replace it. But again, remember, in this case, the VMs would have, for obvious reasons, the majority of the votes present. And here again is your answer. All right, so let's talk about this one. In this case, your preferred data site cannot see the witness, but he can still see the secondary site. So the VMs, once again, are unaffected because you still have the majority of the votes. Now, you better fix that network problem, correct? But in any event, here, just remember the VMs will continue to run. And here you have the answers. So let's take a look at this one. We've already talked about this. I don't want to spend too much time with this. If my data site 1 cannot talk to data site 2, but both can see my witness site. Remember, all the VMs in your non-preferred site will power off and they will restart in your preferred site. We talked about that at the beginning of the lecture. And here you have the answers. Now, let's take a look at this one. In this case, right, it says, in this scenario, the preferred site has failed and the vCenter happened to be one of the VMs there. What happens in that case? Simple. The other servers, the ones on data site 2, they still know their job. Remember, you need a vCenter to build a cluster. But once you build an HA cluster, the vCenter could go down and those ESX servers still know what to do. They're still running FDM, full domain manager. They know their job. Their job is, hey, let's go restart all the VMs, and that includes the vCenter server. And here is your answer. Notice, vSphere HA recovery is independent of the vCenter server. Now, we're going to take a little break, and then we're going to start with 2-node clusters. Enjoy the break. I'll see you in a few minutes. Thank you. Welcome back. It's time to talk about 2-node clusters. Now, I've mentioned earlier that we introduced 2-node clusters back in vSan 6.1 at the same time that we introduced stretch clusters. Now, with 2-node clusters, you have two choices. On one hand, you can create a 2-node stretch cluster. Now, that doesn't seem to be that popular, at least here in the US. What is really popular is to have two hosts next to each other in one location. And maybe in headquarters, we're talking about having the witness host. This witness host is the same one that you use again in stretch clusters. But remember, each stretch cluster requires its own witness appliance. That used to be the case with 2-node clusters, but that is no longer the case in 7.0 Update 1. Starting in 7.0 Update 1, you can, if you want, use one witness host for more than one 2-node cluster. And if you take a look, this is what I'm talking about. Now, you build a 2-node cluster the same exact way I just built my 5-node cluster. The difference, of course, is that you have one host in one full domain, the other host in the other. And for obvious reasons, the witness, which is not a cluster member, is going to be, let's say, in headquarters. Here you can see, however, that now you can have a shared witness appliance if you have multiple 2-node clusters. Underneath, the difference is you will have different instances of CMMDS, one for each 2-node cluster. And when you take a look, here again we show you how you could configure a 2-node cluster or a stretch cluster from scratch when you're building, again, your cluster using the Quick Start utility. Now, if you build a regular cluster and then you want to change it to a 2-node cluster, once again, all you have to do is select your cluster. Once again, go to Configure, go to Full Domains, and you click on the same icon called Create Stretch Cluster. Because again, remember, a 2-node cluster is a variation, if you will, of a stretch cluster. The difference is how many hosts do you have. So I'm going to do another demo. And in the other demo, I am going to take apart my 5-node stretch cluster. And I'm going to show you how to build a 2-node cluster. When you take a look, what follows is going to be my demo. And I'm going to do two things in that demo. First, I am going to go back to my stretch cluster and we're going to emulate a failure. Now, I'm not talking about failing the witness. I'm talking about failing maybe just one host. And then we'll talk about 2-node clusters. And you'll see me again build a 2-node cluster. Now, remember, after that demo, you get to do 3 different labs. Lab 7, notice, it's called Managing Stretch Cluster Operations. You can see you're going to grow the cluster. So you're going to take apart one cluster and you're going to grow the first one. Because what you want to do here is you want to play with the policy that allows you to have a VM that is mirrored across sites, but also mirrored within each site. That's the one that requires 7 servers. Then you have lab number 8. That's where you test your cluster. And then again, you have lab 9. And in lab 9, you get to play with a 2-node cluster. So I'll see you back in the lab. Once again, I'm going to do a demo. And then you get to do not 1, not 2, but 3 labs in a row. Enjoy, guys. Thank you. Welcome back, guys. It's time to build a 2-node cluster. So in this quick demo, I'm going to show you how to configure a 2-node cluster. I've mentioned that there are 2 ways to do it. You could use nowadays the quick start utility, but again, that is not what I'm going to do. I want you to notice first and foremost that I used to have a 4-node cluster called SB vSan01. But notice carefully now, I have removed 2 out of the 4 hosts. Notice carefully SB03 and SB04 are not members of my cluster anymore. So the idea here is I'm going to use my second witness for this demo. So if you take a look, because I already have a cluster, it's a 2-node cluster. What I need to do here is I need to click and configure, and we need to finish setting this up. So think about it. One of the ways is to use a quick start utility. I didn't use that. The second way, the traditional way, if you will, was to, number 1, deploy 2 ESXi servers, take care of the networking layer, then of course create a data center, create a cluster, drag the servers into the cluster, and create a disk groups. We already have that. So the last part is quite simple. I go to the cluster, I go to configure, and what I need to do is I need to go to full domains. Now notice, once again, you cannot have your regular full domains. With the 2-node clusters, the system will create 2 full domains just like it did for the stretch cluster. So even though it's 2 nodes, you're going to click right here for configure stretch cluster. Now what you're going to be doing, again, is you're going to separate the servers. So you can see these are leftovers, if you will, from a previous demo. So once again, all you got to do is just pretty much separate them. And again, you can change your mind for obvious reasons. Maybe you like side A, correct? To be again on the left side, side B on the second. Once again, we have this concept of a prefer side. And what you're going to be doing is, just like before, you're going to choose the actual witness. Now, the first time I use witness 01, I don't want to repurpose that. I want to use the second one. So notice, just like before, the system goes through a series of checks and it says this looks good. Also notice, I used to have VMs in this cluster. For obvious reasons, I deleted them. So if you think about it, what I need to do next is simply recreate a disk group just like I did in my previous demo. We're using, remember, the same tiny configuration. Once again, the small drive is your cache device. Your larger one is your capacity. Then you click on next, and then you click on finish. That is how you build a 2-node cluster. So at this point, just like before, you have to wait a few minutes. Remember, the system is creating 2 different full domains, and it should tell you that you have a 2-node cluster. Remember, these 2 servers could be either next to each other, or technically, you could be building a 2-node stretch cluster. Remember, with 2-node clusters, all you can have is VMs that happen to be 2-way mirrors, aka VMs using the policy called failures to tolerate equals 1. Hopefully, again, you enjoyed that demo. I'm not going to make you wait a couple more minutes because, again, you're going to be doing this in the lab. So enjoy the labs, and I'll see you after the 3 labs. Thank you, guys. Welcome back, guys. It's time for another chapter. And as you can see here, this chapter is called vSan Storage Space Efficiency. So what exactly are we going to be talking about in this chapter? If you've been working with Vsphere, and in particular vSan, for a while, you probably know that over the years, we have added more and more features that could potentially save you space. So when you look at this page, and this page, they're telling you that as your environment grows and you continue to build more and more VMs, you may want to consider utilizing some of these space efficiency features. So what exactly we're talking about? If you think back, if you've been working with vSan for a while, you may remember that in vSan 6.2, which was Vsphere 6.0 Update 2, back then we added a few of these features. In vSan 6.2, we added number 1, RAID 5 and RAID 6. So those two techniques can save you a lot of space compared to using, for example, a two-way mirror or a three-way mirror. Be aware, RAID 5 and RAID 6 can only be used if you have the all-flash architecture. Not only that, in 6.2 we also added deduplication and compression. And dedupe, when combined with compression, can save you a lot of space. Having said that, in this version, in 7.0 Update 1, we've added the ability to enable compression only. So we're going to talk about why you have that and what is the advantage potentially of using compression only compared to dedupe and compression. Lastly, a few versions back, we introduced trim and map. Trim and map was introduced in 6.7 Update 1. And again, trim and map still in 7.0 Update 1 has to be enabled using the RVC, the Ruby vSphere console. So I'm going to show you how to do this. And not only that, I'm going to do a demo on how to use the RVC. In order, again, to enable trim and map, you need to know how to connect to RVC and be able to run commands. So I'm going to do a demo, a full demo on the Ruby vSphere console. Now let's take a look at the goals here. As mentioned in this particular chapter, number 1, we're going to describe all of these features that I just mentioned a second ago. Then we're going to dissect them. First, we're going to start with dedupe and compression. Once again, remember, this can only be enabled if you have the all-flash architecture, just like RAID 5 and RAID 6. After that, we'll talk about why we introduced compression only, advantages of disadvantages one versus the other one. Then we're going to use and talk about RAID 5 and RAID 6. Please remember that in this lab, you already have a RAID 5 VM. Not only that, you may want to remember RAID 5 requires 4 hosts minimum and RAID 6 requires 6 minimum. So although I could create a policy for RAID 6, right now I would not be able to use RAID 6. And lastly, I mentioned before, I'm going to show you how to enable trim and map. So let's take a look at this page. Here, once again, we mentioned that over the years, VMware has added more and more features that potentially can save the customer a lot of space. Let's take a look at some of these sentences. When you take a look, at the very top, they mention what I just said a second ago. So let's look at the second paragraph. Notice the second paragraph says, enable deduplication and compression on a vSan cluster to eliminate duplicate data and reduce the amount of space required to store data. On the vSphere client, you can very easily see how much space you're saving because of dedupe and compression. And if you take a look, maybe you have a cluster and currently you're using, let's say, two-way mirrors, let's say FTT1, let's say maybe three-way mirrors. Maybe you haven't considered using RAID 5 or RAID 6. Remember, RAID 5 can save you a lot of space compared to a two-way mirror. 33% of the space to be more precise. And RAID 6 can save you 50% of the space when compared to a three-way mirror. RAID 5 can sustain 1 loss. RAID 6 can sustain 2. Now, if you take a look, after that we mentioned that once again, another thing that you may want to consider is perhaps enabling trim and map. And if you haven't read the release notes or you haven't played with the RVC, maybe you don't know the fact that you could actually do that. And you do it with one command. With trim and map, once you connect to the RVC, you run one command. And after running the command, you have to power off and power on the VMs. Now, let's talk about dedupe and compression only. Remember, this is the feature that was introduced in vSan 6.2. When you first build a cluster, you have the choice at that point to perform a DFC. And when you do the DFC, disk format version or conversion, the idea is you are doing this operation when A, enabling duplication and compression, or B, enabling encryption. Now here, in this class, we talk about encryption. And we've mentioned in that chapter as well, that once again, when you enable either dedupe and compression or encryption, although you're talking about a couple of clicks, this operation could take a while. Why? Because again, your disk scripts will have to be reformatted so that the disks can support, in this case, the duplication and compression. So notice at the very top, we mentioned why you may want to consider enabling dedupe and compression. Once again, we're talking about saving space. Number two, if you take a look, it says environments with highly redundant data, such as full clone virtual desktops and homogeneous server operating systems, can definitely benefit from this feature. Now, obviously, this is not going to help you or save you. If you have, let's say, 3 virtual machines, one, let's say, running Linux with a web server like Apache, another one running, let's say, I don't know, a different flavor of Linux, perhaps with a database like Oracle, and a third one, let's say, running Windows with Exchange. However, if all of your OSs, or the majority of them, are, let's say, the same type, let's say, for argument's sake, Windows 2016, then you better believe this could save you a lot of space. Now, again, there is a drawback of the duplication and compression. And the drawback is that if you lose a disk in your disk group, that means if any disk, whether cache or capacity, fails, at that point, in order to replace that disk, you have to take apart the entire disk group. That may be why, perhaps, we added compression only. With compression only, you don't have that problem. So remember, if you want to enable the duplication and compression, it's nothing more than one click. But at that point, you may want to take a nice little break, because again, you're going to notice that slowly but surely, every disk group in your environment will be taken apart automatically. The disk groups will be removed. And again, at that point, the disks will be reformatted, and then the disk groups get recreated. So you may want to consider using that feature or enabling that feature on day one when you first build a cluster. But maybe you didn't do that. So maybe again, that's more of a day 2 type of operation. And when you take a look, remember, this feature only works if you have the all-flash architecture. So what I'm going to do here is I am going to switch to the lab. And then at that point, I'm going to show you what happens when you enable the duplication and compression. But before we do that, let's go to this page. Here, we continue talking about the duplication and compression. So here's where they mention the rolling reformat. Remember, it's nothing more than one click. However, it will take a while. In the lab, if you do this task, expect this to take probably 15 minutes, roughly speaking. Now, if you take a look, it says depending on the data store on the vSan data store. Once again, this process might take a long time. Now, in real life, of course, this could take hours, not just 15 minutes. It really depends on how many disk groups you have, how many disks, and how many hosts. Now, when we look at this page, here, we're talking about, again, dedupe and compression. And if you look at the different statements, let's take a look at a couple of them. Number one, here they tell you when the duplication and compression take place. And notice again, they mention it occurs inline when data is written from the cache tier onto the capacity tier. Number two, they mention that the duplication and compression, they use a fixed block size. And again, this is applied within each disk group. And when it comes to compression, the idea is to take 4K blocks and again, compress them into 2K blocks. If you cannot compress into 2K blocks, then we write the data and compress. And when you take a look, in this particular page, we talk about the concept of disk management, things to consider. I've mentioned some of these already. So let's take a look at bullet number 1. Once again, if you enable the duplication and compression, you cannot remove a disk from a disk group. Typically, you remove a disk from a disk group if the disk has failed. So here the drawback is that if you lose a disk, once again, whether it is the cache or capacity, you have to take apart the entire disk group. Notice that's what they tell you in bullet number 2. And bullet number 3 says a single disk failure causes the entire disk group to fail, which means, right, that you may really want to consider perhaps having multiple disk groups instead of one per host. It's always a good idea to have multiple disk groups and ideally multiple controllers per host. Here in class, remember, we only have one disk group per host. And if you think about it, we only have one capacity disk per disk group. So here in class, no matter what you do, if you try to remove the disk from the disk group, you're taking apart the disk group. But remember, you would have to take apart the disk group to repair one single drive. Now, when we look at this page, here we talk about design considerations. So let's take a look at this and then we'll do our first demo. Now let's take a look. Here it says, if you use the duplication and compression when it comes to virtual machine storage policies, remember, your VMs are thin provisioned by default. Without the duplication and compression, you have the choice to create a policy where you're reserving 25% of the space, 50% of the space, or 75% of the space. Now, besides that, of course, you could save 100% or reserve 100%. With dedupe and compression, either the VM is thin provision, or again, you're reserving 100%. You cannot use the 25%, 50%, and 75% choices. Notice, number 2, it tells you something I've mentioned several times. This will not work if you have the hybrid architecture. This feature only works if you have the all-flash architecture. And when you take a look at bullet number 3, it says the processes of the duplication and compression incur compute overhead. That means what? You're going to have a little bit of CPU overhead. It may not be significant, but you may notice it. So before perhaps you enable dedupe and compression, you may want to do some benchmarking. Then you enable dedupe and compression, and then you compare the results. Now, when we take a look, the last few bullets, they mention once again, you have advantages and disadvantages. So remember, maybe you care about saving space and you have plenty of CPU resources available. So that may be what matters to you. For other people, that may not be the case. So that is something to consider. And if you take a look, before we talk about compression only, let's switch to the lab. Let's enable the duplication and compression. And let's wait 1 minute to take a look at what happens if you look at the recent tasks. All right, so let's switch and go to the lab. I'll see you there. Welcome back. Now, let's play with the Vsphere client. Let's use some commands and let's take a look on how to enable the duplication and compression. So, what I'm going to do for this demo is I am going to take my second cluster. Now, in the lab, you're going to be playing mostly with the first cluster. But in my demo, I'm going to use the second one. So let's take a look at SB vSan 01. If I go to the Configure tab, here you can see that when we look at the different services, as we call them, when it comes to space efficiency, here you see none. Now, what I'm going to do is I'm going to click on Edit. Now, when I click on Edit, you're going to notice in 7.0 Update 1 that at the very top, you have 3 choices now instead of 2. None, compression only, which is new in 7.0 Update 1, and deduplication and compression. Prior to 7.0 Update 1, you only have none or dedupe and compression. So, right now, what I'm going to do is I'm going to show you that if I connect to one of the servers in the second cluster, not the first, but the second, what I'm going to do in this case is I'm going to show you how big the data store is right now. Now, I've made some changes here. Yours should be 200 gigs. Mine, however, currently is not. Notice mine is 150 gigs. So remember, yours will be 200. Mine will be 150. Now, let's take a look at this environment. So what I'm going to do here is I am going to choose deduplication and compression. Remember, this requires a rolling reformat. That is not the case with compression only. So I am going to click on Apply. Now, if you take a look, I had a couple of other choices, but in this case, I want to show you that the system now is going through changes. The cluster is going through changes. And you're going to see different tasks taking place. Now, what I'm going to do is I'm also going to show you that if I go to the command line, the idea here is if I type ESXCLI vSan debug, here I'm going to see a series of commands. Now, among these commands, you have a few commands related to your disks. Let's take a look at one of them. Now, what I'm going to do here is I'm going to type ESXCLI vSan debug disk list. Now, this command will show me every disk that I'm using for my vSan cluster. And what it's going to do is it's going to show me what the disks support. For example, encryption, deduplication and compression, or just nowadays compression only. So remember, this will take a while. So if you take a look, I'm just going to pick one disk randomly. Remember, this drive, target 1, in class, is my cache device. So if you take a look, here you can see that I'm looking at controller 0, target 1, lone 0. It belongs to SB-ESXi03. You can see the disk format version. You can see this belongs to a particular disk group. Remember, we only have one disk group here in class. You can see this is a solid state drive. It is my cache disk. And it is actually in your inventory. Remember, CMMDS is one of the many processes that controls vSan. CMMDS, to be more precise, is the one that actually keeps track of your inventory. Now, if you take a look, here you can see that I have not enabled encryption. And if you take a look, remember, this will take a while. So this eventually will change. So I wanted to show you that. And if we go back, of course, to the GUI, you can see right here in class, because my data store is smaller, the system shows you that I have chosen to enable deduplication and compression. So I wanted to show you that. So now we're going to cut back and we're going to go back to the actual lecture. Okay, guys. So now, while we wait for the conversion to finish, let's talk about compression only. I showed you a second ago that with the Vsphere client now, if you want, you have the chance to enable compression only. So let's talk about advantages and disadvantages of compression only compared to deduplication and compression. You may be wondering, why did we actually introduce the ability to enable compression only? And the answer is simple. The advantage of compression only is that, once again, if I lose a capacity disk, I don't have to take apart the entire disk group. I can very easily replace the disk, meaning remove it from the disk group and add it back. Now, having said that, the disadvantage is I will not save potentially as much space if you enable compression only compared to deduplication and compression. And if you think about it, I've already mentioned that you can see your space savings very easily if you choose the option called capacity in the Vsphere client. So when we take a look, here you can see that they talk about compression only. So if we go through the bullets, notice bullet number 1, it says compression only can reduce the amount of physical storage consumed by as much as 2 times. That ratio is much bigger potentially when you have deduplication and compression. Notice bullet number 2 talks about what I just mentioned about a second ago. What happens if you lose a disk? Very easily you can remove the disk from the disk group instead of having to take apart the entire disk group. So in any event, this is for you to decide which one are you going to use. Now, when we take a look at this page, here they keep talking about compression only. And you can see it says the compression only algorithm moves data from the cache tier to individual capacity disks. The key there is individual, which also ensures better parallelism and throughput. Now, when you take a look here, they show you the same thing I showed you in my demo. So once again, you could choose one and or the other. In my first demo, I enabled or decided to enable the duplication and compression. Here, if you think about it, you can see that you have a choice. And again, you could choose one or the other. Now, I mentioned several times that you can actually see how much space you're saving if you enable dedupe and compression or compression only. So notice in this case, you see the ratio when it comes to savings. Notice in this case, the book mentioned could be up to 2 times. Here you can see is 1.23x. All right, so what we're going to do now is we're going to take a break because we've been going for a while. And when we come back, we are going to continue talking about these space-saving techniques. Enjoy the break, and I will see you in a few minutes. Thank you. Welcome back. And now it's time to talk about additional space-saving features. So in this page, you can see that we've mentioned that for a while now, ever since vSan 6.2, you have been able to use RAID 5 and RAID 6. Please remember, RAID 5 and RAID 6 can only be used if you have the all-flash architecture, not if you have the older hybrid architecture. Now, when you take a look, here what they've mentioned is that RAID 5 can save you up to 33% of the space against a two-way mirror VM. And RAID 6 can let you save up to 50% of the space compared to a three-way mirror VM. Please remember, RAID 5 requires 4 hosts. RAID 5 can sustain 1 loss. RAID 6 requires 6 hosts, and it can sustain 2 losses. Now, when you take a look, here they're showing you that if you had a VM, if this VM was RAID 0, and the VM had a disk that was 100 gigs, the VM would use 100 gigs. Now, if the VM is a two-way mirror, 200 gigs. If the VM is a three-way mirror, 300 gigs. But if you use RAID 5, instead of using 100 or 200 gigs, if you're using RAID 0 or RAID 1, with RAID 5, you would need 133 gigs. With RAID 6, that would require 150 gigs. So again, it would save you 50% of the space compared to a three-way mirror. Here we show you that it's very easy nowadays to create these policies using the Vsphere client. What you have to do is you have to go to the home page. You got to click on the icon for virtual machine storage policies. You name the policy. You click on the box for vSan, and then you choose under availability whether you want to use RAID 5 and RAID 6. In my demo, I am going to create a policy for, let's say, RAID 6. However, when I try to use it, it's going to fail. Remember, you can always create the policies, but it doesn't mean you can use them. When I try to create a RAID 6 VM, if I only have 4 hosts, in recent tasks, it will tell me I don't have enough full domains. And if you take a look, before we do the demo, we need to talk about trim and map. We've introduced trim and map in 6.7 update 1. And one of the things you need to understand is that with trim and map, the idea is you need to enable it not with the Vsphere client, but instead with a command. Now, this is not a command inside of an ESXi host. This is a Ruby Vsphere console command. Now, some of you guys may have used the RVC before. Maybe you haven't. So I'm going to do a demo. And in that demo, I'm going to show you how to navigate through the RVC. And I'm going to show you how to enable trim and map. I'm also going to show you what happens if it's already enabled. Now, when you take a look, here they explain to you what this is. And at the very top, it says vSan supports SCSI unmap commands directly from a guest OS to reclaim storage space. So once again, the idea here is simple. You want to save space. You want to reclaim space that is no longer being used. You can see it says the guest operating systems can use trim unmap commands to reclaim space that is no longer used. And of course, to use that, I've mentioned, you have to enable this, but you enable this from one command. Again, inside not of an ESXi host, but inside of the vCenter. And when you take a look, here, you can see as we talk about the advantages, they mention faster repair, and they mention removal of dirty cache pages. Just in case if you don't understand what they're meaning by that, what they're saying. Notice it says because reclaimed blocks do not need to be rebalanced or remirrored if a device fails. Repairs are going to be a lot faster. And at the bottom, it says removal of dirty cache pages from the right buffer reduces the number of blocks that are copied to the capacity tier. So if you look here, we show you commands that you can execute in Linux. And again, what happens in Windows once you have trim and map enabled. In Linux, you can see that you have commands called fstrim. And if you take a look, this happens automatically if you have an NTFS file system with Windows. Now, if you take a look, here they show you that you can enable trim and map either by using PowerCLI or by using the RVC, the Ruby vSphere console. Now, I am going to do a demo using the RVC. So remember, you're going to have to, number one, putty into the vCenter server. Then you're going to have to access the RVC. And then with one command, you're going to enable trim and map. The command is vsan.unmap_support. And that command has two options pretty much. -E for enable or -D for disable. If you run the E option and it's already enabled, it's going to tell you that. Now, the reason I need to do a demo is because you don't just type the command, you have to specify the cluster name. So you have to either be in the right location within the RVC or give it a full path. Once again, if you've never used the RVC, you may want to look carefully at that demo. So if you take a look, I've mentioned you cannot enable the trim and map feature with the vSphere client, but if you enable it with the command line, you're going to have performance-related charts that will give you trim and map information. As you can see in this page, here we have a chart that shows you trim and map throughput. And again, remember, this will only show you anything if you have enabled that feature, which is always disabled by default. So before you do lab 10, we're going to cut for a second and we're going to switch to my kit. I'm going to do a couple of demos. One is going to be about RAID 5/RAID 6, and the other one is going to be about trim and map. So enjoy the demo, and then don't forget to play with the lab. And again, you're doing lab number 10. Thank you guys. I'll see you in a minute when we switch to our lab. Thank you. Welcome back, guys. It's time for another demo. So a minute ago, I've mentioned that I was going to do a demo about RAID 5 and RAID 6. And also I was going to do a demo about trim and map. So let's start with RAID 5 and RAID 6. In this class, you started with two clusters. And if you remember, you already had a RAID 5 VM. So let's take a look at this RAID 5 virtual machine. Now what I'm going to do here is I'm going to go to physical disk placement. If this VM has one disk, if this VM is running, I expect to have 3 different objects. Notice, you're talking about the hard disk, the VM home namespace object, and the swap object. All 3 of them in this case are RAID 5. Remember, RAID 5 requires 4 hosts because again, you have 4 components spread throughout 4 hosts. This obviously is what you want to see. Everything active. Now let's go create a policy for RAID 6. Now remember, I cannot use RAID 6, but I can definitely create the policy. So I am going to go to the home page. I'm going to click on the icon for virtual machine storage policies, and I am going to click on create. I am going to give the policy a name. I'm going to click on next, and I am going to click on the checkbox for vSan. I've mentioned it's a lot easier than it used to be to create these policies. If you ever compare the way we do it with the vSphere client with, let's say, the web client a few years back, night and day difference. The naming convention is a lot easier in the vSphere client. So I am going to choose the option for RAID 6. And if you take a look, I choose RAID 6. Notice it says, hey, if your VM is 100 gigs, you will need 150 gigs instead of a 3-way mirror, which would be 300 gigs. And I click on next. And here you can see I don't have any data stores which are compatible. Now here you can see my vSan data store is incompatible. Why? Once again, I don't have enough hosts. Now if I don't know what that means, I create the policy and then I try to use it. Now let's see what happens when I try to use it. I am going to go to my cluster. I am going to try, notice I use the word try. I'm going to try to create a virtual machine. Now, as I go through the wizard, I'm going to choose one of my clusters. And I am going to choose my RAID 6 policy. Once again, it tells me it's incompatible with everything. Okay, let's assume I don't know what that means. I choose my vSan data store. I get this warning. Once again, if I try to proceed, what's going to happen here is, notice, I try to create a VM and I expect a pop-up window on the bottom right. Now notice this message is fairly generic. It says it failed. But if I look right here under recent tasks, the system is telling me you don't have at least 6 full domains. Remember, that means either 6 implicit full domains, that means 6 hosts, or 6 groupings of hosts. Remember again, full domains are used, I'm talking about explicit full domains are used to make vSan rack aware. So here I only have 4 hosts. All right, so now let's do another demo. And what we're going to do now is we are going to play with trim and map. I'm going to show you how to use the RVC. So the first thing you would need to do is you would need to putty into the vCenter server as root. So here in class, all you have to do is click on the entry for the vCenter server. You can see I'm logged in as root. Now remember, you can enable or disable SSH for the vCenter, for example, from the VAMI port. Next, I'm going to type shell. And now I'm going to type RVC administrator at vsphere.local at local host. All right. What's going to happen next is I'm going to be asked for my password. Now, if you never use the RVC, you can see a few entries. And when you see entries with that slash at the end, I want you to think of those as folders. Now, with the RVC, you could use commands like cd and ls to navigate through the RVC and take a look at the contents of each of these, in quotes, folders. So I am going to change into localhost. Notice I could use the name or the shortcut, the number to the left. Notice I'm using number 1, which is, again, the shortcut for localhost. I type ls. Notice I don't have ls minus l, but I have ls. This shows me I have a data center called SA data center. If I type vSan tab, this will show me all the commands that start with vSan. If you take a look, among these commands, you have the command for trim and map. Now, if you take a look, you can't just run that command as is. Now notice, if I try to enable trim and map, if I don't put a cluster name, it's going to tell me, you need to tell me which cluster you're talking about. Now, what I need to do here is I need to be able to point to one of my clusters. So how do I do that? One easy way is to navigate onto the folder where you find the different clusters. Here you can see I just access my data center. And then what I'm going to do is I am going to go to the folder for computers. I type ls. And by the way, notice if you try commands like clear, that's not going to work. But a nice little shortcut is Control L. Control L will clear your screen. A friend of mine showed me that after years of working with the RVC. I didn't know about that. So having said that, here you can see my 2 clusters. Let's take a look at what happens if I try to enable trim and map on one of those clusters. I am going to try to enable this on my first cluster. Remember, you could use the number or the name of the cluster. The number would be 0 in this case. Remember, if this is already enabled, the system will tell me that. If it's not enabled, it will enable it. And then at that point, it's going to tell me to power cycle the VMs. You can see, if it's already enabled, which it is in my first cluster, it tells me, no, been there, done that. It's already enabled. Now let's do it on the second cluster. I am going to choose this time around the entry number 1. Remember, that is the one for my second cluster. I have not enabled trim and map on this cluster. So let's see what happens. Once again, I said, let's enable trim and map on this particular cluster. And you can see this will take about a minute, not even. It runs this command. And again, as soon as it finishes, it will tell me that it's time to power cycle the VMs. A few more seconds. Let's see what happens. There it is. Done. You can see it says success. And you can see it says virtual machines need to be power cycled to apply the nmap setting. Well, guys, hopefully you enjoyed that demo, and I'll see you in our next chapter. Thank you, and enjoy the break. Welcome back. It's time to start the new chapter. And as you can see here, this is the chapter that deals with security. Now, if you take a look in this page, we explain why this topic is going to be a critical topic for at least some of you guys. Trust me, having lived 15 years in Arlington, Virginia, next to Washington, D.C., I know that a lot of customers have been asking for encryption for many years. Obviously, they want to protect their data. And in this chapter, we're going to talk about two different things. On one hand, we are going to talk about data at rest encryption. Data at rest encryption is not a new feature. We've had that since vSan 6.6, meaning since Vsphere 6.5 update 1. I'm going to do one demo. And in that demo, I am going to show you how to configure data in transit encryption. Data in transit encryption is brand new in 7.0 update 1. Now, as I go through this lecture, you're going to hear me use different acronyms. I'm going to explain to you every single one of the acronyms, what they are, what they stand for, and what they do. So if you take a look, in this page, we show you that for the first time ever, you have two choices when it comes to encryption. On one hand, you can enable data at rest encryption. We've had that before. This has been around since vSan 6.6. If you want to use data at rest encryption, you need to basically get your hands on a KMS server. VMware does not provide a KMS server, but you can get one from different vendors, such as Dell, EMC, HighTrust, IBM, and so on. But when you look at this illustration, at the bottom, you have the new choice, which is data in transit encryption. Please understand that data in transit encryption does not require a KMS server. This allows me to encrypt the data as it flows through the vSan network. And what this does is it allows me to protect myself against a man-in-the-middle type of attack. Now, when it comes to design considerations, the most important thing here is not to put your KMS server in your vSan data store. So if you take a look, that's what we mentioned in bullet number 1. Bullet number 2 mentions that encryption operations are offloaded to the modern CPUs, so it doesn't really have a huge impact when it comes to performance. Some people may notice a 5% difference when it comes to CPU activity because of encryption. This is not for stretch clusters or 2-node clusters. Here we're talking about, again, encryption at the data store level. And if you take a look, if you enable data at rest encryption, if you have a core dump, the core dump automatically will be encrypted because your server will be in crypto-safe mode. If you take a look at the bottom of the page, they tell you that you don't have to enable both features. You don't have to enable either one, I guess, but you could enable data at rest encryption without data in transit encryption or vice versa. And if you take a look In this page, we talk about roles and permissions. Now, ever since Vsphere 6.5, we have had a role called No Cryptography Administrator. So if I work with somebody else and I'm in charge, if I want to be the only one that in a nutshell messes around with encryption, I am going to log in as administrator at vsphere.local. But if I'm working with somebody else and I don't trust that person when it comes to touching my KMS related configuration, I will create an account for him and I will assign him to the role called No Cryptography Administrator. When you take a look, I've already mentioned that you need to get a KMS server if you want to enable data at rest encryption. If you look at the VMware hardware compatibility guide, you will notice that there's a lot of different KMS servers that we support. They need to be running KMIP version 1.1. And if you take a look, the last time I looked at the list, you had a plethora of KMS servers. For example, you had some from IBM, Dell EMC, HighTrust, and so on. The list continues to grow over time. I remember the very first two, if I'm not mistaken, were the ones from HighTrust and Dell EMC. But recently, again, I've noticed that many more were added to that list. Now, what we try to tell you in this page is that you want to avoid a single point of failure. And your KMS server is going to be a critical component. So for obvious reasons, you want to cluster that KMS server. Be aware that you cannot mix and match two different KMS servers from different vendors. So again, both have to belong to the same vendor. And if you take a look, this starts by going to the vCenter server and actually going to the Configure tab. And when you go to the Configure tab, you select Key Providers. You will notice if you have a brand new vCenter that this section is empty. So step number one entails that you click on Add Standard Key Provider. You have to tell the vCenter who is the KMS server. You have to specify, for example, the port to use. And you need to establish trust. Here, you can see that they tell you that once you tell the vCenter who is the KMS server, notice the vCenter uses KMIP, which is the protocol, to communicate with the KMS server over SSL or TLS. And if you take a look, when you establish trust, what's going to happen is you're going to see a series of choices. The reason you see all these choices, once again, is because we support different KMS servers. Now, having said that, once you take care of this, the next thing you need to do is you need to go to your cluster. You need to select Configure. You need to go to Services under vSan. And you need to say, I want to enable data at rest encryption. In this page, we mentioned three acronyms. Besides KMS, which I've already explained, they mention KEC, they mention DEC, and they mention HEC. KEC means Key Encryption Key. DEC is an acronym that stands for Data Encryption Key. And lastly, HEC is your host encryption key. And in this page, we show you how all the components interact with each other. So this starts with the vCenter communicating with the KMS server. And as you can see, the vCenter server in step number one will request the KEC from the KMS server. Notice the vCenter doesn't store the KEC, but he does store the KEC ID. At that point, the vCenter communicates with all the ESXi hosts in your cluster, and he sends the KEC ID to those hosts. In turn, the hosts will communicate, in this case, directly with the KMS server. And again, what they're going to be doing is they're going to be requesting the KEC from that KMS server. The reason here the hosts have to communicate directly with the KMS server is because if something's wrong with the vCenter and the vCenter happens to be in the vSan data store, the host need to be able to communicate without a middleman. Notice, in turn, the host will create a deck for each drive that they have. If you look at step number 5, notice it says each cache and capacity device is going to be encrypted using the deck. And if you wonder, why do I need a heck? The host encryption key is used to encrypt your core dumps, should you end up with a purple screen of death. And if you take a look, here we're talking about what happens when you encrypt your existing cluster. If you have virtual machines, which we do, of course, when you enable data at rest encryption, the idea here is we're going to go through a DFC. Now, what do I mean by that? This is going to be a fairly long lab. Here in class, I would assume about 15 minutes. Because what's going to happen is every disk group is going to be taken apart temporarily so that the drives can be reformatted. You have the choice to move data around. And when you take a look, right, you can see it says when data at rest encryption is enabled on a new cluster, not what we have, but a new cluster, disks are going to be encrypted as soon as you create the disk groups the first time. But here we already have VMs. And if you think about it, if we're going to be deleting disk groups, the question is, what do we do with the data? So you have a couple of choices. One is not to take any chances and move all the data around. The other one entails that we enable a feature that is called allow reduce redundancy. And we're going to talk about that in a second. In this page, here they tell you that if you're going to be doing a DFC, the idea is you want to make sure that you do this when every host is up and running, none of the hosts are in maintenance mode, all the disks are healthy, all the disk groups are healthy. And like I said, this could take a while. The more disks you have to format, the more hosts you have, the longer it will take. Remember, if you decide to move data around, that will generate a bunch of extra I/O. So you may not want to do this in the middle of the day. Maybe you want to do this off peak hours. Now here, you can see that after you tell the vCenter who is the KMS server, the idea is you get to choose whether you want to enable only data at rest encryption or both, that one and data in transit encryption. And then finally, you get the choice whether or not you want to wipe residual data. And as I mentioned earlier, you have the little checkbox for allow reduce redundancy. In this page, they explain to you that you don't necessarily have to use the option wipe residual data. That is nothing more than a choice. And in the lab, I believe that we don't tell you to use that. So when you take a look, once you again enable data at rest encryption, you can enable that on its own. You can combine that with also the duplication and compression. Or again, you can combine and enable everything at once, meaning dedupe and compression, data at rest encryption, and data in transit encryption. Now, when you take a look, I've already mentioned what is wiping residual data. And here they give you an official explanation. Once again, this is not necessary. When it comes to allow reduce redundancy, remember, we're talking about evacuating the bare minimum to basically speed up the process. Having said that, remember, that means you will have absent components temporarily. And imagine, of course, the worst case scenario. What would happen if you have a failure while you're doing this upgrade? Now, when you take a look, here, we are trying to explain to you what happens when you write data into your virtual disk. Now, let's take a look. When you look at the steps on the left side, first, they tell you that the I/O is going to be broken into chunks. At the point, a checksum is created. You can see then encryption is performed. Remember, data always goes to the cache tier first, and then from there it moves to the capacity tier. So you can see it says encrypted data is written to the right buffer. Notice then, as we're ready to destage the data to the capacity tier, decryption is performed. If you have also enabled dedupe and compression, the idea is simple. First, we perform dedupe and compression, then encryption, which of course means we're not sacrificing the space savings provided by dedupe and compression, because that takes place before encryption. And if you take a look, if you ever decide to grow the cluster, what's going to happen here is as you add a new host, when you look at the very top of this page, notice it says, when you add a host to your encrypted cluster, the new host will automatically receive the key encryption key and the host encryption key from the KMS server. So it's very easy to do that. Now, depending on your requirements, you may have to here and there perform a rekey operation. And you have two types of rekey operations. As you can see in this page, on one hand, you have a shallow rekey operation. On the other one, you have a deep rekey operation. Every time you do a deep rekey operation, that requires a brand new DFC. So again, that will take a while. On the other hand, in most cases, a shallow rekey operation will suffice. Here, you can see again, we're showing you exactly what happens when you decide to change your keys. You can see it says a shallow rekey operation replaces only the KEK. And again, the data does not require to be re-encrypted. That's why it doesn't take too long. But that is not the key, or not the case, I should say, if, for obvious reasons, you decide to do a deep rekey. You can see they tell you here that a deep rekey operation replaces both the KEK and the DEC. As mentioned, you may have certain needs, and among those needs, you may have to rotate your client certificates. So you can see again, all changes should be performed on the vCenter server. And if you take a look, after this chapter, you don't have one particular lab, you actually have two. In the first one, you point to your first KMS server and you enable data at rest encryption. In the second one, you're going to change from one KMS server to another. So that's why you see in this illustration, two KMS servers. These are the names of the KMS servers you're going to use. And if you take a look, out of the two of them, only one is going to be the default at once. But you can see again on the Vsphere client, you have this choice to make the other one the default if that's what you want to do. But it's all about trust. Now, we mentioned earlier that if you have a purple screen of death, your core dump is going to be encrypted automatically. So what do you have to do? If you have an encrypted core dump and you want to send this to our support personnel, you need to provide a password just like we show you here. Because if you don't, the problem is we cannot analyze what is going on in your particular environment. So that takes care of the first part of this chapter. We're going to take a quick little break. And when we come back from the break, we're going to proceed and we're going to combine data in transit encryption with a quick little lab or a quick little demo, call it what you will. Thank you guys. I'll see you after the break. Okay guys, welcome back. So let's start. The first thing I want to show you is that if I select my second cluster, the one called SB vSan 01, when I go to configure, if I choose services, I want you to notice data at rest encryption is disabled and data in transit encryption is disabled. Now in my demo, I'm only going to enable one of these features. Now in the first lab, they're going to tell you to pretty much go to one of your hosts. And they're going to tell you to test connectivity. They're going to tell you to ping your KMS server. Your KMS server should be up and running. Now, if I'm not mistaken, I believe the IP address of the KMS server should be 172.20.10.193, and the book they tell you to ping that particular machine by name. In both cases, you should see a reply. Now, for data at rest encryption, the first thing you would need to do is go to your vCenter. You would go to Configure. And if you just deploy your environment, this is going to be empty. What you have to do is you have to click on Add Standard Key Provider. You come up with a name. Here you choose. Once again, remember you're going to see two options because again, you're going to start with one and then switch to a second one. And when it comes to the address, you can use the IP address and or the name. In class, we use port 5696. So this would be step number one. At that point, you would click on Add Key Provider. A pop-up window would appear. And in that case, what you would do is you would choose Trust. Now I'm going to click on Cancel. Once you do that, notice if you do something wrong, you could always make changes by clicking on Edit, and of course you could also choose Remove. Now in this case, I'm not going to do Remove yet. Typically, again, the second step is you would establish trust. But again, I've mentioned I wasn't going to do the entire demo, just a part. So on purpose, notice I have not configured my KMS server. Therefore, I cannot enable data at rest encryption. Take a look. If I go to SB vSan 01, if I go to services, if I did not take care of my KMS server, I would never be able to click on Edit and successfully enable data at rest encryption. Now, when you specify the key provider, as you specify that particular key provider, the idea is you would see it right here. This will be auto-populated. Now, if I try to turn on data at rest, again, if this is blank, it's going to fail. Now, instead, in my demo, I want to only enable data in transit encryption. Remember, these two are independent from each other. And as we mentioned in the lecture, you can change the read key interval. Now, I don't need to change this. If you take a look, this should be pretty quick. I'm going to click on Apply. And what you want to do typically at this point is you want to look at your recent tasks. Now, when you look at the recent tasks, this should take a couple of minutes. Remember, this does not require a DFC. So you can see your vSan information and configuration is being updated. And again, this I expect it to take about another minute. The goal here is to show you once again that you don't need both, and the new feature does not require, once again, that you have a KMS server. If you take a look, here it is. You can see it is enabled. And once again, if you want, you can click on Edit. You can turn this off when you want to. You can change the read key interval whenever you want to. Or again, if I wanted to at this point, if I specify who the KMS server is, I could very easily also enable data at rest encryption. And that pretty much takes care of this demo. One more thing. Remember, this feature, data in transit encryption, is incompatible with remote vSan. So what I'm going to do for now is I am going to once again turn this off because my demo at this point is pretty much done. So all I can say is have fun. And once again, once we finish this chapter, we have more material to cover. Thank you guys. I'll see you soon. Okay guys, welcome back. So now it's time to talk about data in transit encryption. And prior to the break, I've mentioned that again, this is a brand new feature that was introduced in vSan 7.0 Update 1. Now, when you take a look at the very top of the page, we mentioned that we're talking about encrypting your vSan traffic as it flows through the vSan network. So here in class, we're using VMNIC 3 for vSan. So we're talking about encrypting the data as it flows through VMNIC 3 in this case. And if you wonder why, once again, this will be there to protect yourself against a man-in-the-middle type of attack. Now, if you take a look, we've already mentioned that you can enable both data at rest encryption and data in transit encryption. I'm just going to enable one of them because data at rest encryption is what you get to do in the first lab. I'm not going to do that. I've already talked about the steps. Instead, what I want to do here is I want to show you this new feature. Now, all I'm going to do is I'm going to select the cluster. I don't need a KMS server. I'm going to show you that. I don't need to enable data at rest encryption. All I have to do is choose data in transit encryption. And then in this case, I get to choose whether or not I want to go with the default rekey interval, which is 1 day, or I could change it. If I click on the expander there, be aware that you will have different options. I'll show you those options in my demo. So, how does it work? In this page, we explain to you how this actually takes place. Let's take a look. In this page, it says vSan enforces encryption on vSan traffic exchange between your vSan nodes if and when you enable data in transit encryption. Notice, they tell you here that Virtual SAN creates a TLS link between the different ESXi servers in your cluster. And this again is intended to exchange the traffic. Now, when you take a look, the nodes involved will create a share secret and they will attach it to the current session. And when you look at step number 3 here, it says vSan uses a share secret to establish an authenticated encryption session between, again, the different vSan nodes in your cluster. When you take a look at this page, we see that we have different choices when it comes to the rekey interval. 1 day is the default, but you don't have to do that. Notice the different choices. You have 6 hours, 12 hours, 1 day, and so on. In my demo, I'm going to click on the expander, but I'm not really going to change anything there. And if you need to troubleshoot encryption, remember, your best friend is always going to be Skyline Health. Now, if you select your cluster and you go to Skyline Health, in 7.0 Update 1, you have a whole section for data in transit encryption. And if you take a look, if you have a problem, notice you have a choice that in this case is grayed out. And that is a choice called Remediate Inconsistent Configurations. Having said that, what happens if I decide to grow my cluster? When you take a look at the very top, here it says when you add a host to the data in transit encrypted vSan cluster, the new host configuration is going to be automatically remediated. So you don't have to turn anything off and on. You don't have to make any manual changes and so on. And if you look at the second statement, remember this is new in 7.0 Update 1. So you cannot add an ESXi server running an older version. Otherwise, guess what? You're going to have a network partition. And if you take a look, I've mentioned we have 2 labs. So before you do labs 11 and 12, I'm going to do a quick demo. So hopefully you enjoyed the demo. And remember, I am not going to configure data at rest encryption because, again, that will take a long while. You get to do that in the lab. Thank you guys, and I'll see you during the demo. Okay guys, welcome back. It's time for our next chapter. And as you can see here, this chapter is called vSan Cluster Monitoring. Now let's take a look at this chapter. This is one of those chapters that has several lessons. So when you take a look, we start with the importance page. And you can imagine, of course, it's critical for any sysadmin, for any vSan administrator to constantly monitor what's going on. So in this chapter, we are going to talk about how to monitor your vSan cluster, your vSan data store, your VMs, and so on. And not only that, we're going to mix the Vsphere client also with some commands. So let's take a look at this chapter. This module, you can see, has 3 lessons. The first one is called vSan Health Monitoring. The second one is vSan Performance Monitoring. And the last one is called vSan Capacity Monitoring. Now, as I go through the materials, I'm going to be explaining to you pretty much what you're going to be doing in the labs. And in my demos, I'm going to show you, for example, how to break your cluster. And we're going to do a series of demos where, for example, we're going to create cluster partitions. We're going to have losses when it comes to the disks. So we're going to see how the vSan cluster reacts. Throughout my demos, I will be using the different clusters, both cluster A and cluster B. So let's start with the first lesson. And again, this lesson is called vSan Health Monitoring. So when you take a look, here we start not necessarily with Skyline Health. We start by explaining why you may want to consider joining the Customer Experience Improvement Program. After that, we talk about again how to monitor your vSan cluster. And in particular, we're going to be dealing with the health service, which nowadays is called Skyline Health. I'm going to be combining that with some commands. And if you like the command line, I would suggest that you remember ESX CLI vSan. Not only that, you may want to remember ESX CLI vSan and debug, and also ESX CLI vSan Health. So when you take a look, here they're talking about the Customer Experience Improvement Program. And there's a lot of reasons why you may want to consider joining that program. As you can see here, notice this not only helps us, but it also helps you. Now, when you take a look at the very top, it says the CEIP helps us, aka VMware, improve our products and services by collecting anonymous data from different customers. And notice the data that we collect is related to how our customers use our products. So you can see again, we collect configuration related data, feature use, meaning what features are our customers using. Not only that, we get performance related information and also information from logs. So when you take a look here, we show you how to join this CEIP. In class, we don't do that. Please, again, don't do that. But in any event, by doing that, not only you're helping VMware, you then also have access to additional features and tools that without it, you cannot use. So having said that, let's talk about this. With the last few versions of vSan, we always allow our customers to run these proactive tests. Now in 7X, you have 2 different tests. I'm going to show you these tests in my demo. The first one is called Virtual Machine Creation Test. And what this test will do is it will create temporarily 1 VM for each of your hosts. Within a minute or less, those VMs get created, then the VMs get deleted, and then you get the results of the test. If you run that test in class, expect that test to pass. Having said that, there is another test. This one's called Network Performance Test. This one, however, will always give you a warning in class because remember, our servers are nested. This one is simply, again, testing the performance of the network. So don't be surprised if you run that one, that you're going to get warnings throughout. But again, typically you run these tests before you put the cluster in production. And if you don't get the results that you expect, maybe it's time to go back to the drawing board, fix whatever issue you may be dealing with or having, and then again, do the test again. Now, when you look at this page, here we introduce the concept of Skyline Health. And I always tell my students that this is your best friend when it comes to troubleshooting your vSan cluster. We've had this service for a while. We used to call it the health service. It was renamed in 7X. But in any event, The idea is the same. When you have a problem with vSan, you always want to go here first. Now, the idea is simple. If you see, for example, a red circle in the old days in the web client, a red diamond, or any type of error or warning, always start by going to your cluster, and from there, go to the Monitor tab. When you go to the Monitor tab, underneath vSan, select Skyline Health, and you're going to see a series of tests. And again, these tests will tell you whether you're having issues when it comes to the network, whether you're having issues when it comes to your data, your objects, whether you're having issues with cluster partitions. Now, as you can see here, we have a series of tests. And again, at different times, you may see everything in green, which is what you want to see, or potentially don't. Notice there's a section for networking. There's a section for your physical disks, a section for data, a section for clustering, and so on. And in my demo, I am going to show you how we can break the cluster in a variety of ways and how quickly you could ascertain who the culprit is. Now, in this page, here we talk about online health. And if you take a look at the very top, we explain what this is. Notice it says online health includes vSan Support Insight and also Skyline Advisor. If you take a look here, you have a brief explanation of the two products. First, notice it says vSan Support Insight helps vSan users maintain a reliable and consistent compute, storage, and network environment. But for you to use this, as mentioned earlier, you would have to join the CEIP. And when you take a look then, we see a paragraph talking about Skyline Advisor. And notice again, this only works if you have Premier support. But again, the idea here is we try to be proactive when it comes to figuring out what potentially could go wrong and make your life a little easier in the process. So going back to Skyline Health, here you can see, for example, that in this particular scenario, everything looks clean. Now, in this case, we're looking at the test to see whether or not we have a cluster partition. Now, if you notice, everything looks green. That's good. But besides that, when you take a look, as you look at the partition list, you can see that your 4 hosts happen to be on the same partition. If you ever see, for example, 3 servers on partition 1 and a host on partition 2, then that's the guy that happens to be network isolated. He's the one that doesn't see the other 3. And the worst case scenario, of course, would be to have 4 servers in this case and seeing each and every single one of the servers in a different partition. That means you have a total network failure. Now, if you see that type of problem, right? Number one, the question is, did you actually consider perhaps using redundancy throughout? But besides that, you're having a bad day. Now, in that case, none of your VMs will run because, again, you will never have the majority of the votes. So this is what you want to see. Every single host on the same network partition. You can also see here that every host has a unique ID. Now, here you have another example of what you expect to see. And this one is related to networking. So you can see in this case, we're talking about the network latency check. And once again, everything looks clean here. So again, we're trying to show you what we expect you to see. Having said that, in my demos, trust me, you're not going to see everything green. You're going to see things sometimes in yellow and or red. Now, in this case, we're talking about taking a look at your data. Now, in this case, you can see that everything is green. Now, notice carefully the right side. And on the right side, you have 2 choices there, which happen to be grayed out. The first one is repair objects immediately. We kind of talked about this before. Now, remember, typically you want to use that if, let's say, a host crashes and you know it's not coming back. Remember, when a host crashes, by default, we wait 60 minutes for us to rebuild the data. Now, if you know the server's not coming back in an hour because, let's say, the motherboard is fried, you don't want to sit there for another 15 minutes. start rebuilding the objects immediately. And then you also have another choice called Purge Inaccessible VM Swap Objects. In the old days, you could only do that with the RVC, the Ruby Vsphere console. But over the last few years, VMware has added a lot of bells and whistles to the Vsphere client, so you don't have to necessarily rely on that tool called the RVC. Here you have another example. This one, to a point, is self-explanatory. This one is about time synchronization. And once again, as you can see here, every single one of the hosts happens to have the NTP service enabled, and everything looks clean. Now, we've talked about this one as well. And remember, in the old days, we had a feature called proactive rebalance. And the system would always tell you to do a proactive rebalance if the variance when it comes to space utilization was higher than 30% between two different disks, potentially on the same or different hosts. So in this case, you can see everything looks good. So you don't have to do a proactive rebalance. Notice the maximum load variance in this case is 3%. Remember, 30% is the default threshold. If you exceed 30%, unless you have enabled automatic rebalance, the system will give you a warning saying that it would be a good idea to click on that icon called proactive rebalance. And then again, at that point, allow the system to move data around to rebalance space across different disks. Now, if you're going to do that, not a good idea to do that in the middle of the day because you're talking about potentially adding a lot of extra I/O. So this may happen, for example, if you just add a bunch of new drives. The new drives will be empty to begin with. The existing ones may be at 50, 60%. So in that case, the variance is higher than 30%. And if you take a look, we talked about upgrades, and we've mentioned that you want to make sure that every single host has every single drive with the same disk format version. Remember that we talked about if we do an upgrade, in some cases you may have to do a DFC upgrade. Here you can see we have 4 hosts. Once again, everything looks clean. So again, you don't have any disks that were not magically upgraded. Now, this may show something different. If you're doing an upgrade of the DFC and halfway through, perhaps one of your hosts crashes. At that point, the test may fail halfway through. And again, you may have disks that were upgraded and other disks that were not. And if you take a look, this is very important. Now, when you take a look here, we can see that all the advanced parameters of every host when it comes to vSan happen to match. And that's what you want to see. Now, if you take a look, here you see that you have a match when it comes to, again, parameters such as the object repair timer, side read locality, and so on. Now, if you take a look, you could change some parameters on the command line, let's say, or with the Vsphere client. So, for example, there is a parameter. I'm going to show you this in the demo, but there is a parameter that, for example, allows me to dictate how big a component could be. If I was going to change that, you want to change it in every host. If I only change it in one host out of 4, let's say, the system eventually will complain that I have advanced parameters out of sync. So that would be, again, a typical warning. And the way you fix it, again, is you start by looking at Skyline Health. And if you take a look, once again, here, you have another example. This one's related to capacity. And here, you can see it says VMware Skyline Health vSan component utilization. This check examines component utilization for the entire cluster. And if you take a look, it says it displays a warning or error if the utilization exceeds 80% for the cluster or 90% for any host. So once again, in this case, everything looks good. Remember, we've mentioned several times the concept of slack space. So if you're exceeding 80% of the space when it comes to the cluster, it may be time to perhaps grow the cluster or potentially migrate VMs elsewhere if you can. So when you take a look, here you have another test that in the old days could only be performed with the Ruby vSphere console. Notice again, this one is called, what if the most consume host fails? Meaning, what would happen if one of your servers just crashes? When it comes to space, would you be out of space or not? And once again, in this case, you can see you're not even remotely close to running out of space. So when you take a look, this is just nothing more than a quick intro to Skyline Health. Remember, in my demo, I am going to show you all sorts of examples. And again, the demo will be extensive because again, this is one of the most important things. Also do remember, we do have an entire vSan troubleshooting class that all of us at VMware teach. And again, that's a pretty cool class. In that workshop, first we lecture, and then you run scripts, and those scripts magically break your cluster. It's going to be up to you in that class to figure out exactly what the script did. And again, those scripts emulate real life. Thank you guys, and I'll see you when we do the demo. Thanks. Welcome back, guys. Okay, it's time for another demo. And in this case, what I want to do is I want to show you how to break your vSan cluster for testing purposes. Remember, I've mentioned in the lecture that your best friend when it comes to troubleshooting is Skyline Health. I've done already a couple of demos, but I want to do a few more. If you recall, I did a demo about a network partition. So in this case, I want to combine the GUI and the command line and have some fun in the process. Earlier, I told you that I was going to show you how to magically fail the disk, or for that matter, unplug a disk. So that's what we're going to be doing here. So let's take a look. Right now, I have two clusters. Both clusters are healthy. Remember, the first cluster has 3 VMs, and at least one of them is RAID 5. I want you to remember that. The first VM is RAID 5. I'm going to ignore the other 2. So, we mentioned earlier that every time you have a problem, in no time whatsoever, you expect to see red circles on the vSphere client. If you're still using 6.7 and maybe you're still using the web client, push come to shove, again, red diamonds. But no matter which one we're talking about, the idea is the same. In previous versions, Skyline Health was called the health service. But if you understand one, you understand the other one. So let's take a look. Right now I have a 4-node cluster and I have 3 VMs running. So before we again break the cluster, let's take a look. I've mentioned the first VM is RAID 5. So we're going to concentrate on that one. Because if this VM is RAID 5, remember this VM is using all the disks in your vSan data store. Remember, 4 nodes, 1 disk group per node, or let me rephrase that, yeah, 1 disk group per node with 1 cache and 1 capacity disk. So that VM, no matter which disk magically fails, is going to be affected by that. Now, when it comes to the other VMs, let's take a look. This one, you can see is a two-way mirror. And the last one, let's take a look at this one. This one, you can see is also a two-way mirror. So, let's talk about different problems. The first thing I want to show you is the fact that each ESXi server has Python installed. Now, buried in each ESXi server, in the folder called user live VMware vSan bin, we have different scripts, including a script called vSan disk fault injection.pyc. Now, let's take a look at this one. I'm going to go to dev disks. And remember, your disks are located or found in this folder. Now, this folder is a link to VMFS devices disks. But again, I'm going to be working from here. So if you take a look, I am going to run this command. And initially, give me a second. I am going to use the option --help. Now, if you take a look at the output of --help, you can see that we have different options, including the U option. The U option allows me to emulate unplugging a disk. I have the P option. The P option allows me to inject a permanent failure. If I use the P option, I need to use the C option to clear that failure. You could also inject a transient or temporary failure. So in this case, we are going to run this command with the U option. The U is for unplug. And then we're going to specify a particular disk. In this demo, I am going to choose the capacity disk for this host. I'm just picking one randomly, but again, it's a capacity disk. Now, underneath this utility will run another command called Vsphere Interactive Shell, VSISH. Now, we have this command for testing purposes. And if you take a look, when you run the command, you want to look at the output. You want to make sure that it says that it injected the issue onto that drive. If it says on none, that means you did not type the command properly. So this would be the same thing as if I go to your data center and I randomly unplug a drive. I'm talking about one of the hot swappable devices. So let's take a look. To speed this up, I am going to make sure, number one, that this is SAES601, not SB01. So I'm working with the first cluster. What we're going to be doing here is we're going to select the cluster. We're going to go to monitor. And when we go to monitor, to speed this up, I'm going to do the following. Notice underneath vSan, I am going to choose Scala Health. Remember, my VMs don't have an operating system installed, so there is no I/O taking place. That's why you don't start seeing immediately these red circles and stuff like that. So right now, notice everything seems to be okay. Now, some of these have been disabled. I'm talking about some of these tests. So I'm going to click on retest. And when I click on retest, I expect to see failures. Notice there it is. There's my infamous red circle on top of the cluster. So in real life, let's say somebody calls you up and they're like, hey, we have a problem. I see a red circle either at the host level or the cluster level, whatever the case may be. What do you do? Again, the first thing you want to do, select the cluster, go to monitor, and go to Scala Health. Notice, in this case, we have issues. If I unplug a disk, and I know for sure that disk had at least one component, which it did, obviously some of my objects were affected by this. Think about it. At least one VM for sure was affected by this. But also you want to remember that we have other objects as well, such as the stats DB object. So notice, my failure in this case affected X number of VMs and in the process, X number of objects. Now let's dissect it. If you take a look, in this case, I am going to, for example, just choose vSan object health. This gives me an idea of how many objects were affected by my failure. And in the process, you can see that I have the choice to click on repair objects immediately. Now remember, this is an example of an absent component, because it's not like the disk was slowly but surely failing and sending error messages. It magically vanished. So when you take a look, a bunch of objects were affected by this. That includes, of course, the stats DB object, the one for the performance service. And if I take a look at my VMs, remember this VM should have three objects: the VM home namespace object, the disk object, and the swap object. Now let's take a look. Because this VM was RAID 5, I expect three objects here to be affected. There is 1, 2, and 3. So once again, notice we're talking about the three objects were affected by this. Once again, you can click on the expander. Now, let's take a look at this VM. Now, this VM was a two-way mirror VM. So maybe it was affected by this or not. And quickly you can see that when it comes to the hard disk, one of the components is missing. When it comes to the VM home namespace object, again, one of the components is missing. And if you take a look, he got lucky when it comes to the swap object. All three components, including again the witness component, were untouched. And lastly, in this case, VM3, let's see if it was affected or not. Notice it was. So, in this case, as mentioned earlier, from the get-go, you want to go first and foremost always to Skyline Health. Now, let's take a look at other things. If I select my cluster and I go to configure, remember, one of the disk scripts was affected by this. So you can imagine in this case, I could go to the cluster, I could go to configure. And when I go to disk management, I would expect to see something wrong here. Let's maximize this. So notice, here you can see that there is a problem with the only disk group in host 1. You can see you have an absent disk. And again, if you think about it, the way I fix it in this case is by simply performing a rescan, because technically I did not physically remove that disk. But if I go back to monitor, once again, we're going to go back to Skyline Health. And once again, if I go here, you can see, of course, all sorts of tests available. Now, if you think about it here, you can see very quickly that if I choose Operation Health, it tells me where the problem is. So if I have a 64-node cluster or a 30-node cluster, whatever the case may be, I don't have to look at every single host. Once again, very quickly, I can see the problem is what? Related to SA01. And it gives me the unique ID of the disk that is absent. We mentioned when a disk fails, it affects potentially X number of objects. And again, not only, of course, the objects for the VMs, but also potentially the ones for StatsDB, or again, iSCSI objects, or nowadays file service related objects. So to fix this, all I have to do is perform a rescan. I could do that with the GUI. I typically prefer to run this, although I could also use the newer version of this command located in ESXCLI. So when I perform the rescan, at this point, I am going to do a retest. And when I do a retest, you can imagine the disk will magically reappear. Now remember, I also could have done the rescan from here. So if I go to the host and I go to configure, if I go to storage adapters, here is rescan. That's the same thing. The difference is in this case, I'm not bypassing the vCenter. Now, no matter what, the disk should reappear. The objects, when it comes to the components, they will be taken care of. So let's take a look. You can see without me doing anything else, the red diamond has vanished. So very quickly here, I am going to scroll down one more time. We're going to take a look at the section for vSan. And we're going to realize in this scenario that the disk group is okay again. Let's take a look. Disk management. And everything looks beautiful. And once again, if I go back to monitor, if I go to Skyline Health, take a look. Everything should be clean now. Everything should be green. Notice nothing related to the network in this case, or for that matter, nothing related to physical disks or data. So that's an easy demo. So hopefully, again, you enjoyed the Python script. Remember, the Python script is found in every single one of your ESXi servers. Please don't run that command in your production cluster. Again, that command should be used for testing purposes before you put the cluster in production. Thank you, guys, and I'll see you in the next lesson. Thanks again. All right, guys, welcome back. It's time to cover lesson number 2. As you can see here, this lesson is called vSan Performance Monitoring. So what we're going to be talking about here is a service called the Performance Service. And again, this service has been around for a while. And for the last few versions, this service has been enabled. In the old days, the service was not enabled by default. But again, in 6.7 and 7.0, this service is automatically enabled. And although you could disable it, we don't recommend you do that. Here you see the goals of this particular module. And again, we're going to be talking about how to monitor what's going on when it comes to your cluster, your hosts, and also the VMs. What we're talking about here in particular is the ability to take a look at really pretty charts that will show you what's going on at the vSan level. Now, I'm going to be doing demos once again. And if you take a look, right, we're going to go through this chapter and understand what exactly is the performance service. But if you take a look, before we start with that, we have this extra page. And notice this page is called vSan Online Performance Diagnostics. So when you look at this page, let's take a look at exactly what they're showing here. And you can see they're saying that the vSan Online Performance Diagnostics tool collects performance data and once again sends it to VMware for us to analyze. That again is, for example, how we make our products better. So when you take a look here, right, we show you exactly how to use this feature. But again, the bulk of the chapter deals with the performance service. And that's what we show you here. So we've had this for many, many years. We didn't have this back in the old days. I'm talking about back in 5.5, update 1 or 6.0. But again, if you've been working vSan, let's say from 6.5, 6.7, or even 7X, you've seen this service. As I mentioned, this service now has been enabled for a while. And what this service does is it gives you more exposure to what's going on when it comes to your vSan cluster. If you look at this capture, here once again you can see that this service is enabled. You can click on edit and you can technically disable it. Don't do that. It's just not a good idea. Now the cool thing about this performance service is that it stores information, but it does not store that information in the database of the vCenter. Instead, it stores that information in an object. That object is inside of the vSan data store. And that object is called the statsDB object. By default, that object is a two-way mirror. But if you want, you can say, gee, I want that object, for example, to be something else like RAID 5. Now, when you take a look, here you can see that that object has a UUID. And once again, in this case, you can see that everything looks good. This object is a two-way mirror. It's using the default policy. You can see again, when it comes to compliance, it says compliant. That means no absent components or anything like that. And other than that, notice you have something called verbose mode, which is never enabled by default. So if you take a look, all we try to show you here is that this particular service will capture and show you all sorts of traffic. So with vSan, we have what we call front-end traffic, and we also have back-end traffic. Now here they try to tell you and explain the difference between front-end VM traffic and again back-end traffic. Now when you look at the statements on the left side, you can see they're trying to tell you, number one, when I'm talking about front-end storage traffic, this is the traffic generated by your virtual machines. This is your VM IO traffic. Now, when we're talking about back-end storage traffic, as you can see here, we're talking about, for example, additional activity that is taking place potentially because of a resync operation or because of the actual replication of your VMs. Remember, after all, if your VM is a two-way mirror, you're writing the data twice. If your VM, of course, is RAID 5, you're writing the data, right, to 4 different hosts. So that's what we're talking about backend traffic. And when you take a look, what we try to show you here is that when it comes to the performance service, you have pretty performance related charts at the cluster level, at the host level, and also at the VM level. Now notice here you can see when it comes to performance, you have different tabs. For example, you have one for VMs, one for backend, and one for something called IO Insight, which again is fairly new and you're going to get to play with that in the lab. Now, this, as you can see, is an example of what you expect to see when you look at this performance related charts. So we're talking about charts related to IOPS, charts related to throughput. And as you can see also, right, we're talking about charts that will show you, for example, read and write latency as well. And again, we have all sorts of charts. Please pay attention to the demo if you never use this feature. So when you take a look, here we're showing you examples of different types of charts. Once again, if I go back to the previous page, we were talking about cluster level metrics for VMs. Here again, we're talking about backend cluster level metrics. So if you take a look, remember, you can actually compare different charts in order to truly understand what is being generated by the VMs and what is being generated by additional routines taking place simultaneously. So once again, when you look at this particular page, notice it says throughput comparison, and it says compare the charts for the throughput metric of VMs and the backend. Now, in this page, we introduce a feature called IO Insight. So we're talking about vSan IO Insight. And you get to actually play with this in the lab. In my demo, we'll do a demo. And again, remember here our VMs don't necessarily have an OS, so don't expect to see much. But when you look at the statement on the left side, it says IO Insight captures IO traces from ESXi and generates metrics that represent the storage IO behavior for a particular VM at the VMDK level. So the idea here is simple. Using the Vsphere client, you decide whether you want to analyze one VM or potentially more than one VM. And to use IO Insight, you have to create a new instance. You tell the system how long to run for, and then again, when it's done, it will tell you exactly what's going on. So if you take a look, here they're showing you that they're creating a new instance. And notice the duration. Here they're saying, I want you to have these VMs, right, obviously run for X number of minutes. And in this case, after 10 minutes, show me what has been happening. Now, when you click on the expanders for these ESXi hosts, as I mentioned earlier, you can choose all of your VMs, or again, maybe just a handful. As soon as you select your VMs, you click on Finish. And again, notice it tells you this test, right, this instance will start immediately. If you go with 10 minutes, after 10 minutes, you can view the results. And if you take a look, here we show you how to do that. So notice, once you create the instance, and again, we capture that IO, you have the chance to view the metrics, or if you want to, rerun that instance a second time to see if anything has changed. Or one of the things you may want to do once you're done is simply delete them. Now, here you have an example of charts that you may see at the host level. Remember, you can see charts at the cluster level, at the host level, and at the VM level. So if you look at this example, you can see here we're choosing a host. And the host is, in this case, saesxi01.vclass.local. Remember, all you have to do is, in this case, select the host and go to the Monitor tab. And when you go to the Monitor tab, you click on Performance. And then you get to choose exactly what you want to see. So notice, in this case, we're showing you that if you select disks, you can say, show me what has been happening. And then you can be very specific. You could choose one of your many disk groups if you have more than one. And once again, you can say, I want you to show me what happened in the last 1 hour or potentially 24 hours and so on. Just like that, I want you to notice we have other tabs. So you can also see what happens, for example, for the VM NIC that we use for vSan. So notice again, you have a tab there for physical adapters, for host networking, and so on. And if you take a look, once again, all sorts of charts are available to you. So in this case, we're talking about the cache tier. Remember, every disk has one and only one cache device. And once again, you can see all sorts of information. One of the things you want to make sure you don't have is congestion. So if you take a look, here we're talking about the write buffer. Now, I would suggest that you spend a few minutes and definitely take a look at what is available to you. You can see here we're showing you additional charts. And in this case, these are charts related to our resync operation. Now, if you take a look at the actual charts on the right side, you can see that we have pretty charts related to resync IOPS, resync throughput, and so on. Now, once again, I would suggest if you've never used this, to pay close attention to my demos. And I'm going to show you different charts available once again at the cluster, host, and VM level. I also mentioned that it's not just about the disks, it's also about the network. Remember, all of the data flows through the vSan network. So you want to make sure, for example, that you're not dropping packets, that you're having good performance, and so on. Here, we're selecting a VM. So in this case, notice we're not selecting the cluster. We're not selecting a host. We're just picking one VM. This VM is SAVM01. Once again, you select the VM, you go to monitor, and then you go to performance. And one of the things that you could do is take a look at charts for individual disks. So if your VM has, let's say, a boot drive and an application drive, you can say, show me what has been happening with the application drive. And once again, you can choose your time range. As you can see here, they're choosing 1 hour, which is the default. And again, they're selecting, in this case, the first virtual disk. On that note, in a minute, I will see you again while I'm doing a demo. And again, I'm going to show you all sorts of charts available. Hopefully, again, you enjoyed that presentation. And remember, when it comes to performance, this would be the easiest way to take a look at what's going on. In the old days, I'm talking about back in 5.5 and 6.0, before we had this performance service, we used to have to rely on another tool called vSan Observer. The drawback of vSan Observer was that it had to be, number one, enabled through the Ruby Vsphere console, and number two, it consumed a lot of resources on the vCenter. This, instead, doesn't do that. And again, it does not store the results on the database of the vCenter. It actually stores them in an object. So this also stores historical data. And the vSan Observer never did. So this is definitely much better. That's why I'm telling you not to ever disable it. Thank you, guys. Welcome back. It's time for lesson number 3. And as you can see here, this lesson is called vSan Capacity Monitoring. Now, this lesson is not too long. And as you can see here, when it comes to the goals, it is quite simple. The idea here is we want to take a look at the Vsphere client to understand how you and your peers are using the space in the vSan data store. Now, when you take a look, the first thing we're doing here is we're selecting the cluster. And as you can see here, once we select the cluster, somebody here is clicking on the Monitor tab. And when you click on the Monitor tab, you have this entry called Capacity. Now, there's all sorts of information available to you here. Here you can see we have 2 tabs. One is called Capacity Usage. The second one is called Capacity History. And in this case, in this particular illustration, I can see, number one, how big is my vSan data store? Number two, I can see whether or not I'm running out of space. And number 3, I can see how much space is still free or available. Now, if you look here, there's a little explanation about what they mean by actually written. Now, if you take a look, It says information in the capacity overview includes used, and in quotes, actually written space at the capacity tier, and then free space on disks. Because if you think about it, remember that we're talking about how much space you're using. But again, that to a point could be a bit confusing or misleading, considering the fact that you could be using a variety of different policies, or for that matter, the fact that again, you gotta remember that most of your VMs, if not all of your VMs, are gonna be thin provision because they are thin provision by default. So if you take a look in this case, I'm not even remotely close to running out of space. According to this, I have about 192 gigs of free space, and I have only used up 8 gigs. You can even see the percentage. Now, some of you guys may have enabled deduplication and compression. Others, nowadays, compression only perhaps. Some of you guys don't enable either one. So not only, again, I can see how much space I still have free, but I can also save how much I'm saving because of dedupe and compression. And you can even see the ratio. So, some of you guys, again, will use dedupe and compression. And remember, with deduplication and compression enabled, the advantage is that you can save a lot of space. If there is a disadvantage, it's the fact that you cannot remove a capacity disk from a disk group. You would have to take apart the entire disk group. That's why in 7.0 Update 1 we introduced compression only. Now with compression only, you will not save as much space compared to if you enable both. But if you lose a disk, I'm talking about a capacity disk, then you don't have to take apart the entire disk group. All you have to do is simply remove and replace the failed disk. Now, when we look at this page, remember, you may see, for example, that you have 100 gigs available, but that doesn't really mean that you have 100 gigs of unique space. Think about it. If your VMs are two-way mirrors, if it says you have about 100 gigs free, in this case 191, realistically, if your VMs are going to be two-way mirrors, you only have space for half of that. So the numbers will change, whether you're using the default policy or other policies like RAID 5. So when you look at the bottom of the screen, when we're talking about capacity usage, you can see that when it comes to usable capacity analysis, you could choose, right, to go with the default storage policy. In that case, as you can see here, if I have 191 gigs of free space, realistically speaking, I only have space for 95 gigs. That value, 95 gigs, will change if you change the policy. So for example, if I select RAID 5 instead of FTT1, you better believe that when it comes to effective free space, that number would increase. Because remember, if your VM is 100 gigs, if your VM is a two-way mirror, that VM potentially could use 200 gigs. With RAID 5, you're saving 33% of the space compared to a two-way mirror. Just like, for example, RAID 6 will save you 50% of the space compared to a three-way mirror. So you may want to look into this, but again, remember, just because you see 191 gigs of free space, it doesn't mean that you really have that. You may have to divide that by 2, again, if your VMs are two-way mirrors. Plus, remember, there's something called slack space that you may want to consider. And if you take a look, if you want detailed information on how the space is used, you can see it right here. So in this case, you have this pretty chart that shows you how all the space is being used. Now, this is not what you're going to see in real life. I'm assuming, of course, in real life, in a production environment, most of your space will be used by your virtual machine objects. But again, remember, here in class, we only have a handful of VMs. And again, they don't even have an OS installed. And if the VMs are thin provision, they don't use a lot of space. But here you can see the breakdown on how this space is being used. Typically, I would expect the majority of the space to be used by the virtual machines. But if you think about it again, some of the space is also used by the statsdb object, your file service objects, or for that matter, also if you use ASCII, that as well. Now, there's also overhead when it comes to some of the features that we use. So if we look at this example, You can see the breakdown between VMDKs and swap objects. And just like that, you have again these other entries for overhead, including the one for dedupe and compression. And again, in real life, dedupe and compression will never use 51% of the space. That's only in class. And if you take a look, not only I can take a look at capacity usage, I could also click on the tab called Capacity History. And this gives me an idea of how quickly, let's say, I'm using up the space over time. So this kind of helps you figure out how quickly you're growing, if you're growing at all. And again, at what point you may want to consider perhaps growing the size of your vSan data store. Now, we've talked about this briefly before. And again, remember, in 7.0 Update 1, you have this new feature called vSan Capacity Reserve. Now here, we're looking at the Monitor tab. And this feature, again, is not enabled by default. So if you click on Configure, this again would allow you to reserve a portion of the space of the vSan data store for operations and or for host rebuild operations as well. So when you take a look, in a few minutes, you will have the chance to perform not one but two labs. One is going to be similar to my first demo. That's going to be the one dealing with Skyline Health. The second one is the one that again allows you to look at all these performance related charts, and also it allows you to see how your space is being used in your vSan data store. All right, so please again, take a look at my demos and have fun. Thank you guys. Welcome back. And now it's time to do another demo. In this demo, we're going to be playing with the performance service. And in the process, we're going to combine this demo with a demo where we show you capacity related information. So let's take a look. Now we're going to start with the performance service. So in the lecture, we've mentioned that when you take a look at your cluster, by default, you have a service called the performance service. And this service is enabled by default. Here you can see it is enabled. Once again, you can click on edit. I've mentioned you don't want to disable it, but you could. And again, nothing says that you have to go with a two-way mirror. So for example, one of the things that I could choose is obviously a different policy. So maybe just to show you something, I'm going to change it to RAID 5. Now in this case, remember that object will go through a reconfiguration. And what I'm going to try to do is I'm going to try to show you an example of reconfiguration. Let's see if we can catch it on time. Now here I can see all the different objects that I have. And one of them is the stats DB object. We've mentioned earlier that the system is now creating new components, copying the data, and then it's going to erase the original components. So maybe I get lucky. Again, maybe I can see this on time, maybe not. If we don't, not the end of the world. So let's take a look. That I may not be able to show you this, but in any event, remember, it is an object. It is a two-way mirror object by default. And as we speak, I decided to change it from RAID 1 to RAID 5, which again would save me space. Now, initially, again, that object will use twice the space. Well, I don't think this is going to, of course, update in time. Now, having said that, let's go back again to the performance service. Now, we've mentioned we have charts at the cluster level, at the host level, and also at the VM level. So let's start with one VM. Remember here, my VMs don't have an operating system. They don't have any applications. And again, they're not generating any IO. So at the VM level, I could choose performance. Remember, performance under vSan. And as we mentioned earlier, you have all sorts of charts. So notice you have a tab for VM and a tab for virtual disks. And I don't have to necessarily go with the default time range. I can change that as well. Here you can see charts related to read and write IOPS, read and write latency, and again, the same thing for throughput. Now, I could go to virtual disks, and obviously if I have more than one disk, I could be very specific. And here you have charts related to IOPS. When you take a look, now I'm going to go to a host. I'm going to go to monitor. And when I scroll down, I'm going to click on performance. Now here you see what they were showing you in the book. So if you take a look, I can always go to IO Insight. We mentioned this is a new feature. And if you take a look, here you can see that you have the ability to pick one VM or more than one. Now, if you take a look, the idea here is I would choose one of those VMs, create an instance, and then specify how long I want to run that for. Now, before I go there, remember in class, we're using VMNIC 3 for vSan. So once again, I can see throughput at the physical NIC layer. If you take a look, I can see any errors potentially, whether I'm dropping packets. So it's not just statistics about the disks. Again, we have it also for networking. And if you take a look, remember each host has only one disk group. Realistically, you could have more than one. And again, you can be very specific and choose either the cache disk or the capacity disk. Now I want to go to the cluster. And when I go to the cluster, once again, here is performance, not to be confused with performance diagnostics. Now I'm going to go to IO Insight here. And let's run this for a couple of minutes. Once again, you can tell it again what to select. And if you think about it, here's where you specify the duration for your instance. Now, no way, of course, I would be sitting here for 10 minutes. But if you think about it, that's how you set this up. Now, here is what you see, whether or not you have different VMs. And again, these are new VMs, which, by the way, are related to a new feature in clustering 7OPD1. So these are not necessarily the ones that I'm showing you here. So we've mentioned we have charts all over the place. Once again, latency related charts, IOPS related charts, throughput related charts, and also congestions. Now, we talked about capacity. And when it comes to capacity, remember, you select the cluster and you look for the section on vSan. Here's capacity. Now, here's capacity usage and capacity history. Now, for obvious reasons, the space utilization is not growing, so there's nothing to show you there. But here you can see that my vSan data store is 200 gigs. Currently, I have 190 gigs free. And the system says, hey, if you're going to create VMs and the VMs are going to be two-way mirrors, you have 95 gigs or effective free space. That changes when I choose, again, a different policy. If I choose RAID 5, this should increase. There it is. That's what I was saying during the lecture. And here you have the breakdown when it comes to how the space is being used. Again, this will change significantly. If, for example, here in class, you enable iSCSI and you create iSCSI lawns, which are really objects, or for that matter, the same principle when it comes to file service. What else can I show you? Let's see, we talked about capacity. Here we've mentioned that you could enable operations and host rebuild reserve. So notice from the monitor tab, you click on configure. This will again take you to the configure tab. You can do this also from the configure tab. So notice again, you could enable one or both from here. And that pretty much takes care of this second demo. When you go back to work, if you have a cluster, go take a look at what you actually see. Thank you guys, and I'll see you in the next chapter. Have fun. Welcome back, guys. And it's time to start the next chapter. As you can see here, the name of this chapter is Configure and Manage vSan Direct for Cloud Native Applications. In this chapter, you're going to see a brand new feature that was introduced in 7.0 Update 1. And although you don't have a lab for this, I want to do a quick demo. If you want, you can always do the same thing that I'm doing, and in a nutshell, you can make your own lab. So let's take a look at what this is. Let's talk about why this could be something very important for some of you guys. Let's read what it says in this page. Notice it says employing vSan Direct to manage local disks that use vSan management capabilities is beneficial when working with cloud native storage, such as persistent volumes. So the first thing to understand is that this feature was created with Kubernetes in mind. So what we're talking about here in a nutshell is taking internal drives, which are not part of your vSan data store, and with the Vsphere client, turning them into vSan Direct data stores. So we're talking about creating file systems, data stores that use VMFS, to be more precise or to be more specific, VMFS-L, and somehow managing those data stores as if they were vSan data stores. Now let's take a look at the goals. Here, you can see that first and foremost, I want to explain what vSan Direct is. And once again, although you don't have a lab, I want to do a demo. In order to do a demo, I am going to have to delete a disk group because we don't have additional disks to play with. So I am going to be doing this demo on my second cluster. Notice bullet number 2 says, we will explain the use cases of vSan Direct. And once again, the idea here is you can create these data stores and give them to your DevOps people, to your Kubernetes people. That way they can use them, perhaps as persistent volumes. And when you take a look, notice the third bullet mentions, once again, that this was pretty much created with one thing in mind. And then lastly, we're going to see not only how to create those data stores, but then what you would actually expect to see when you go to different places in both the Vsphere client and also the CLI. I'm talking about the command line. So let's talk about this feature. If you take a look here at the very top, they mention once again that this feature enables users to create a vSan Direct data store on a single disk. So we're talking about taking a disk that does not have a file system and using the Vsphere client, telling your cluster that those individual disks are going to be vSan Direct data stores. Now, when I do my demo, I want to show you the partitioning scheme of that drive before we actually create a vSan Direct data store. And then, of course, I'm going to show you the same partitioning scheme afterwards. When you take a look, as mentioned, if you have, for example, 2 different disks, you get to create, if you want, 2 vSan Direct data stores. So it's 1 per disk. And if you look at the rest of the page, here they mention features. And notice the idea is simple. As you create these vSan Direct data stores, we get to manage them with the same utilities that we use to manage our regular vSan data store. So notice bullet number 1. It says vSan Direct extends the HCI management features of vSan to the local disks, which are formatted with VMFS. Remember, when you create a vSan Direct data store, that disk will be repartitioned, and the system will create not a regular VMFS file system. It's going to be a stripped down version of VMFS called VMFS-L. Some of you guys may remember that name from back in vSan 5.5. This is before we start to use vSanFS. Back in 5.5, we used to use VMFS-L for the file system for your vSan data store. Bullet number 2, vSan Direct manages and monitors disks formatted with VMFS and provides insights into the health, performance, and capacity of these disks. So again, you get to monitor those vSan Direct data stores with the same tools that we'd use for a regular vSan cluster. And if you take a look, bullet number 3 says vSan Direct enables users to host persistent services on a VMFS data store that is again managed as if it was your regular vSan data store. Notice lastly, it says it enables users to define placement policies and quotas for those particular local disks. So if you look at this page, here again, this page starts by saying vSan Direct use cases. And once again, let's keep it simple. You have the ability to create different types of vSan Direct data stores. And again, depending on the type of disk that you use, you could use some for your critical applications and others maybe with lesser drives for your secondary type of VMs. Notice, for example, here they mention use cases. Bullet number 1, it mentions application with high-end storage requirements. Notice again, they mention, for example, a MongoDB database type of workload. Then they mention applications with mid-range storage requirements. Once again, they have a couple of examples here. And then again, potentially also using some of these vSan Direct data stores for your, let's say, low-end type of workloads. So when we look at this drawing, all I want you to notice in this drawing is the reference to DevOps and also Kubernetes. So once again, I'm going to show you exactly what the vSan administrator would do. The rest would be done not by you necessarily, but instead it would be done by the Kubernetes person. So at the very top of this page, notice it says vSan Direct supports cloud-native applications running in a Vsphere 7x supervisor Kubernetes cluster. Other Kubernetes clusters are not currently supported. And again, the idea is if you have, for example, 5 disks, you get to create 5 of this vSan Direct data stores. So it's a 1-to-1 ratio. It's a 1-to-1 mapping. Notice these different data stores create what we call a storage pool. Now, when you look at this particular page, here, as we continue talking about the key concepts of vSan Direct, notice you always see the reference to Kubernetes. So when you look at the acronyms PV, remember they're talking about persistent volumes. So you can see references to cloud native storage control plane, first class disks, and besides that, storage policy-based management and vSan management services. So let's have some fun. This time, I have decided to mix the lecture with a demo. So in a second, I want to do a demo. And what I'm going to do is I'm going to start by deleting a disk group. As I delete the disk group, that will free up 2 drives. And then we're going to take a look at the command line. We're going to have a 5 gig and a 50 gig drive. These drives are going to be the ones that at one time were in a disk group. Let's take a look. The idea here is quite simple. If you want to play with this particular feature, you will quickly realize that you don't have any disks that you could use for this demo. So what you're going to have to do is you're going to have to take apart one of your existing disk groups. So let's take a look at what I have. For this demo, I will be using my second cluster. And if you take a look, I am going to select SB vSan 01. I am going to choose the option configure. And I am going to go to disk management. Now you typically create the vSan Direct file systems from here. But like I said, we don't have any disks available. Now typically what you would do is you would click on claim unused disks. But you can see again, I don't have any disks that I could use. So what do? In this case, I am going to delete the disk group for one of my hosts. I'm going to delete this disk group. As you can see here, this disk group has a 5 gig cache device and a 50 gig capacity device. Once I delete the disk group, then I have the choice to play with these 2 disks. So remember, you can create 1 vSan Direct file system per disk. So let's start by removing the disk group. In 7.0 Update 1, if you want to remove a disk group, you simply click on these three dots. Notice I will choose the option remove. Now I have the choice to move data around. Notice I have one virtual machine. That virtual machine is called Javier01. You have three different options. I'm going to go with full data migration. I don't have an operating system in that VM, so it's not like I have to move a lot of data. So once again, the first thing I'm doing here is I'm deleting an existing disk group simply because I don't have any disks to play with. Now this should take a few seconds. Let's take a look. Notice I can select recent tasks. I can wait a few seconds. And as soon as the disk group is deleted, then I can play with the 5 gig drive and the 50 gig drive. Now, in the meantime, one of the things that I can show you is that if I go to that host, remember that host is SB04, my vSan data store here will shrink. It's going to go from 200 gigs to 150 gigs. Now, as we can see here, the data store still shows 200 gigs. So once again, while I wait, I'm going to go to VMFS devices disks. And remember, this is the link to dev disks. With vSan, all the disks that I use in vSan typically have two partitions. So they typically have a very small partition, which is partition 1. That's for metadata. And then you have this partition, which is about 99% of the disk. Now you can see the disk group has been deleted. So when we take a look, first I'm going to type df-h. My vSan data store has shrunk from 200 gigs to 150. And if you take a look, notice the partitions are gone on both target 1 and target 2. Remember, these were the cache and capacity devices. Remember, a second ago, both of them had two partitions. You can see them right here, :1 and :2. Oops, :2. That's more like it. So, what I want to do now is I want to show you how to create a vSan direct file system. And as we were saying, you create those vSan direct file systems from here. Now, I'm going to click on claim unused disks. And when I do that, you can see the two drives available. So I'm going to start with one of them. Doesn't really matter which one. Now, if you take a look, the first one is 50 gigs. The second one is 5 gigs. So what I want to do here is I want to choose do not claim for the small drive. Ignore this warning for now. Now notice right now I'm getting this error because again, the system thinks I'm trying to create a disk group with only a capacity device. That's not the case. So what I want to show you here is that I choose not to use one drive. And when it comes to the 50 gig device, you can see different choices. I could choose cache tier, capacity tier. In 7.0 Update 1, we have a brand new choice, vSan Direct. So that's what you want to do. Now, as soon as you choose one drive to be a vSan Direct option, and the other one, again, do not claim, notice the error disappears. So what's going to happen is the system, the software, will take the 50 gig drive. It's going to partition the drive. But this time around, it's not going to create a vSan FS file system. It's going to create a file system, which in the GUI you will see vSan Direct. But we've mentioned it's VMFS-L underneath. And that drive will only have one partition. Let's take a look. I'm going to choose create. Notice it says done, completed. Now what I'm going to do here is I am going to expand this. And as you can see here, when it comes to SB-ES6i04, notice again, I don't have a disk group, but I have that new entry called vSan Direct Disks. It says 1. And if I select that, you can see which one that is. You can see that is my 50 gig flash device. Now, let's go to the command line for a second. if you take a look, first, I want to type ls. Notice I use target 2. And notice when it comes to target 2, I only have one partition. I no longer have 2. Now that's because, again, this is not a typical vSan disk. Again, this drive was formatted differently. Now, the next thing I want to do, I want to type df-h. And notice that here, you will see the new entry. Notice in the command line it says vSan uppercase D. You can see the drive is 50 gigs, roughly speaking. You can see how much space I have already used. That's for metadata. And you can see the mount point. Once again, all the mount points in Vsphere start with VMFS volumes. Notice you have this whole entry. So notice it says VMFS volumes. Then it says vSan direct. Then you see the name of the host. And then you see the name of the disks, which again is controller 0, target 2, lon 0. Now, if you take a look, I'm going to go to the storage view. And when I go to the storage view, you can see the same thing here. Once again, when you go to the storage view, you can see the presence of your typical file systems, both VMFS, potentially NFS, potentially vSanFS, and also data source for vVols. Here you see now there's a new entry, and this one is vSan direct. When I select this one, here notice you will not see VMFS-L. So on the upper left, you see vSan direct. On the upper right, you see the capacity. And you see the reference to this tag. Remember, I didn't create the tag. I didn't assign the tag. This happens automatically. So again, that's all it takes to create a vSan direct file system. The rest, once again, will be pretty much up to the Kubernetes person. So one more time, if you want to create another one, what did I do? Number one, I freed up some disks. Number two, I went to my cluster. I selected configure. I went to disk management. And once again, I scrolled down. I found my host. Remember again, this host is SV04. I still have another drive available. And if you take a look, what I'm going to do is I am going to do it one more time, this time using the 5 gig drive. I'm going to claim unused disks. I should see only one drive. That's my 5 gig drive. I am going to choose once again vSan direct. And again, that's all it takes to create a vSan direct file system. So this way you can monitor these vSan direct file systems using the typical vSan tools. Hopefully again that demo helped. I'll see you back when we go back to the book. Let's create a file system. Let's verify that everything is fine. And let's proceed. Let's take a look. Once again, I'm going to scroll down. I click on vSan direct disks and I see 2. If I go back to the command line, I should see, once again, 2. One is 5 gigs, one is 50 gigs. Notice, there they are. Thank you. And let's go back and finish the chapter. Thanks. Now, when you look at this page, here they're showing you the responsibilities of each person. I'm talking about my responsibilities as the vSan administrator and potentially the responsibilities of the Kubernetes person. Now, if you look at the very top of the illustration, once again, all I have to do is provision a vSan direct data store. Obviously, I need to have disks available for this. And then I need to, again, create namespace and assign vSan direct storage policies. The rest, once again, wouldn't be up to me. You can see that the other person would be in charge of claiming persistent volumes with vSan direct storage pools. And again, he would be the one consuming the actual space and persistent service. Now, when you take a look, what they show you here is exactly what I just did. So once again, I showed you how to create the vSan data store. I'm talking about the vSan direct data store. And again, you get to see it alongside your distros and your cache and capacity disks. Once you actually take a look at the very bottom, you can select the reference to that vSan Direct data store. And then again, at the point, you can see which drive was used for that vSan Direct data store. Now here, you have a better picture compared to what you saw before. So once again, when you look at the very bottom, you can see in this case that we have one and only one vSan Direct disk being used. Once again, you saw in my demo that if you select that, you could tell exactly which drive we're talking about. I showed you this as well. So again, I didn't create that tag. I didn't associate it to the vSan Direct data store. This happens automatically. So every single one of your vSan Direct data stores will be assigned that tag that you see there. Once again, the tag is called vSan Direct. And if you take a look, one of the things that you could do is go to the homepage of the Vsphere client. And then at that point, you could take a look at your existing virtual machine storage policies. Once again, here we're talking about tag-based placement rules. On that note, here you have another screenshot where you get to see which drives you could potentially use for a vSan Direct data store. And again, if I choose a particular policy for this, then again, if I click on storage compatibility, I would be able to see all of the drives that were configured for vSan Direct. When it comes to capacity reporting, just like you can actually select your cluster and go to monitor and click on capacity and look at how your vSan data store is being used, same thing applies to your vSan Direct data store. So when you take a look, notice, I'm going to see if I can highlight this. No, you can't do that easily. The idea here, if you notice where the mouse is, you can click on vSan Direct. Once again, you can see attributes about that particular data store and how it happens to be used. On that note, that concludes this particular module. Thank you and enjoy the break. We have one more lesson to go. And again, that one is about file services. Enjoy the break. Thank you. Okay, guys, welcome back. It's time to cover the last module of this class. And as you can see, this module is called Native vSan File Service. I mentioned earlier that this is not a new feature in 7.0 Update 1. This was actually introduced in 7.0, but it was enhanced in 7.0 Update 1. And if you take a look, here what we're talking about is, in a nutshell, having a brand new type of object, which is going to be shared with non-cluster members using different protocols, such as NFS and or Samba. As you can see here, it says you can use vSan File Service to create file shares in the vSan data store. So just like in the past, in 6.5, as a matter of fact, we introduced iSCSI capabilities. Now we have NFS and Samba capabilities. Remember, we're talking about creating shares. These shares realistically are going to be objects. And these objects are going to be controlled by appliances, but not really by the appliance itself. Inside of the appliance, you're going to have containers. Notice it says data stored in the file shares can then be accessed from various supported clients over a TCP/IP network. So what we're talking about is potentially having other machines like Unix machines, Linux machines, or for that matter, even Windows machines. And again, these non-vSan cluster members are going to be the clients, and they will be able to access your shares. Now here we have the goals of Module 11. And once again, over the next few minutes, I want to talk about this particular feature. I want to talk about how it was introduced in 7.0, how it was enhanced in 7.0 Update 1, and I'm going to do two demos. In those demos, first, I'm going to show you how to configure the appliances. Now, the appliances will take a while to configure. The second part will show you how to create a share. We're going to look at the attributes of the share. and then I'm going to show you how to mount it from another machine. As you can see here, we have a series of goals. And once again, in this case, I am going to show you how to do all this using the Vsphere client. So let's take a look at this particular page. If you take a look at this page, once again, on the upper left, they tell you what this is for. And I've already mentioned, we're talking about creating NFS or Samba shares and make them available to non-vSan cluster members. So again, just like we did iSCSI in 6.5, now we have an alternative to that. Now, when you take a look at the illustration, you can see that the clients could be potentially different types of machines. So notice, for example, in one hand, the client could be some kind of VM using the NFS protocol. Notice it could also be a physical server, or for that matter, again, this could also be used by Kubernetes. So when you take a look, in this page, they also mention the concept of VDFS. And as you can see in the middle of the page, it says vSan file service is based on the vSan distributed file system. So we're talking about having, in this case, 4 appliances. That's because we have a 4-node cluster, which are going to be inside, controlled by containers. The containers are actually doing all the work. One of the things to understand is that these appliances will never be migrated. You don't get to choose the number of CPUs or the amount of memory. You don't want to muck around with them. Basically, they are controlled by the EAM service. So let them be. If, for example, you put a host in maintenance mode, that appliance will not migrate using something like vMotion. It will shut down instead. But the actual container inside will be migrated elsewhere. Because remember, every object always has an owner, and this is no different. When you take a look, once again, I will show you how to do this lab. And again, remember, the lab will take about an hour. So when you look at the illustration, here you can see that if you have a 3-node cluster, you're going to have 3 appliances. In my case, I have a 4-node cluster, so I'm going to have 4 appliances. Each appliance, you can see the reference to Docker. Obviously, again, each of these appliances will be in charge of X number of shares. Now, I'm only going to have 1 share, but you could definitely have more than 1. And as mentioned, the idea here is quite simple. The shares are controlled by the actual container. If you have a problem with a container, somebody else will become the new owner. And I'm going to show you how you can tell using the Vsphere client. When you look at this particular page, once again, after you deploy the appliances, you get to specify how many shares you want, what is the protocol to use, and in 7.0 Update 1, you could, if you want to, use Kerberos as well. So if you take a look at this page, you don't get to choose which appliance is in charge of which share. This again is controlled automatically. The system is always trying to optimize performance. And again, when it comes to where exactly the share is going to be, remember, this is an object. You get to choose the policy of the object. And push come to shove, you don't know exactly, unless you look, of course, at the Vsphere client, where everything resides. You don't choose the individual disk. Now, I've mentioned before that this is controlled by appliances. So these appliances get installed via OVF. And again, that's going to be the first part of my demo. So notice, these appliances are running our version of Linux. I'm talking about Photon Linux. And notice the maximum number of appliances that you can have is 32. So if you have theoretically a 64-node cluster, you're going to have a maximum of 32 appliances. It's always 1 per host to a maximum of 32. Now, when we look at this page, here you can see the dimension in the left side of the illustration, OVF. Now, these appliances are going to be deployed via OVF. And when you start this up, you want to make sure you remember to take care of the NS. Now, in my demo, I'm going to have 4 of these appliances. I'm going to specify the IPs. I'm going to click on an icon called autofill. So that way I don't have to type all the IPs in a row because again, they're going to be sequential. But then instead of typing the names, I am going to again, just simply tell it to look up DNS. And because we've taken care of DNS, you will see automatically all the names will be mapped to those IPs. When it comes to those OVF packages, you could try to get all the software over the internet, but instead here, we have prepared a folder that you can see from your desktop. That folder has 6 files. Those are the 6 files that you need in order to deploy those appliances. When you look at this particular page, if you take a look at the policy that is being used by these appliances, this particular set of appliances uses a policy called fsvm_profile_do not modify. You don't want to change that particular policy. And again, that policy, notice, says this appliance is not going to be redundant. So in a nutshell, it's going to be what? Rate 0. It's not going to be striped. So number of disk stripes is 1. It's not going to have an IOPS limit. But again, this appliance will not ever migrate elsewhere. When you take a look, the first thing you'll have to do is enable the service. And as you enable the service, what you're going to be doing is you're going to follow a wizard. And you're going to have to specify, for example, who is your DNS server. You're going to have to specify the IP of the gateway. You're also going to have to specify the IPs of the appliances. And once again, you have to take care of DNS ahead of time. So when you take a look, the book will tell you exactly what you need to input. Having said that, at any given time with the Vsphere client, you can see what you actually have. Now, one of the things that you need to specify is the name of what they call here the domain. This is your vSan file service domain name. And notice at the very top of the page, it says a vSan file service domain is a namespace for a group of file shares with a common networking and security configuration. So you just got to come up with some kind of name. And when it comes to the network, the appliances need to be connected to a particular port group. So just like in this illustration, the appliances will be connected to the port group called VM network. It is imperative that you connect them to the right network. Otherwise, you will not be able to interact with your NFS client. And in this case, the NFS client is going to be your desktop. Here you can see the IPs that we're going to use. So the IPs are going to be 172.20.10, 100, 101, 102, and 103. And those are the names that automatically will be populated because, again, we've taken care of DNS ahead of time. Now, when you take a look, here's what you expect to see. If you are in hosting clusters, you expect to see a resource pool. And inside of the resource pool, you will have 4 appliances. Notice carefully here, you're looking not at hosting clusters, but you're looking at virtual machines and templates. So here you don't see the actual pool. Here you see a folder. Now again, make sure that you don't change the attributes of the pool. Make sure you don't change the attributes of the VMs. In my demo, I will show you some of those attributes. But again, if you try to change them, the system will complain. And it will warn you that, again, these appliances are not for you to muck around with. Now, when you take a look, the idea here is once we have everything in place, we want to create shares. And as you can see here, you have different choices. I am going to choose file shares. And again, when it comes to file shares, you can choose different versions of NFS. Once again, we support version 3 and version 4.1. But besides that, remember, you could also use Samba. In the lab, we're going to use NFS. So the way that you do it, you select the cluster, you go to configure, you go to file shares, and you click on add. You specify the type of share that you want to have. And then what you're going to do is you're going to come up with a name, specify the protocol, whether you want both NFS version 4.1 and 3 or just one of them. When it comes to 4.1, you could choose different types of security, for example, Kerberos. And when it comes to the policy, I'm going to go with a two-way mirror. Now, the share, I'm going to make it very small. It's going to be about 5 gigs. So you get to choose how big the share is going to be. And you also get to choose a share warning threshold. So for example, I can say, you know what, my clients can use up to 5 gigs, but I want to get a warning once we exceed 4 gigs. So I'm going to go with those values, 4 and 5. And if you take a look, remember, as you create a share, we're talking about the NFS protocol. You get to choose who is going to be a valid client. As you can see in this illustration, you can choose different options. You can say no access. I'm not going to use that. Instead, I'm going to use allow access from any IP. That means anybody potentially could mount the share. You could also be more specific. As you can see here, the third choice allows you to specify whether, again, you want to have just one NFS client or, again, potentially a subnet. So you could be very specific or fairly generic. Now, when you take a look, here you can see that with the Vsphere client, you could click on copy path. And what this would allow you to do is it would allow you to, again, make it very easy for you to remember exactly what you have to do from the client side. So all this is going to be shown in the demos. Now, when you take a look here, you can see that we're selecting the actual cluster, but we're changing from configure to monitor. So when I take a look at monitor here, notice I'm going to performance. And in 7.0 and 7.0 update 1, not only again you have the choices for example, VM and backend, but we have a new choice, again, called file share. And you can see all sorts of performance related information. You can see here the time range is 1 hour, but again, you can change that as well. And if you take a look, when it comes to Skyline Health, formerly known as the health service, you have a series of new tests related to file service. I'm going to show you again all of those 3 choices. You can see they're called infrastructure health, file server health, and share health. So for example, you can see whether or not your share is healthy or not, whether maybe you have a problem with one of the components, or again, maybe you have a problem with one of the appliances, and so on. And if you take a look, here you have certain things that you may want to remember. Now, let's go through the bullets. Here it says vSan file service considerations. Number 1, only IPv4 is supported, and static IPs are required for the appliances/containers. Notice you can have up to 32 file shares. Again, here in class, we're going to do 1. And when you take a look, you can see it says each host in a vSan cluster should have a minimum of 4 CPUs because your appliance in 7.0 update 1 will have 4 virtual CPUs. Make sure that when you do this lab, that you do it on the first cluster because my memory doesn't fail me. The second cluster has hosts with only 2 logical CPUs. So you need to do this in the first cluster, not the second one. And if you take a look, this is not for stretch clusters or for that matter for 2-node clusters. Again, you need 3 hosts minimum. And again, here in class, we use 4. So when you take a look, in a minute, we're going to take a look at the first part of the demo. So remember, there's going to be 2 demos. When you do the lab, which is lab 15, which is your last lab, remember, this lab will take close to an hour. So the first thing you need to do is you need to enable this feature, configure the appliances, then probably take a 15-minute break. Once the appliances are ready, what you want to do next is you want to create a share, and then you want to test it. Hopefully, again, you enjoy the demos. And again, hopefully, everything is great when it comes to the lab. So I'll see you in my demo. Thanks, guys. Have fun. Okay, guys, welcome back. It's time for another demo. And what I want to do next is I want to show you how to configure file service. This feature, as mentioned earlier, was introduced in 7.0, but it was enhanced in 7.0 Update 1 as we mentioned in the lecture. So I'm going to show you what you're going to be doing in Lab 15. You need to understand that this lab will take close to an hour, and you want to be patient. This demo will be split into two halves. In the first half, I'm going to show you how to configure the appliances that control the NFS shares. Now that, of course, will take a while. We're talking about deploying 4 different appliances, 1 per host. Remember, we have a 4-node cluster. So deploying those appliances from OVF will take a while. At that point, I'm going to stop the actual demo, and then we'll pick it up once those appliances are ready to go. At that point, I'm going to show you how to create 1 NFS share. I'm going to show you how it works. I'm going to explain the concept of the containers inside. And then we're going to mount that particular data store, that share, I should say. Bottom line, in the lab, the only difference, you will use your Windows desktop as an NFS client. To save time, to do something a little bit different, I'm going to take another ES6 server, one that is not a member of that cluster, and I'm going to show you with one simple command how to mount the NFS share. Please remember what we mentioned in the lecture. You can set up NFS shares using either NFS version 3 or 4.1. And also remember, you could also use Samba. And in my demo, I'm going to use NFS 3. All right, so let's talk about the first part. When you take a look at your lab book, the lab book will tell you, number 1, to go to your cluster. And when you go to your cluster, you want to go to the Configure tab just like I've done. You can see here, you're going to choose Services. And right here, you can see that, of course, this service is not enabled. Notice if I go to File Service, you can see it's disabled. And of course, the idea here is to enable it. So that's the first thing you're going to be doing. Now, at this point, you're going to click on Next. Now, you have 2 choices when it comes to deploying the appliances. In class, we're not going to be fetching the data over the internet. Instead, we have the files that you need in a folder. The book will tell you, of course, the location of the folder. So what I'm going to do is I'm going to choose manual approach. Typically, this is, of course, what you use. If, let's say, your vCenter is not connected to the outside world, you're going to click on Browse. Now, in your desktop, let me show you this. You actually have a folder called Class Materials. If I go to Downloads, here you have a folder. You can see the name ends with OVF. So here's what you have, the 6 files. You're going to need all 6 files. So let's go back to, not that, let's go back, of course, to the browser. We're going to click on Browse. And then at that point, once again, I'm going to go to the desktop. I am going to click on Class Materials. I'm going to choose Downloads. I'm going to select the folder for OVF. And I am going to select all 6 files. Like I said, it will take a while. I'm going to click on Next. Now, the idea here is you don't have to always have 4 appliances. Here is going to be 1 per host. So because I have a 4-node cluster, you better believe we're going to have 4 appliances. Please remember, these appliances will not be vMotion. If you put the host in maintenance mode, the appliance shuts down automatically. When you take the host out of maintenance mode, the appliance starts automatically. These appliances are not for you to manipulate, to manage. They're managed by a particular service within Vsphere. Now, we've mentioned the name of that service in the lecture. So if you take a look, in a few more seconds, the system will ask me a few more questions. I'm going to show you the PDF, which is the equivalent of your ebook. And we're going to take a look at exactly what you have to do. Remember, this is the first part of that particular lecture, or that particular demo, I should say. So let's take a look. Once again, this will take a while. So it's almost ready to go. And what I'm probably going to have to do is I'm going to have to put my glasses, because I want to make sure that I don't make a mistake. So sometimes you'll see me use my glasses. It's called getting old. So let's take a look. Once again, we're going to wait. Remember, I was saying that these appliances do not give vMotion. What happens is, because you're dealing with objects here, after all, an NFS share is going to be an object. The object will be controlled by a container inside of one of those appliances. So if I put a host in maintenance mode, and it happens to have the appliance with the container that controls that share, that container, in quotes, will move onto another appliance. As you can see, I've mentioned again, this takes a while. So we're going to keep waiting. And again, it should be ready to go in a few more minutes. I guess in the meantime, what I could do is I could show you the PDF. Never mind, it's pretty much ready to go. So let's take a look. Here you can see that you get to answer a few questions. Now at the very top, notice it says, what is the name of your file service domain? Now let's take a look for a second at the actual PDF. You can see I have the book ready to go. And when you take a look, I'm talking about task number 2. So we were able to find the 6 files. And then obviously at this point, we're going to come up with that file service domain. It's going to be vclass.local, same as the DNS suffix. And again, our DNS server is 172.20.10.10. So very carefully here, I'm going to type vclass.local. Once again, the IP of my DNS server is 172.20.10.10. When it comes to the DNS suffix, we mentioned we're going to use vclass.local. And when I click on next, here, notice you have to select number 1, a port group that you're going to be using for these appliances when it comes to the network. We're going to use VM network. Now, it is important that you use that port group. If you use another port group, then the problem is you're going to have connectivity issues. Now in class, we always use class C. So this is going to be 255.255.255.0. And when it comes to the gateway in class, if I'm not mistaken, I'm going to verify it should be .10. Now let's take a look. It should be the same IP. There we go. As our DNS server. So if we go back again here, we click on next. And now the book will tell you what are the IPs of the appliances. And notice you see 4 entries because again, I have a 4-node cluster. So if you take a look, we're going to use 172.20.10.100. Then we're going to click on autofill. The numbers here are going to be sequential. And you need to take care of DNS ahead of time. So I'm going to click on lookup DNS. Notice, when it comes to DNS, the names for these machines, for these appliances, are going to be FSVM 01, 02, 03, and 04. Now we're going to click on next. And as I mentioned, I'm showing you the first part of your actual lab. We're going to click on finish. Now what we want to do is we want to wait a few seconds. And what you're going to notice is that a resource pool gets created automatically, as you can see on the left margin. That pool is called ESX-agents. And when you take a look, I expect to have there 4 appliances by the time I'm done. Now again, this part will take probably 15 minutes or so. So I would recommend that as you do the labs, instead of waiting here and sitting looking at this, perhaps this would be a good time to take a little break. Now that concludes the first part of the demo. I'm going to wait about 15 minutes. Then I'm going to show you the second part. Remember, the second part will start when I create the NFS share. And then again, I test it by using another machine to mount that share. Hopefully, again, this helps you understand what you're about to do. I'll see you in a few minutes. Have fun. Okay, guys, welcome back. This is the second part of the demo. As you can see here, about 15 minutes have gone by, and now I have 4 running appliances inside of my first cluster. Remember, before I started this demo, you did not have that pool called ESX agents, and you did not have those appliances. So at this point, pretty much I'm ready to go. But what we want to do is we want to take a look at certain attributes and show you some of the things that I've mentioned in the lecture. Now remember, the second part of the lab is quite simple. What you want to do here is you want to select your cluster. You want to go to configure and you want to choose file shares. Now creating the share takes about a minute, not even. So let's take a look. Now here you see different choices. Now I'm using the dark theme. It's a little easier on my eyes. So you can see, for example, you can choose container file volume, vSan file share, and again, you have this other option called all. So I'm going to go with vSan file share. I'm going to click on add. And when I click on add, remember, you're going to come up with some kind of share name. So I'm going to call it share 1. Now, if you take a look, when it comes to the protocol, again, I'm going to choose NFS. But here, you can see again that you could choose NFS 3 only, NFS 4.1 only, or both. Now, unlike the book, I'm just going to choose NFS 3. I've mentioned that this is really an object, and the object needs a policy. By default, the object will be a two-way mirror, and that will do the trick just fine. What I want to do next is I want to choose 2 values. Let's start with the size of the share. Remember, with NFS, you're really sharing a folder. And if the disk underneath is huge, you're technically sharing all the space, but we want to put a quota. So we want to make sure that nobody can use more than 5 gigs. Now, we also want to be warned if we're running out of space. So when it comes to share warning threshold, I'm going to choose 4. These are not exactly the same values we use in the book. It doesn't really matter. And you could also use labels. I'm not going to use that. When you take a look, here I get to dictate who can use this. And I want to keep it simple. Not necessarily the most secure environment out there here, but this is education, this is class. So I'm going to say allow access from any IP. And at this point, I'm going to click on finish. Now, remember, you can have up to 32 shares. Here, I'm only going to have 1. I could show you, of course, more than 1 if you want. So again, we want to wait a few seconds. And if needed, we want to monitor what's going on right here. Notice again in the recent tasks, it's almost ready to go. So there's my first share. And if you take a look, at any given time, you can select the share. You could modify it. So you can modify any of those values. Or again, you could delete it. Now, if I click on edit, I'm not going to change anything. Here you can see that again, you can change any of the values, or for the matter, the protocol that you use. When it comes to delete, I think that is self-explanatory. And if you take a look, we talked about copy path. Now, before I mount the share from a non-cluster member, let's take a look at a couple of things. What I'm going to do here is I'm going to pick randomly one of these hosts. And what I'm going to do is I'm going to take that host and we're going to choose to put them in maintenance mode. Remember, these 4 appliances are running 1 per host. So if you take a look, the appliances will not be migrated. The appliances instead will shut down. I've mentioned that in the lecture. So let's take a look at what happens. First, if we have other VMs, which we do, they need to be moved via DRS. Now, I went with ensure accessibility to speed this up. But if you take a look, one of the appliances is already down. So the appliance shuts down automatically. Again, it does not get migrated. You can see the server goes into maintenance mode. Now, if I take the host out of maintenance mode, then obviously things will change. And again, I expect that appliance to power on automatically. Remember, you don't boot them up, you don't power them on, you don't power them off, you don't touch them. Now let's take a look. Let's wait a few seconds. And again, I expect that appliance to power on automatically. So while I wait, I'm going to right click on the VM and I'm going to choose Edit Settings. I want you to notice what happens. If you take a look, you're going to get a warning. And again, you're not supposed to touch these appliances. Now I'm going to click on Yes. And if you take a look, I just want to show you the specs of these appliances. Notice these appliances, they have 4 vCPUs each in 7.0 Update 1, and they have 8 gigs of RAM. Notice they also have a series of disks. So again, we're not going to change them. Notice by now, that appliance has booted back up. Now, let's take a look at the rest. So here's what I'm going to do. You can see that I have set up this configuration, this feature in my very first cluster. Remember, in the lab, who is going to be your client? Your client is going to be your Windows desktop, the gray desktop. Now, I'm going to do a little bit, I'm going to change this a little bit. So let's take a look at what I'm about to do. Let's see if I remember how to do this. When I was doing the beta class, I was explaining to other people, including other instructors, that if they want to do a quick demo, they could theoretically go to another ESXi host, one from a different cluster, and they could test it from here. So instead of using Windows, which is what you get to do in the lab, I'm going to show you that another ESXi host can theoretically mount the share. Now, this is not what this was devised for. But again, this is just a quick demo. So let's take a look. If I choose copy path, once again, remember, I chose NFS version 3. Now, you can see here that the folder, right, is basically what? Share 1. That's what I called it. So let's take a look. Let's see if I remember how to do this. I am going to type ESXCMG-NAS-L. Remember, this host is in the other cluster. So this is going to be my guinea pig. This is going to be my NFS client. So instead of using Windows, which to me, again, it takes a while, I am going to try to do it with the command line on that host. Now, what I'm going to try to do here is, if you remember, here we can see who the server is. Notice it says FSVM01. Well, that would be a typo. So let's take a look. What I'm doing here is I'm saying I want to add an NFS share. The name of the share, in this case, is going to be NFS1. I'm going to specify who the server is. And then I'm going to say, what is he sharing? Now, let's see if I remember how to do this. I am trying to specify here that the share is called share1, the folder. And let's take a look. There it is. Guys, it was fun. Enjoy.